Hey there, thanks for clicking on this video. This series is all about D365 finance and operations development, right? And it's basically built around MB-500 certification preparation. Now, before we jump in, let me just quickly tell you what you're getting into and what to expect so you can figure out if this is the right fit for you. All right. So, what is this series about? It focuses on explaining concepts, things like architecture, development patterns, extensibility, security, all the core topics you need to understand. Now, it's organized around certification preparation. If you're looking for hands on step by step tutorials where I'm clicking buttons and walking through screens, there are other videos on this channel for that. This one is more about, let's say, walking through the concepts themselves so you understand what's happening and why things work the way they do. Okay. Now, here's what this isn't actual exam questions. I can't share those, it's not allowed. What this actually is, it's structured notes from my own preparation when I took the exam back in June. So I went through a lot of material, a lot of questions, a lot of explanations, and I organized everything in a way that I think is easier to follow. So it's inspired by that preparation, but there are no direct exam questions here. Okay. The thing is, when you understand the concepts properly, you can handle different variations of problems. So who is this for? Well, if you're preparing for MB-500, you'll find this useful. If you're new to D365 finance and operations and you want to understand the fundamentals, this covers that. If you're already experienced, but you've got gaps in certain areas, uh, this can help fill those in. And if you just need structured revision of the core concepts, yeah, this works for that too. So what will you get from this? Explanations of how D365 finance and operations actually works. The concepts are broken down so they're easier to grasp. Now, what you still need separately hands on practice in actual environments, practice questions from other sources, real scenario work. This series covers the conceptual side of things, right? The practical side, you need to do that yourself. Now, one important thing, especially if you're experienced, as we go through the material, you might come across things that seem overly emphasized or even obvious, like, don't overlay, extend instead, things the system actually prevents you from doing anyway. Here's why that happens. This content is directly inspired by certification preparation. The exam focuses heavily on certain principles that Microsoft wants you to know, even if in practice, the system guides you automatically. So sometimes I'll stress things that might feel unnecessary to someone who's worked in the system for years. It's not about doubting your experience, it's about making sure the concepts are clear for the exam context. Just wanted to mention that upfront. Okay. All right, now that you know what to expect, let's talk about how this entire series is actually structured. Okay, understanding the organization is going to help you navigate and really get the most value from each topic we cover. So, this series is organized into major modules. Each module contains multiple topics that build logically on each other, right? The progression moves from foundational concepts all the way through to operational concern. You can watch it end to end if you want that comprehensive understanding, or you can use the timestamps to jump directly to specific areas you need to focus on. Okay. Okay, so module one is all about architecture and methodology, right? These are really the foundational concepts you need to understand first before we dive into anything else. So, what are we talking about here? Well, we are looking at deployment models, how the system actually gets deployed in the real world. Project methodology, basically how projects are structured and managed. The LCS workspace, which is kind of your central hub for everything. Integration patterns is how different systems connect and talk to each other, right? And then extensibility principles. I mean, this is basically the philosophy of how to customize D365 safely without breaking things. So yeah, that's module one. Now, module two, um, this is all about how code is organized and managed. So let me quickly explain what we're covering here. Models, packages, and layers, these are what structure your code, okay? Version control is what keeps the entire team working together without, stepping on each other's toes. And then build pipelines, right? These automate the compilation and deployment process. So basically, this module makes sure your code is properly organized, tracked, and deployed the right way. Module 3 focuses on data and code fundamentals. So let's break this down. EDTs define your data types, tables organize your data, Indexes, these optimize your queries so things run faster. Relations connect different entities together. And then we've got X++ programming, which covers the language syntax, object-oriented principles, and proper data manipulation techniques. Like this is really where you build the solid foundations for everything else that comes after. Okay, Module 4 covers advanced extensibility, which is the modern way to customize D365, right? So what does this look like? Well, class extensions through chain of command let you add behavior to existing classes without actually touching them. Event handlers let you respond to specific events in the system. Table and enum extensions let you add fields and values where you need them. This keeps your code safe when Microsoft releases platform upgrades. Very important concept. Module 5 is all about user experience. So let's talk about what that means. Form patterns ensure consistency and familiarity across the interface, so users aren't confused. Controls provide the actual interaction points. Menus and navigation, um, these guide users through the system. Workspaces provide role-specific dashboards tailored to what people actually need to see every day. Tiles show live KPIs right where people can see them. And personalization, right? This lets users customize their own interface the way they like it. So together, all of these create professional user experiences that people actually want to use, not just have to use. Module 6, okay? This covers integration and data management. So what are we looking at here? Data entities expose your data for external systems to consume. DMF handles bulk imports and exports efficiently. Very important for moving large volumes. OData provides real-time REST API access when you need it. Custom services, these expose your business logic to other systems. Asynchronous patterns handle those high volume scenarios that would otherwise bog things down. And Power Platform connectivity integrates with the broader Microsoft ecosystem. So yeah, lots of integration options here. Module 7 focuses on reporting and analytics. Now let me quickly go through what we're covering. SSRS reports provide detailed analysis when you need to dig deep into the data. Electronic reporting, or ER, enables configurable documents that you can customize without writing code. Aggregate models power those live KPIs everyone wants to see. And embedded analytics, right? These bring insights directly into your forms and dashboards where they're actually useful. So this module helps you understand how to present data in ways that actually drive better decision making. Not just generate reports for the sake of reports. Module 8 covers security, testing, and operations. Okay, so role-based security controls who can do what in the system. XDS policies, um, these filter data at runtime based on who's accessing it. Very powerful stuff. Unit testing with SysTest ensures your code quality stays high. Workflow automation routes documents through approval hierarchies automatically, so people don't have to manually push things around. And performance monitoring keeps your systems running smoothly in production. So basically, this module is all about operational excellence and making sure you're production ready, right? Not just development ready. Now, each topic we cover follows a consistent structure. Okay, so what does that look like? Core concepts are explained clearly, and not just the what, but the why behind them, right? Why does this matter? Comparison tables help you understand when to use different approaches and why you'd pick one over another. Best practices show you the professional way to do things. And anti-patterns, these highlight those common mistakes you want to avoid making. So you're learning what to do and what not to do. How you use this series really depends on what you need, guys. So let's say you want comprehensive understanding, you can watch it end to end for the complete platform picture. Or maybe you need something specific. You can use timestamps and jump straight to modules you want to focus on, right? Or you can mix both approaches, get that comprehensive foundation first, then dive deep into the areas that are most relevant to your actual work. So it's pretty flexible. All right. So you now have the complete roadmap. You understand how everything is organized. You know what each module is going to cover. You're ready. Okay. Let's start with the first module, architecture and methodology. This is where the journey really begins. We are beginning with the foundation, architecture, and methodology. So think of this as looking at the blueprints before you start construction. We need to understand where the system actually runs, how we organize the work, and how different systems connect to each other. Everything else we build is going to rest on this foundation. So let's dive in. Okay, so first question, where does your D365 system actually run? You've got two main choices here. Cloud deployment means Microsoft manages the servers for you. You know, they handle all that infrastructure. On premises means it runs on your own servers in your own building. Now, the software looks and works the same either way, right? But there are specific features that differ based on which deployment type you choose. Understanding these differences is critical when you're making design decisions. Here are the practical differences you need to know, okay? So in the cloud, you get business process modeler and task recorder. Because they rely on cloud APIs, you get SharePoint integration for document management. But here's the trade-off. You can't directly access the SQL database. You have to go through the platform's APIs. On-premises is the opposite. You have direct SQL access, which is incredibly powerful for reporting and analytics, but you don't get those cloud-only services. So basically, you choose based on what matters most for your specific situation. Next question, how do we actually organize the work? So waterfall is the traditional step-by-step approach, right? You finish phase one completely, then you move to phase two. It works great if your requirements never change. But here's the thing, software requirements always change, okay? That's where Agile comes in. You work in short cycles, get feedback, adjust as you go. Now, for ERP implementations, Agile is usually the right choice because requirements shift as the business actually sees the system in action and starts understanding what they really need. Makes sense, right? To manage all of this, we use Lifecycle Services or LCS. So think of LCS as your command center for the entire project. Okay, it's where you track project health, manage your different environments, request support from Microsoft. It also connects directly to Azure DevOps, which is where the development team tracks their daily tasks and work items, right? So here's how it works. Project managers live in LCS, developers live in DevOps, but the systems talk to each other. Here's the reality. No system lives in isolation, right? Your D365 needs to talk to your website, your warehouse systems, payroll providers, and countless other platforms. We call this integration. So your data is constantly moving between these systems. And here's what's important. Different data has different requirements, okay? Sometimes you need to move massive batches overnight. Sometimes you need instant real-time updates. So basically, different scenarios require completely different approaches. You can't use the same tool for everything. Okay, so think of data like cargo, helps with the analogy. For large loads, like importing 10,000 orders every night, you use batch jobs. Think of this like a cargo truck, takes time to load everything up, but it can move massive volume. For instant updates like checking a price or updating inventory in real time, you use OData. That's like a motorcycle courier fast and perfect for single items. But here's the problem. If you try to push an entire warehouse worth of data through OData, the system's going to throttle you and time out. So you've got to use the right tool for the job. Okay? When you're bringing in that heavy cargo, here's a rule. Don't dump it straight into the clean house, right? First, put it in a staging area where you can inspect it. We call this a staging table. You import your raw data into the staging table first, then you validate it, check for errors, make sure everything looks right. Okay. Only if it's clean does it actually move into the main system. This protects your database from getting corrupted by bad data. Staging tables are absolutely fundamental to building reliable batch processes. Very important concept. Finally, let's talk about extensibility, how we actually customize D365. Okay, so the old approach was something called overlaying. Developers would directly rewrite Microsoft's code to add their customizations. Here's the problem with that. When Microsoft updates the product, your changes conflict with theirs and upgrades break, right? The modern approach is extensions. You layer your customizations on top without actually touching the original code. The original stays clean and updatable. Your customizations stay separate and safe. So this is how we customize D365 today. Much better approach. Okay, so let me give you a real example of this. Let's say you want to add a new field to a standard table. What you do is create a table extension, which is basically a separate object that builds on top of the original without actually touching it directly. So you write your code and that's great. But here's the thing, you're not done yet. Okay. You absolutely have to sync the database. This is how you tell SQL that, hey, this new column actually exists now. If you skip this sync step, right, your code's going to try referencing a column that SQL doesn't even know about. And that's when everything crashes. So remember, always sync after making schema changes. This is very important. Now, when you're extending forms, you really need to follow the established patterns. Think about how a standard form is structured, right? You've got an action pane at the top for your commands, a navigation list on the side for filtering, a list grid showing your records, a details header displaying key information, and details tabs where users actually edit things. These patterns exist for a reason. You know they create consistency and make sure users feel at home in the interface. So when you're adding new fields or features, stick with that same structure. If you break these patterns, you're going to confuse users. All right, let's recap what we just covered in this topic. So your deployment choice, whether you go cloud or on-premises, that actually determines which tools are available to you, right? We talked about how agile methodology is really the right fit for software development because let's face it, requirements are always changing. LCS is your command center. It's what connects all the pieces together. For integration, remember to use batch jobs when you're dealing with high volume data and OData when you need instant updates. And here's the big principle we keep coming back to. Always extend the platform, never modify it directly. These foundations, they support everything we're going to talk about moving forward. Next up, we're looking at how code is actually organized and deployed. Welcome to the next topic. So now we understand where our system lives and how we'll manage the project using LCS and Agile principles, right? But here's the new challenge we're facing: organizing the actual code. Dynamics is absolutely massive. We're talking thousands of files, thousands of classes. If we don't organize this carefully, what happens? Developers start stepping on each other's code, updates break everything, and nobody can find anything when they need it. Think about it like a library for a second. If you just throw all the books in a giant pile on the floor, you're never going to find that introduction to sales book when you need it. And you'll probably step on something important in the process. That's why D365 uses these strict containers models, packages, and layers to keep everything organized and, more importantly, safe. Okay, so let me break down three terms that confuse pretty much everyone at first: project, model, and package. So the project, that's your workspace in Visual Studio, right? Think of it as a desk where you actually sit down and write code. Each project belongs to exactly one model. Now the model is your feature design. It's the logical container for all the related code. So if you're building something like, let's say, a tax calculation extension, that's your model. Here's something important to understand: it only exists during development. It's what we call a design time concept. The package is what actually gets shipped. When you're done developing, the system compiles your model into a package, which is a DLL file that runs on the server. This is your deployment unit. So here's the clear hierarchy. One project belongs to one model compiles into one package. Why do we need this structure? Because it keeps your custom code completely separate from Microsoft's code. Your package compiles independently, deploys independently, and updates independently. So what exactly are we extending here? Well, Microsoft's own code actually follows the same packaging structure. Think of it like building a skyscraper with three distinct levels, okay? At the very bottom, you have the application platform. This is the engine room. It's the kernel, the runtime, all the core systems that everything else depends on. You almost never touch this layer. Then you've got the middle layer, which is application foundation. This holds all the shared utilities things like workflows, number sequences, and the global address book. These exist so all the business modules can actually use them. At the top is application suite. This is where the actual business functionality lives: sales, ledger, inventory, HR, projects. Most of the time, this is where your extensions are going to hook in. Why? Well, if you break something in the suite, it only affects that particular module. But if you break something down in the platform layer, you've just broken the entire system, right? Safe development means extending at the top, not messing around at the bottom. Now we also need to define who actually owns the code. That's where layers come in. Think of it like a layer cake where each layer represents different ownership. Okay. The bottom layer is SYS, that's Microsoft's sealed core. You simply can't touch it. If you buy a solution from a third-party vendor, that's going to live in the ISV layer. As a partner, you typically work in the VAR layer. And if a customer makes their own custom tweaks, those go in the CUS layer. Now, here's a critical warning I need to give you. Never write code in the USR layer. That layer is strictly reserved for user personalizations. Things like, I want my grid to show 50 rows instead of 25. It's not meant for formal development. So why do these layers matter? because higher layers override lower layers. If Microsoft fixes a bug in SYS and you've got code sitting in var, your code wins. This hierarchy keeps ownership crystal clear and prevents conflicts from happening. Okay, so when you actually sit down to create a model, Visual Studio walks you through a wizard. You'll name your model, pick a publisher, and select your layer, typically var if you're a partner or COS if you're a customer, right? But here's the critical question the wizard's going to ask you: create new package or select existing package. For clean architecture, you almost always want to choose create new package. This keeps your code in its own separate assembly. Why does this matter so much? Well, if you mix your code into an existing Microsoft package, you're creating this messy monolith, When Microsoft sends an update, your code and their code are all tangled together. It becomes impossible to separate them, and upgrades turn into absolute nightmares. A new package means you've got clean boundaries. Your code compiles separately, deploys separately, and updates separately. Now, the final step is references. And honestly, this is where a lot of people get stuck. If your code needs to extend something like a sales table, your model must explicitly reference the application suite package. Need to use number sequences? You've got to reference application foundation. Think of references like a handshake between systems, right? Without that handshake, the compiler literally can't see Microsoft's code. It's like trying to look up a word in a dictionary you don't actually have. Here's what happens when you forget this. You write your code, IntelliSense suddenly stops working. You see those red squiggly lines everywhere, and the build just fails. What's the fix? Go to your model properties and add the package reference. Once you do that, the compiler can finally see the standard code. IntelliSense lights back up and everything compiles properly. Okay, so before we move on, let's highlight the three most common mistakes people make. Mistake number one: adding your custom model to a Microsoft package. This breaks the isolation principle and makes upgrades essentially impossible. Always create a new package, always. Mistake number two: writing code in the USR layer. USR is for user settings, not for formal development. Okay. Use var or CUS instead. Mistake number three: forgetting to add package references. When this happens, your code won't compile, IntelliSense won't work, and you'll waste hours trying to debug it. Now, why do these mistakes matter so much? Because all three of them break your upgrade paths. When Microsoft releases a new version, your system won't update cleanly. You end up stuck on an old version, security patches won't apply, and eventually you'll need to rebuild everything from scratch. Get the structure right the first time, it'll save you so much pain later. All right, so let's recap this topic. We learned about the hierarchy projects contain code, models define features, and packages deploy to servers, right? We learned that Microsoft's code is layered into platform, foundation, and suite, and we extend the suite level. We learned that layers define ownership var for partners, CUS for customers, and never USR for actual code. And we learned that references are essentially the handshake that lets our code see Microsoft standard objects. This structure keeps everything clean, upgradable, and maintainable. But here's the reality you're going to face. You're not working alone. You've got three developers modifying the same model at the exact same time. Developer A is adding a field, developer B is fixing a bug, developer C is updating a form. Without proper coordination, they're going to overwrite each other's work, or even worse, create incompatible code that crashes the entire system. So, how do we prevent this chaos? We use source control. Think of it as a shared notebook where developers check in their changes, track history, and merge their work without destroying each other's code. That's the next topic, source control and branching, and it's absolutely critical for team success. Welcome to the next topic. So we've learned how to organize our code into models and packages, right? But now we're facing the real world problem. Multiple developers working on the same code at the same time. Just imagine five developers sitting at five different desks, all writing code simultaneously. Without proper coordination, they're going to overwrite each other's changes, or worse, create incompatible code that brings the whole system down. That's where source control comes in. Think of it like a shared notebook where every single change is recorded, tracked, and merged carefully. Okay. When developer A and developer B both edit the same file, source control doesn't just let them destroy each other's work. It records both sets of changes and basically asks, how do we combine these safely? That's exactly what we're covering in this topic. How teams use source control and branching to work together without creating chaos. Okay, so first let's talk about where your code actually lives. If you're using cloud-hosted Dynamics 365, your code must live in Azure DevOps Service, the cloud version. This isn't optional, it's mandatory, right? Azure DevOps Services connects directly to Lifecycle services, which is what manages your environments and deployments. It also provides cloud-hosted build agents that automatically compile your code for you. Now, if you try to use an on-premises tool like local TFS or GitHub, it simply won't integrate with LCS. Your builds will fail, your deployments won't work, and when you call Microsoft support, they're going to turn you away because the setup is completely unsupported. Now, for on-premises F&O installations, you do have more flexibility. You can use local TFS or even GitHub if you want. But if you're using cloud F&O, Azure DevOps Services is mandatory. This is the first fundamental rule of source control in the D365 world. All right, so before a developer can actually start writing code, they need to set up what's called a local workspace. This is basically just a mapping a handshake between Azure DevOps and your development VM, okay? Specifically, you're mapping the metadata folder from TFVC, that's where the code lives in the cloud down, to the package's local directory on your local machine. This ensures that when you open Visual Studio, you're actually working with the latest code from source control, not some stale binaries just sitting on the server. If you skip this step, Visual Studio gets really confused. It starts reading old metadata instead of the new source control changes. Your IntelliSense breaks. The compiler gets confused. Merges fail silently, and you won't even know why, right? So always set up the local workspace first. It's a one-time setup that takes maybe 5 minutes, but it prevents literally hours of debugging later. Now let's talk about branching strategy. Think of branches like parallel universes for a moment. In one universe, developer A is working on a new feature. In another universe, developer B is fixing a bug. These universes don't interfere with each other until they need to merge back together, right? Most teams use a pretty simple three-branch strategy. You've got the dev branch, where individual developers do their work. It's messy, changes happen every day, and breaking things is actually okay because it's just your sandbox. Then you have the main branch, which is the integration point. When your dev work is stable and tested, you merge it up to main. This is where the team's combined code lives. Daily builds run on main, and everyone tests against it. Optionally, there's a release branch for UAT and production staging. This branch is very stable. Only approved code merges here. Here's the key rule you need to remember. Code always flows up the chain, dev to main to release. You never merge downward. Okay? Dev never pulls from main just to keep current. Why not? Because that causes absolute merge chaos. Only pull from main when you need to fix specific conflicts. Okay, so when you're merging code, you really need to be precise about direction. The source branch is where your work lives. The dev branch, for example, the target branch is where you're sending that work. Let's say main. If you get this backward, you're going to accidentally overwrite the entire main branch with your incomplete dev code. And that's a catastrophe, right? Most merge tools will ask you something like merge from source to target. Always remember source equals dev, target equals main. That way code flows from dev into main, which is what you want. If the tool uses different terminology like merge into or pull request, just remember this principle. The direction must always be toward production. Dev flows toward main, main flows toward release, release flows toward production, never the reverse. All right. So when you're ready to merge code, Visual Studio provides a merge wizard. Follow these steps exactly. Don't skip around. Okay. First, connect Visual Studio to your Azure DevOps project. Second, map the target branchlets, say main to a local folder. You need the destination locally so you can actually review what's being merged. Third, open source control explorer. This shows you all your branches in one view. Fourth, right-click the destination branch main in this case and navigate to branching and merging, then select merge, the wizard appears. Fifth, confirm that source is dev and target is main. This is your last chance to catch any direction errors before they happen, right? Sixth, if there are conflicts, meaning code change in both dev and main too, wizard's going to show them to you. You pick which version to keep, the compiler checks that everything still works, and then you check in the merged result. This sequence is pretty strict. Skip steps and you'll merge incorrectly. Follow it exactly and your code moves safely from dev to main. Now let's talk about how you actually add code to source control. There are two different workflows depending on what you're doing, okay? If you're editing an existing element, maybe a form you modified or a class you changed, you right-click the file and choose checkout for edit. This tells source control, Hey, I'm working on this, nobody else touch it. If you're creating something brand new, a new extension, a new class, you choose add to source control instead. This tells the system this is a completely new element I just created. Both of these actions show up as pending changes in Team Explorer, right? Once you've checked out or added everything you need, you open the pending changes view. This is where you review all your modifications, add comments explaining what you did, optionally link work items from your project tracking system, and finally commit the changes set. This commit actually sends your code to Azure DevOps. Always use pending changes to commit. Never try to shortcut this process because you'll miss important validation steps. Okay, so Visual Studio has multiple comparison tools and it actually matters which one you use. If you're comparing your custom X++ code against ISV code to spot the differences, use compare code with baseline. This shows you exactly what you changed versus the original baseline. If you're resolving merge conflicts where your code and the team's code both changed the exact same section, use compare and merge code instead. This shows you three versions side by side. The common ancestor, your changes, and the incoming changes. Then you pick which one to keep, right? If you're comparing form metadata or UI structure, the XML that actually defines a form's layout, use compare metadata with baseline. This compares the XML element definitions, not the code itself. Using the wrong tool means you're going to miss important differences. The comparison view won't highlight what actually changed, and you might accidentally accept the wrong version. So pick the right tool for the specific job you're doing. Now, when you click Get Latest Version to pull the team's changes, Visual Studio tries to automatically merge them with your code. If the changes don't overlap with yours, the merge succeeds silently and you just keep working. But if you and the team both edited the same section of code, you've got a conflict, right? Visual Studio can't decide which version to keep, so it stops and asks you for help. Here's where people really mess up. They panic and click Undo. This is completely wrong. Undo removes your pending changes, the changes you haven't committed yet. But the auto-merged files, they stay merged and messed up. Instead, use the output window to diagnose what actually happened. The output window shows you exactly which files auto-merge successfully and which ones have conflicts. For the conflicted files, open them in the compare and merge tool, resolve the conflicts manually, and then try the merge again. This detective work might take 10 minutes, but it prevents you from losing hours of your own code. Okay, so let me tell you about three mistakes that developers make all the time with source control. Okay, so mistake number one, and this is a big one, rolling back team change sets. So let's say you're frustrated, right? Because someone's code just broke the build and you're thinking, okay, I'll just undo their changes set, problem solved. But here's the thing, this affects the entire team. It doesn't just remove their code. I mean, it removes everyone's code from that changes set. So if that changes set had code from, let's say, 5 different developers, rolling it back removes all 5 people's work, right? So instead, what you should do is talk to the team member who committed the bad code and have them fix it. Never roll back without getting permission from everyone involved. Okay. Now, mistake number two, checking pending changes to figure out why code disappeared during a merge. This is backwards logic, basically. Pending changes shows your uncommitted work. It doesn't show what source control overrode. Use the output window instead. The output window tells you exactly what auto merged and what conflicts actually occurred, right? And mistake number three, merging downward. So like release back to main or main back to dev. Now this sounds logical at first. You're thinking, let's push bug fixes down to dev, but it causes absolute branch chaos. Always merge upward toward production. So dev to main to release, never go in reverse. Okay. So sometimes, you need to find out when a specific line of code was added or which developer actually made a particular change. Now, source control tracks all of this history for you. In Solution Explorer, right-click a file and choose source control, then view history. This shows you every single commit to that file, who changed it, when they changed it, and what changes set number it was. Right now, click on any commit to see the diff, exactly what lines changed. And this shows you every single commit to that file, who changed it, when they changed it, and what change set number it was. Right now, click on any commit to see the diff, exactly what lines changed. You can also use the annotate view to see authorship at the line level. So every single line shows you which commit introduced it. This is incredibly powerful for debugging. You find a bug, you use annotate to see which developer and which commit introduced it. Then you can ask them for context about what they were trying to do. Now, here's a common mistake people make. Developers think Application Explorer shows source control history. It doesn't. Okay. Application Explorer shows metadata, what's currently deployed in the environment. It has absolutely no connection to source control. So if you want to see history, you need to use Solution Explorer and the View History option. Application Explorer simply cannot tell you when was this form last modified. You have to use Solution Explorer instead, right? All right, so let's recap what we just covered. We learned that Azure DevOps Services is mandatory for cloud F&O projects, right? It connects to LCS and provides those cloud build agents we need. We learned that you absolutely must set up a local workspace mapping. So metadata to packages, local directories, so Visual Studio reads live source control instead of stale binaries. We learned the branching strategy, dev for individual work, main for team integration, release for UAT staging, and remember, code always flows upward, dev to main to release to production. We learned the merge sequence, confirm your source and target, resolve conflicts using the right comparison tool, and always merge in the correct direction. Okay. We learned the check-in workflows, check out for edit on existing code, add to source control for new code, and review everything in pending changes before you actually commit. We learned about the diagnostic tools, the output window for auto merge problems, view history for traceability, and why Application Explorer really isn't suitable for source control history. Now that your team's code is organized, tracked, and merged safely, the next step is actually building it. We need to compile all that code into a package and deploy it to testing environments. So that's the next topic, build, deployment, and LCS, where we'll see how all these pieces actually fit together. All right. Welcome to the next topic. So we've learned how to organize code, merge it safely, and track changes with source control. But we're still on the development machine at this point, right? Our code isn't live yet. Now comes the critical step, moving our code from development into testing, then UAT, and finally production. So think of this like a factory assembly line for a moment, okay? Raw materials, which is your source code in branches, get processed by machinery. That's the build pipeline into finished products, deployable packages. Those finished packages get stored in a warehouse, the LCS asset library, and then they're shipped to their destinations, test, UAT, and production environments. Without this process, your code just stays on your desk forever. With it, your code actually reaches thousands of users. So this is what we're covering now, build, deployment, and LCS. We're going to see how all these pieces connect and how code actually moves through the system. Okay, so first let's clarify what we're actually deploying here. Dynamics 365 doesn't work like a document editor where you just, send source files around. It needs compiled packaged code. The only artifact you can deploy to production is a deployable package, which is a zip file containing compiled models, DLLs, and metadata. Now, never try to deploy Axe model or Axe BB files, right? Why not? Because Sandbox and production environments don't have developer tools installed on them. They can't compile source files. So if you try to deploy source code, the system is just going to reject it outright. And never deploy managed solutions for finance and SCM code. Those are for Power Platform and Dataverse, not for our business logic. Okay. So here's the single rule to remember. Deployable package, zip format, compiled and ready to go. That's the only artifact that actually works. So you have two supported ways to create a deployable package, right? The first is automated through DevOps. So a developer checks in code to the correct branch. Automatically, the build pipeline wakes up, compiles all the models, and generates a deployable package. And this package can then be automatically uploaded to the LCS asset library, making it instantly available for deployment. Now, this is absolutely the best practice. It's repeatable, it's audited, and it removes human error from the equation. The second way is manual through Visual Studio. So you open Visual Studio on your development machine, right click your project, select create deployment package, wait for it to compile, and then retrieve the zip file. Then you upload it to LCS manually. Now, this works fine if you're a solo developer just testing on your own machine, but in a team environment, it's really error prone. Different developers might generate different packages from different workspace states, and nobody knows which version is which, right? So here's the rule. Use DevOps pipelines for anything you actually care about. Only use Visual Studio packaging for isolated testing. Okay. All right. So if you're creating a package manually in Visual Studio, let me walk you through the steps exactly. First, open your solution, the one containing your custom models and extensions. Second, right-click the project and navigate to Dynamics 365, then select Create Deployment Package. Now a dialog pops up asking which models to include. Third, select the models you want. You can choose just one model or multiple models depending on your scenario, right? Fourth, click Create and wait. Now the compilation process can take a few minutes depending on how much code you have. Fifth, once it's complete, retrieve the generated zip file, from your VM. It's usually saved to a standard folder like downloads or your desktop. Sixth, upload that zip to the LCS asset library. We'll talk more about the asset library in just a moment. Okay. So this manual process is fine for your own personal testing, but never use it for team deployments. Always use DevOps pipelines for production grade application. Now, the automated DevOps approach is much more elegant. So a developer checks code into the correct Azure DevOps branch automatically without anyone clicking anything. The build pipeline wakes up, it pulls the latest source, compiles all the models, and generates the deployable package. Now, if you have a release pipeline configured, it even automatically uploads that package to the ALCS asset library. From start to finish, this happens in just minutes, completely hands off. The beauty of this is repeatability and audit trails. Every single deployment can be traced back to a specific code commit and a specific build run. So if something breaks in production, you just ask which build was deployed, and the system has a definitive answer. With manual packaging, you lose this trail completely, right? Did you package from the dev branch or the main branch? Was it the 10 a.m. version or the 2 p.m. version? Nobody knows for sure. So use DevOps pipelines for anything important. Okay. So the LCS asset library is basically your package warehouse, right? Every deployable package you create, whether manually or through DevOps, gets uploaded here and stored safely. Now the asset library organizes assets by type. Software deployable packages is where your code lives. But there are also other asset types. GER configurations for reporting, marketing assets for branding images, localized reports for statutory reports. We're focusing on software deployable packages here. Okay. Once you upload a package, it moves through different states. Uploaded, staged, ready to deploy. The package just sits in the asset library until you actually decide to deploy it. You might upload a package to the asset library but not deploy it immediately. Maybe you're waiting for sign off or you want to deploy next Tuesday night during maintenance hours. That's totally fine. The asset library holds packages safely until you're ready to use them. So think of it like a shipping dock. Packages arrive, they get inspected and stored, and they wait there for deployment orders, right? All right, so uploading a package to LCS is pretty straightforward. First, open LCS in your browser and navigate to the asset library. Second, find the software deployable package section, not marketing assets or any of those other sections, okay? Third, click upload and select your zip file. Now the upload can take a few minutes depending on how large the file is. Fourth, once it's complete, your package appears in the asset library. It's now stored safely in the cloud and accessible from any LCS user in your project. Now, here's a critical point I need to make. Uploading is not the same as deployment. A lot of people confuse these two steps. Uploading means put the package in the warehouse. Deployment means take the package from the warehouse and actually install it in an environment. These are two completely separate actions, right? You can upload a package and just leave it sitting in the asset library for weeks if you want. Later on, when you're ready, you decide to deploy it. We'll cover the deployment process next, okay? All right, so before we deploy, let me be very clear about what's supported and what's absolutely not. Okay, here are the incorrect approaches. Copying a zip file directly to a server folder and hoping it somehow installs itself. This is completely unsupported and dangerous, right? Using remote desktop to manually unzip and install files, totally unsupported. Trying to use alternative tools or custom scripts you found somewhere, unsupported. Deploying source files like AXPP or AXModel, completely unsupported. The environment doesn't even have compilation tools to process them. All of these approaches are deprecated, risky, and will absolutely break your system. So the only supported method is using LCS. You open the environment in LCS, navigate to maintain, select apply updates, choose your package from the asset library, and approve the deployment. LCS handles absolutely everything: validation, installation, rollback capability, audit logging. This is the only way to deploy in Microsoft managed environments. If you use any other method and something breaks, Microsoft support is going to refuse to help you. Okay, so here's the exact deployment sequence you need to follow. First, open your target environment in LCS, let's say your Sandbox environment. Second, navigate to the maintain section. This is where you manage environment updates, deployments, and general maintenance tasks, right? Third, select apply updates. This is the actual deployment action. Fourth, a dialog appears showing all the packages in your asset library. Select the specific package you want to deploy. Now the system is going to ask you to confirm and schedule the deployment. You can either deploy immediately or schedule it for a specific date and time. Okay. Fifth, once you approve it, the environment begins the deployment process. The system pulls your package, installs it, runs validation checks, and typically restarts the environment. Now, this whole process can take anywhere from 30 minutes to 2 hours. You can't use the environment at all during deployment, so make sure you deploy during off hours. Once deployment completes, your custom code is actually live in that environment, right? All right, so let me show you the typical environment progression. At the very bottom are development VMs, your build machines. This is where you write code and test things locally. Now, you never formally deploy to dev VMs. You just rebuild them from LCS when needed, okay? The next level up is sandbox environments, also called test environments. This is the first place you actually deploy your package using LCS. You deploy to sandbox, test everything thoroughly, verify the behavior, and make absolutely sure nothing broke, right? Once you're confident everything works, you move up to UAT, user acceptance testing. This is where real users actually test the functionality. Then finally, after UAT approval, you deploy to production. Now, here's the rule you must follow. Never deploy directly from dev to production. Always go through sandbox first. Always test before touching production. If you skip sandbox testing and deploy broken code straight to production, you've now hurt thousands of users and created a major business problem. So the deployment sequence is always dev development, create package, sandbox testing, UAT user testing, and then production live. This progression takes time, yes, but it's absolutely mandatory. Okay. So after deployment, sometimes things go wrong, right? The system feels slow. Users start complaining about performance. So how do you actually diagnose the problem? Well, LCS provides three main monitoring tools for this. Health metrics shows you CPU usage, memory consumption, request volume, and overall environment health. So if CPU is completely maxed out, you clearly have a performance problem. SQL Insights dives much deeper into the database layer. It shows you slow queries, table locks, missing indexes, and blocking chains. So if a query is running for 5 minutes when it should run in 5 seconds, SQL Insight shows you exactly why. Maybe there's a missing index, or maybe your code has an n+1 query problem, right? Activity monitoring shows you user sessions and request traces. It answers questions like, what was that specific user doing when their screen was running slow? Now, these tools are only available in Tier 2 plus environments. So Sandbox, UAT, and production. Your build VM has pretty limited diagnostics, okay? So here's the pattern to follow. If deployment doesn't work, check health metrics first. If health metrics looks okay, check SQL Insights next. Still stuck? Run system diagnostics on the build VM and upload the logs to LCS. These LCS tools are basically your detective kit for troubleshooting. Okay, so let me highlight 4 critical mistakes people make during deployment. Mistake number 1. Deploying straight to production without testing in Sandbox first. You think, oh, this is just a small change, I don't need to test it. Then it breaks something fundamental and suddenly thousands of users are offline, right? Always test in Sandbox first, no exceptions. Mistake number 2, deploying AXPP or XML files instead of zip packages. You might think the system will just compile it for me. No, it won't, okay? Sandbox environments don't have compilation tools installed. The deployment is going to fail. Always deploy only zip files. Now, mistake number 3, installing an ISV solution without reviewing SQL performance first. ISV code can have really inefficient queries, missing indexes, or n+1 query patterns. After installation, the entire system slows to a crawl. So before deploying any third-party code to production, review it thoroughly in Sandbox first. Use SQL Insights to check for performance issues, right? And mistake number 4, bypassing LCS and trying alternative installation methods. You might think you can just copy files or use some custom scripts. You'll break the system completely. LCS is the only supported method. Use it always, no shortcuts. Okay. All right. So let's recap what we just covered. We learned that Dynamics doesn't deploy source files. It deploys compiled, packaged zip files. Right. We learned there are 2 ways to create packages: automated through DevOps pipelines, which is the best practice, or manually through Visual Studio for quick testing. We learned that packages get uploaded to the LCS asset library, which is basically the warehouse where packages are stored and staged. We learned the deployment sequence: open the environment in LCS, navigate to maintain, select apply updates, choose your package, and approve the deployment. We learned about the progression path: dev to sandbox to UAT to production. Never skip any steps in that sequence, okay? We learned that the only supported deployment method is LCS and apply updates. Nothing else actually works properly. And we learned about the LCS monitoring tools, health metrics for general performance issues, SQL Insights for database-specific problems, and activity monitoring for user-specific issues, right? Now that code is deployed and running in Sandbox, the next problem we face is how do we debug it when something doesn't work? That's where Visual Studio tools come in. Okay, so the next topic covers debugging, breakpoints, and the diagnostic tools that help us find and fix issues in running code. All right, welcome to the next topic. So your code is deployed, it's running in Sandbox, but something isn't working correctly, right? Users start reporting things like the form doesn't calculate the total correctly, or the batch job fails silently, or the price calculation is using the wrong value. So how do you actually find the bug? You can't fix what you can't see, right? That's where Visual Studio tools come in. Instead of just staring at code, hoping to somehow spot the mistake, you use the debugger to step through execution line by line, watch variables change in real time, and see exactly where things are going wrong. You know, so this is what we're covering now. VS tools and debugging. We're going to learn how to navigate the code base efficiently, find what we're looking for quickly, inspect forms and extensions properly, and use the debugger to trace through code execution. Okay. So Visual Studio's Application Explorer is where you browse all the metadata tables, forms, classes, everything in the system. Now, by default, it organizes elements by type, model tables grouped together, node forms together, or classes together, right? This is fine if you're just browsing by category, but when you're actually reviewing architecture, it gets really confusing. Which code belongs to which model? With thousands of elements spread across dozens of models, you really need clarity. You know, the solution model view. Right click the AOT node at the very top and select model view. Now the application explorer reorganizes itself to show elements by their originating model. You can see your custom model with just your extensions inside. You can see application suite with all the standard business code. Okay. This instantly answers questions like which code did I actually customize and what lives in the standard product versus what's custom. Model view is especially useful when you're validating solution architecture or auditing what you've actually customized over time. So just switch between traditional view and model view depending on what you're looking for at the moment, right? All right. So Visual Studio includes a really powerful metadata search tool. Instead of manually browsing through the application explorer tree, which can take forever, you can search for exactly what you need. The syntax is pretty straightforward. You start with type followed by a singular element type. So use singular forms, type table, type form, type enum. Okay. If you're looking for sub elements like specific methods, use a comma, type table, method name, insert. This finds all insert methods across all tables in the system, right? You can add property filters like name or model to narrow your results down. Use code to actually search inside method bodies. So for example, type class code cross company finds all classes containing the word cross company somewhere in their code. You can even combine filters. Type form, model application suite, name sales order, finds all sales order forms specifically in application suite. Here's the critical part though. Use singular type names. Plural forms simply don't work. Use type table, never type tables, okay? And avoid unsupported operators like contains. Just stick with the supported syntax and your results appear instantly. So when you're reviewing what you've actually customized, you need to find all the extensions affecting a specific form. Let's say you're auditing the sales order form. What extensions are modifying it? How many different developers have added code to it? What exactly did each extension add? Now, Visual Studio provides two approaches for this. First, you can use view references. Navigate to the base form in Application Explorer, right-click it and select View References. This lists all extension artifacts under the extending category. You see exactly which extensions are touching this particular form. Okay. Second, you can open the form designer and use the E filter in the search bar. The E stands for extensions. This filter displays only extension originated controls, methods, and data sources in the combined hierarchy. You instantly see what's new versus what's original product code. So if you see something like sales order form extension total, that's clearly an extension. If you just see sales order form total, that's original product code, right? This is absolutely critical for understanding customization, impact, and knowing what you're responsible for versus what Microsoft maintains. Okay, let's talk about breakpoints. They're really the foundation of everything in debugging. A breakpoint is basically you telling Visual Studio, hey, stop execution right here. I want to look around and see what's going on. Setting one is super simple. Just click in the margin to the left of any line number. You'll see a red dot appear. That's your breakpoint. Now, when you run the program with F5, execution runs normally, doing its thing until it hits that breakpoint. then everything pauses. I mean, execution stops completely. You're frozen in time at that exact moment in your code. You can check the watch window to see all your variables. You can inspect the call stack to see the chain of method calls that got you here. And you can use step into or step over to move forward one line at a time. When you're done investigating, just hit F5 again, and it will keep running until it hits the next breakpoint. And here's the thing, you can set as many breakpoints as you want, right? If you've got breakpoints at lines 10, 25, and 50, execution will pause at each one. This is how you trace through code without, littering it with print statements or just guessing what's happening. Set your breakpoints strategically, put them at the entry point of methods you're suspicious about, right before calculations happen, after database queries execute. Then run your code and watch it pause at each breakpoint. Inspect what you need to see, step through, resume. Keep repeating until you find what's broken. Okay. All right, so the watch window is like your personal variable inspector while debugging. When you're stepping through code and you want to know what's actually in this variable right now, that's when you add it to the watch window. And here's what makes it powerful: as you step through your code using step into and step over, the watch window updates in real time. You literally watch your variables change right in front of you. Let me give you an example. So let's say you're debugging a price calculation that's giving you wrong results. You add unit price, quantity, and total price to your watch window. You start stepping through the code. Initially, unit price shows 100, quantity shows 5, and total price is still empty. You step into the calculation method, and now total price becomes 500. Makes sense, right? But then you keep stepping, and suddenly total price becomes 475 instead of 500. Wait a minute, that's your bug. Turns out tax was being subtracted when it shouldn't have been. The watch window made that bug visible. Without it, you'd just be guessing at what's happening. To add a variable to watch, just right click it in your code and select Add Watch, or you can type the variable name directly into the watch window. This is genuinely debugging gold because variables don't likely show you exactly what your code is doing at each step. Okay, so think of the Visual Studio Debugger as basically your time machine for code, right? Here's how it works. You set a breakpoint, you run your code, and boom, execution stops right at that line. Now, from that, you've got three essential commands to move through your code. Let's talk about step into first. That's F11. So when you're sitting on a line that calls a method like insert, and you hit F11, you actually dive inside that method. You'll see every single line of logic as it executes. This is perfect when you're thinking, okay, something's going wrong inside this method. I need to see exactly what's happening. Now step over, that's F10, works differently. It runs the entire method without taking you inside. So if you're at that same insert call and press F10, the method executes completely and you jump straight to the next line. You don't see what happened inside. Use this for methods you already trust, like framework utilities where you know the problem isn't there. Then there's step out, which is shift plus F11. So let's say you've stepped into a method and you realize, wait, I've gone too deep, the bug isn't here. Step out finishes executing the current method and brings you right back to where it was called. Here's the pattern you want to remember. Step into when you're investigating something suspicious. Step over when you trust the code and just want to move past it. And step out when you realize you've gone deeper than you needed to. These three commands, honestly, they'll handle about 90% of your debugging scenarios. Okay. All right, let me walk you through the complete debugging workflow, the way you'd actually do this in practice. First, you need to identify where the problem probably is. So let's say users are reporting the total is wrong on sales orders. You narrow it down, okay, the bug's probably somewhere in the sales order total class, specifically in the calculate total method. Second, um, open up that method and set your breakpoints. Put one at the entry point where the method starts and another at the return statement. Third, press F5 to start debugging. The program runs like normal. When execution hits your breakpoint, it pauses. Fourth, check your watch window. Look at all the variables at this exact moment. Are they what you expected? Is unit price loaded correctly? Is quantity right? Has tax already been applied when it shouldn't be? Fifth, you step into to go inside sub methods when you need to see what's happening there. You step over to skip past calls you trust. You step out to back up when you've gone too deep. Move forward one line at a time, keeping your eye on that watch window. The moment a variable becomes something unexpected, boom, you found your bug. Sixth, once you've identified the issue, fix it. Remove your breakpoints, rebuild, test again. This workflow is actually pretty simple, but it's incredibly powerful. Most developers solve bugs exactly this way. Set breakpoints, inspect variables, step through execution, find the unexpected state, and fix it. The debugger basically turns, I have absolutely no idea what's wrong, into, oh, I see. The calculation is using yesterday's date instead of today's date. So after you coded a new form or made changes to an existing one, you want to test it right away, right? Instead of rebuilding the whole environment and then clicking through menus to get to your form, there's a much faster way. Use the startup object shortcut. Here's how it works. In Application Explorer, find your form, right-click on it and select Set as Startup Object. What you're telling Visual Studio is, when I press F5, start by launching this form directly. Now press F5. Visual Studio builds the entire solution, spins up a debugging session, and launches a browser that goes straight to your form. You can skip all that menu navigation. The form just appears immediately. You can manually test the functionality. Click buttons, enter data, see if your validation works the way it should. And if you need to debug deeper, just add breakpoints to the form code before you press F5. The debugger will pause when execution hits those breakpoints. This is honestly the fastest workflow for form development. Write your code, set as startup, hit F5, test it, fix whatever's wrong, and repeat. No time wasted navigating through menus, Okay, so the output window is like Visual Studio's information dashboard. It's showing you what's happening behind the scenes. When your code runs, Visual Studio is recording everything: method entries, database queries, warnings, errors. All of that information appears in the output window. You can open it by going to View, then Output Window, or just press Ctrl plus Alt plus O. Now the output window becomes really invaluable when you're debugging batch jobs or background processes. You can't step through a batch job the way you would a form. It's running in the background, so instead you add diagnostic output to your code. For example, in your batch job, you write something like debug.writeLine about to calculate total. That line sends a message straight to the output window. When you run the batch job, you're watching the output window and you see the flow happening: starting calculation, fetching orders, processing 100 records, calculation failed, null reference. The output window is showing you exactly where execution stopped and why. This is especially useful for diagnosing batch jobs, web services, and other background processes that don't have any visual interface, right? The output window is basically your window into what the system is doing when you can't see it directly. All right, let me point out 3 debugging mistakes that people make all the time. Mistake number 1, using step over when you actually need step into. So you suspect there's a bug inside a method. You're sitting at the call site, you press F10, step over, and what happens? You skip the method entirely. Execution jumps right past the area where the bug is actually living. You never even see the problem. What you should do instead is press F11, step into, to actually enter the method and inspect what's happening inside. Mistake number 2, running your code without setting any breakpoints first. You press F5 and the code executes normally. It runs fast, completes, and you've learned absolutely nothing. You never paused to inspect any variables. And set breakpoints at the suspicious locations before you run. Okay. Mistake number 3, stepping through code without using the watch window. You're going line by line, that you're not watching any variables. You have no idea what values are actually contained in anything. Add your variables to the watch window. Watch what changes at each step. Okay, let me show you how debugging actually works in real scenarios you'll encounter. In scenario 1, a form is calculating totals incorrectly. Open the form in Application Explorer, find the calculate total method, set a breakpoint right at the entry, press F5. The form opens, you interact with it and trigger the calculation. Execution pauses at your breakpoint. Now in the watch window, inspect unit price, quantity, discount. Are they what you expected them to be? Step into the calculation logic, watch the variables change. When you see an unexpected state, like total becoming 475 instead of 500, you found your bug. Turns out it's the tax calculation applying when it shouldn't. Fix the logic and test again. Scenario 2, a batch job is failing silently with no error message. Open the batch class, add debug.writeLine calls at key points. Batch started, fetching orders, processing record, calculation complete. Run the batch job, watch the output window. You see batch started, you see fetching orders, and then nothing. Execution stopped right there. Likely there's a query error. Check the where clause, validate table permissions, inspect the data. Scenario 3, a query is returning the wrong rows. Set a breakpoint right after the query executes. Run the code, inspect the result set in the watch window. You see the rows returned when you were expecting. The where clause isn't filtering correctly. Check the logic, fix the filter, test again. These scenarios cover most of the debugging situations you're going to run into, and all right, let's recap what we have covered in this topic. So we learned that Model View reorganizes Application Explorer by model, which gives you clarity on what code belongs where. We learned metadata search syntax, so you can find elements quickly without manually browsing. Remember to use singular types, sub-element commas, and property filters. We learned how to find all the extensions affecting a form using view references with the designer filter. We learned the three-stepping command: step into to inspect the internal logic of methods, step over to skip methods you trust, and step out to exit when you've gone too deep into the method stack. We learned that the watch window shows you variable states as you step through code, um, revealing exactly when and where values become unexpected. We learned that breakpoints pause execution so you can inspect what's happening. And we learned the debugging workflow: identify the suspicious area, set breakpoints, run your code, inspect the watch window, step through execution, and find the bug when a variable becomes something you didn't expect. We also learned to set a form as startup object and press F5 to launch forms directly without navigating through menus. Now that you understand how to write code and debug it, the next question is, what data types should you be using? Should you create your own type or use a standard one? That's what we are covering in the next topic, EDTs and Enums, where we explore the foundation of data types. All right, welcome to this topic. Now that you know how to write code and debug it, we need to talk about the foundation of everything: data types. In your code, you're working with data constantly: strings, numbers, dates, booleans. But here's the thing about primitives like string or int are basically naked. They have no metadata, no help text, no consistent formatting. Extended data types or EDTs wrap these primitives and add that metadata. An EDT called customer account tells you immediately, okay, this is a customer account number. A plain string tells you absolutely nothing. Enums let you define a list of allowed values. So instead of storing good, medium, risky as plain strings where someone might type excellent by accident, you define an enum with these exact values. This prevents typos and makes the system self-documenting. This topic is about EDTs and enums. We are going to learn how to choose the right data type, when to reuse standard EDTs, when to create new ones, and how to use enums to control data quality. Okay, let me explain the difference between primitive types and EDTs. A primitive type is basic: string, int, real date. It holds a value, but that's it, nothing else. A method parameter of type string could be a customer account, a name, an address, literally anything. There's no clarity. An EDT wraps that primitive and adds metadata on top of it. So the EDT customer account is still a string primitive underneath, but now it carries metadata: a label that says customer account, help text that says enter the customer account number, maximum size, formatting rules, maybe some validation. Now, when you see customer account total in your code, you immediately understand what it is. When you use customer account as a field type on a form, the label and help text appear automatically. When you use customer account in a table, all instances of it have the same formatting, validation, and constraints. This is the real power of EDT's reusability and consistency. Without EDTs, every single form would need its own custom labels and help text. Every table would have to define its own size constraints. With EDTs, you define it once and reuse it everywhere. And when you change the EDT, those changes cascade to everywhere it's being used. So EDTs can actually inherit from each other, which creates a hierarchy. The foundation is a primitive type like string. Then you create an EDT that extends string. Let's call it extended string. Then you create another EDT that extends extended string, call it amount. Finally, you create sales amount that extends amount. You've created a hierarchy. Now, here's the critical rule you need to understand. The root EDT, the one that's closest to the primitive, governs the string size. If the root allows characters, all the children inherit those characters. Child EDTs cannot override the parent size. If you try, the system will reject it. This prevents accidents where a child EDT shrinks the size and breaks data integrity. But child EDTs can override metadata like labels and help text. You could have amount with the label amount and sales amount with the label sales amount. This inheritance hierarchy lets you specialize things. Amount is generic, sales amount is specific. Just understand the hierarchy, right? The root EDT is the authority, everything else inherits from it. Okay, so when should you extend an existing EDT versus creating a completely new one? The decision comes down to fit. If you need to increase the size of an existing data type, like amount, and amount is derived from a root EDT, you should extend the root EDT. Find the root, maybe it's amount base, and create an EDT extension that increases the string size. This change automatically cascades to amount and all its descendants. Every field using amount now supports the larger size. That's elegant reuse. But if you need a completely different data type that doesn't fit any existing EDT, then create a new one from scratch. Base it on a primitive type like string or int, define its properties, add your metadata, and now you have a new reusable type. Here's a rule: reuse when the existing EDT fits what you need, extend when you need to enhance an existing type, Create new when you have unique requirements. Maximizing reuse minimizes the maintenance burden later on. All right, let me be very clear about what's safe to change on EDTs and what's dangerous because this matters. Safe changes. Increasing string size on the root EDT. When you extend the root, all children automatically inherit the larger size. Changing labels and help text on any EDT, these are pure metadata and don't affect data storage. Adding new help text or clarifying existing labels is fine. Creating a brand new EDT from a primitive type, you're starting fresh with no inherited constraints. Extending an EDT to modify its metadata is safe. Now, unsafe changes, decreasing string size. Never ever shrink a field. If the field is storing 30 character account numbers and you shrink it to 20, existing data gets truncated. That's data loss. The system will block this. Increasing string size on a child EDT, the root EDT governs size. A child cannot override it. The system rejects this. Changing alignment or other fundamental properties, these are locked by design. And don't expect parent fields to automatically update when you create a derived EDT. They don't. If you create a new EDT but existing fields still point to the old EDT, those fields don't change. You have to explicitly reassign fields to the new EDT. The golden rule: size changes must never decrease. String size can grow, but it can never shrink. This is a safety guardrail against data loss, okay? Okay, here's how you actually increase a field size through EDT extension. First, identify the root EDT. So if you have a field of type amount, trace it back. Amount extends amount base. Amount base extends string. Amount base is the root. Second, create an EDT extension for amount base. You're not modifying amount base directly, you're extending it. Third, in that extension, modify the string size property. Increase it from, let's say, 20 characters to 30 characters. Fourth, build the model. The compilation process verifies that your extension is valid. Fifth, and this is critical, synchronize the database. The database schema needs to update to reflect the new field size. After you sync, every table using amount or any EDT that's derived from amount automatically gets the larger field. You don't touch those fields individually. The change cascades automatically. This is the power of a proper EDT hierarchy. One change at the root ripples through the entire tree, right? So creating a new EDT from scratch is pretty straightforward. First, decide on a primitive type. For text, use string. For numbers, use int or real. For dates, use date. For true/false, use boolean. Don't use derived types as the foundation. Always go back to the primitive level. Once you've chosen your primitive, create an EDT extending it. Give it a meaningful name like vendor risk rating or product description. Set the string size if it's string based. Set metadata like label and help text. Now you have a reusable type. Any table that needs a vendor risk rating field uses a vendor risk rating. Any form automatically shows the same label and help text. If you ever need to increase the size later, you modify the EDT once and all the consumers update automatically. For large text fields like notes or comments that need unlimited space, create an EDT based on string and set string size to memo or note. This creates an unlimited length text field. These are really useful for freeform comments where you can't know the size upfront. Okay, so an enum is an enumerated type, basically a list of predefined allowed values. Imagine you have a vendor risk rating field. The only valid values should be good, medium, or risky. If you store these as plain strings, developers might type excellent by accident, or good in uppercase, or met shortened. Now you've got inconsistent data. Typos break your reports. With an enum, you define exactly which values are allowed: good, medium, risky. That's it. When a developer or user tries to enter a value, the system only accepts these three options. A drop-down shows them. No typos possible, no surprises. Enums are perfect for classification scenarios: status like active, inactive, pending, priority like low, medium, high, risk rating like good, medium, risky. They're also self-documenting. When you see vendor risk.good in code, you immediately know what it means. Compare that to a numeric code like 0, 1, 2. Nobody knows which number means what without reading documentation. Enums make your code readable and your data consistent, right? All right, here's how you create an enum-based field. First, create a base enum. In Application Explorer, right-click on enums and create a new one. Name it something meaningful like vendor risk rating. Define the literal values: good, medium, risky. The system assigns each one a numeric value underneath, but you think in terms of the text values. Second, create a table extension on the table you want to enhance. Third, add a new field to that extension. Set the field type to your enum vendor risk rating. Fourth, extend the relevant form and add the field from the data source. When the form displays, the field automatically appears as a drop-down showing good, medium, risky. Users can only select from these values, no typos, no unexpected values sneaking in. This enum approach is way better than storing text directly. It prevents garbage data from getting into your system and makes everything self-documenting. Every developer and user knows exactly which values are valid. So field groups are a simple but really useful organizational tool. They group related fields together. For example, a vendor might have credit related fields, credit limit, risk rating, payment terms. These three are logically related, right? So you create a field group in the table called credit rating. You add these three fields to the group. Now, when a form needs to display credit information, instead of manually adding three separate fields, the developer just adds one field group. All three fields appear together in the same order with the same layout. And if you later decide we need a payment status field in this group, you add it to the field group once. Automatically, every form using that group now shows the payment status field in the right place. Field group ensure consistency. Credit information always looks the same whether you're on a vendor form, a purchasing form, or a reporting form. Without field groups, every form defines its own layout. Credit fields appear in different places on different forms, which confuses users. With field groups, consistency is guaranteed. All right, so enums can be displayed in multiple ways on forms depending on what makes sense for your context. Dropdown is the most common option. When you add an enum field to a form, it automatically displays as a dropdown showing all the valid values. Users click the dropdown, see the options, and select one. This works for any number of values. Option buttons or radio buttons are good when you have just a few values, like 3 to 5. Option buttons show all the values at once, no clicking required. Good for quick decisions. Good, medium, risky, all visible. Users see all the options and can pick one immediately. Slider bars work well for ordered, continuous values. Low, medium, high can be represented as a slider. Users slide left for low, right for high. This is intuitive for ordinal data. Now, what's not allowed? Never use a date field for an enum. Date fields are for date primitives, not control lists. The system will prevent this combination anyway. The choice of UI depends on your data. Got a few values and users are familiar with them? Use option buttons. Many values, use a drop-down. Ordered spectrum of values, consider a slider. Most commonly though, a drop-down is the right choice. It's flexible, users are familiar with it, and it works for any dataset size. Okay, so let me walk you through 4 really critical mistakes that people make with EDTs and enums. First mistake, right, is decreasing an EDT string size. So you're thinking, we need to tighten up this field a bit. You shrink it and boom, data gets truncated. Existing records, they lose information. The system actually blocks this for a very good reason. Never shrink fields. Okay. Second mistake is using non-primitive EDTs as the foundation for new EDTs. You think, oh, I'll just base my new EDT on amount. But see, amount is already derived from amount base, which itself is derived from string. So you're creating these really deep inheritance chains that they complicate maintenance down the line. Always base new EDTs on primitives like string, int, real, date. Third mistake, storing enum-like values as plain text instead of using actual enums. You think I'll just store good, medium, risky as strings. Then developers typo excellent, users enter good in all caps. Your data becomes absolute garbage, right? Use an enum type instead. The system enforces valid values for you automatically. Fourth mistake, creating enums without grouping related ones with field groups. You end up with, let's say, vendor risk fields scattered all over a form. Credit limit fields in completely different places. Users get confused about which fields actually go together. Use field groups to organize related fields, making the UI consistent and intuitive. All right. So for numeric EDTs like weight, amount, or price, there's this precision property called number of decimals. This basically controls how many decimal places are supported. So amount might allow 2 decimals like $100.50, right? But what if you need 4 decimals? Something like to increase precision, you need to find the root numeric EDT. Let's say it's weight base, okay? And you extend it. In the extension, you modify number of decimals from 2 to 4. Now, all fields using weight or any derived EDTs, they support 4 decimals. But here's the constraint, and this is important. If a child EDT has number of decimals extensible set to false, you cannot modify its precision. It's locked. You can only modify precision on root numeric EDTs. Now, why this restriction? because changing precision on a child EDT could break dependent formulas or calculations. By locking precision on children, the system prevents accidental data corruption. So remember, numeric precision behaves just like string size. Changes at the root cascade down to children. Changes on children are blocked if they're locked. Once you understand the EDT hierarchy and these extensibility rules, precision management is pretty straightforward. All right, let's quickly recap what we covered in this topic. So we learned that EDTs wrap primitive types with metadata like labels, help text, and size constraints. This makes your code self-documenting and your data consistent, right? We learned about EDT inheritance. The root EDT governs fundamental properties like string size. Children inherit from the root and they cannot override that size. We learned to extend root EDTs to increase size, and those changes cascade automatically to all consumers. We learn to create new EDTs from primitives for completely new data types. Never use non-primitive EDTs as the foundation, okay? We learned about enums, which are defined lists of allowed values like good, medium, risky. Enums prevent typos and make your system self-enforcing. We also learned that enum fields can display as drop-downs, option buttons, or sliders depending on the context. We learned that field groups organize related fields for UI consistency. Now that you understand data types, EDTs, and enums, the next question is, where does this data physically live? How are tables actually structured? What are indexes and why do they matter? That's the next topic where we dive into the physical storage layer. Welcome to this topic. Now that you understand data, types, EDTs, and enums, we need to understand where that data physically lives. How are tables structured? What are indexes and why do they matter so much for performance? How does caching work and when should you actually cache data? This is the storage layer we're talking about, okay? A badly designed table with missing indexes can be literally 1,000 times slower than a well-designed one. Users click a button and they're waiting for 30 seconds because of a missing index. With the right index, that same query returns in milliseconds. Think of it like a library, right? If books are organized by topic and color, coded by genre, you find what you need instantly. If they're just thrown randomly on shelves, you're searching forever. Indexes are that organizational system for your data, and caching, it's like keeping frequently used books right on your desk instead of walking to the library every single time you need them. So in this topic, we are going to learn how to design performant tables and implement smart caching strategies. Okay, so indexes serve four critical purposes. First, performance. Without indexes, the database has to scan every single row in the table to find what you need. If the table has a million rows, it's checking all million of them, right? With an index on the search column, the database jumps directly to the matching rows. You go from seconds to milliseconds. Second, uniqueness. A primary index ensures that no two rows have the same key value. This maintains data integrity. Third, physical ordering. A clustered index defines how rows are physically stored on disk. If you cluster by customer, all the rows for customer A are physically near each other. This is really efficient for queries that filter by customer. Fourth, secondary access paths. Non-clustered indexes provide alternative ways to find data without changing the physical storage. You might cluster by date but need to frequently search by customer. A non-clustered index on customer provides that fast lookup without restructuring the physical table. Understanding these four purposes helps you choose the right index for the right problem. There are three main index types you need to know. Primary indexes uniquely identify each row. No two rows can share the same primary key value. The system uses primary indexes for default lookups and relationship enforcement. Clustered indexes define the physical sort order of the table. Rows are physically stored sorted by the clustered index columns. One table can have just one clustered index because data can only be physically sorted in one way, right? Think about a book. Pages are arranged in one order. You can't arrange them sequentially in two different ways at once. Non-clustered indexes provide additional logical entry points without changing physical storage. Many non-clustered indexes can exist on a single table. They're like separate index cards at the back of a book. You look up the topic in the index card and jump to the page. The page order stays the same. The index card just provides an alternative way to look things up. Here's a critical detail, and this is important. Column order matters in multi-column indexes. An index on customer date is different from date customer. The database engine optimizes queries based on the leading columns. If your query filters by customer first, then date user customer, date index. If you query by date first, use date customer. So how do you choose the right index? Ask yourself three questions. First, do I need a unique identifier for each row? If the answer is yes, use a primary index. The primary key uniquely identifies each record. Second, will users frequently filter or search by a specific column? If yes, use a non-clustered index on that column. For example, if users are frequently searching by customer name, add a non-clustered index on the name column. Okay. Third, do I need to organize data physically for efficiency? If yes, use a clustered index. For example, if 90% of your queries are filtering by date, cluster the table by date. All the rows with the same date are physically near each other. So range queries like dates between X and Y, they become very fast. Now, the consequences of making the wrong choices here are dramatic. Missing a critical index means a query that should return in 50 milliseconds takes 30 seconds instead. A poorly ordered cluster index means your data isn't organized for your most common queries. Take the time to understand your access patterns and design indexes accordingly, right? All right, so table inheritance lets you create a parent-child relationship between tables. A parent table defines common fields that are shared across multiple child tables. Child tables extend the parent and add their own specialized fields. For example, let's say a party table might be the parent, customer extends party, vendor extends party. Both customers and vendors have party level properties like name and address, right? But customers have credit limits and vendors have payment terms. Without inheritance, you would be duplicating the party fields in both tables. With inheritance, you define those party fields once and both tables inherit them. Two properties control inheritance. First, extends identifies the parent table. You set this to the parent table name. Second, supports inheritance is a boolean that enables the inheritance behavior. Both of these must be configured together. If you set extends but forget supports inheritance, the system doesn't recognize the inheritance. Always set both, okay? This inheritance structure reduces data duplication and ensures consistency across related table types. When you create a product in D365, you choose a subtype. This choice affects how the product behaves in the system. Product is a standalone item. It's individually identifiable and uniquely defined. No variants, no dimensions. Use product for commodities or simple items where things like size and color don't matter. Product master is a template. You don't actually sell the master itself, you sell variants of it. A t-shirt master defines that size and color are dimensions, right? Product variant is the actual SKU that gets created from a master plus specific dimension values. So a large red shirt is a specific variant of the t-shirt master. Item is the legal entity specific release of a product. You define a product globally, then you release it in each company where you're going to sell it. Each company gets its own item record. Now, why does subtype matter? It affects how the system handles variants, purchasing, sales, and forecasting. Choose the wrong subtype and the system won't work the way you're expecting it to. Make sure you understand your product structure before you start creating products, okay? When you set up a product for purchasing or planning, you define several quantity parameters that control how the system behaves. Standard order quantity is your typical lot size. Planning uses this value to generate purchase proposals. If the standard is 100 units and demand is 250, planning will suggest ordering 300 units. That's 3 lots of 100, right? Minimum order quantity is the smallest amount you can order. Maybe the supplier won't accept anything less than 50 units per order. Maximum order quantity is the ceiling. Maybe warehouse space limits you to 1000 units maximum per order. Multiple is a rounding constraint. Maybe the supplier ships in cartons of 10, so quantities have to be multiples of 10. You can't order 105 units, you have to order 100 or 110. These constraints all work together. Your minimum might be 50, your standard might be 100, your maximum might be 1000, and your multiple might be 10. Planning uses the standard to propose quantities, then it rounds to the multiple and verifies the result is between the minimum and maximum. These parameters ensure you're creating realistic, executable purchase orders. They prevent you from ordering too little, too much, or in quantities your suppliers won't even accept. Okay, let's talk about caching and why it matters so much for performance. Think about it this way. Every time you need data, you have two choices, right? Grab it from memory where it's lightning fast, or go all the way to the database, which takes significantly longer. Caching is all about keeping the stuff you use constantly in memory, so you're not making that expensive database trip every single time. Now, the cache lookup property, this is where you control how caching actually behaves. You've got EntireTable, which does exactly what it sounds like. It loads the whole table into memory. This is perfect for those small parameter tables, things like configuration settings, lookup values, code lists. If your table's got maybe 100 rows, just load all 100 once and you're done. But here's the thing, don't even think about using this for large tables because you'll just eat up all your memory, okay? Then there's NotInTTS, which caches records only when you're outside transactions. Inside a transaction block between TTSBegin and TTSCommit, your queries skip the cache entirely and hit the database directly. Why would we do that? Because when you're in a transaction, you absolutely need the most current data. Cache data could be stale, and that's a risk you can't take. Outside transactions, though, cache data is perfectly safe to use. Found is interesting. It caches the records you actually look up and find, but it also caches the misses. So if you search for record and it doesn't exist, it remembers that too. This works really well for stable master data like your vendor lists. Query the same vendor twice and that second query just grabs it from cache. Found and empty takes this a step further. It's like found, but it also caches those empty results. Use this when you're dealing with optional region-specific data. Maybe you've got region-specific tax rates that don't exist for every region. Cache both the found results and the not found results. The bottom line is you need to choose your caching strategy based on three things. How big is the table? How often does the data change? And how are people accessing it? Parameter tables, go with EntireTable. Large transactional tables, NotInTTS is your friend. Stable master data, found works great. Alright, let me give you a quick reference guide for matching caching strategies to table types. Start with parameter tables. Things like company, currency code, unit of measure. These store your configuration data. They are small, they almost never change, and literally everyone's accessing them all the time. For these, you want EntireTable. Load it once, serve it from memory always. Simple as that. Now, transaction tables are a different beast entirely. Sales order, purchase order, these things are huge. They're getting updated constantly and you need current data. For these, go with NotInTTS. What this does is ensure you're getting the latest data while still getting the performance benefits of caching when you're outside transaction blocks. Master data tables. Customer, vendor, product, these sit somewhere in between. They're stable, you access them moderately, and lookups are pretty common. Found is your strategy here. It caches when you find record, caches the misses so you're not repeatedly querying for stuff that doesn't exist. Then you've got region-specific master data, like local tax rates. These might exist in some regions, but not in others. That's where found and empty shines. Cache both the found results and the empty results. Here's the principle you need to remember. Match your caching strategy to how the data is actually used. Parameter tables need full caching because everyone needs them constantly. Transactional tables need cautious caching because you can't risk stale data. Master data benefits from that hit and miss caching. Region-specific data benefits from caching empty results. Get this combination right and you're maximizing performance while minimizing the risk of working with stale data. Table extensions, this is how you customize tables without overlaying, and let me walk you through what's actually possible. First off, adding new fields, absolutely totally allowed. Use table extensions to add whatever custom fields you need without touching the standard table. You can also add new indexes, which is great because it helps queries on your new fields run fast. Event handlers, yes, you can add those too. Pre-insert, post-insert, pre-update, post-update handlers let you inject logic whenever records are being modified. You can extend methods using something called chain of command, or COC for short. This lets you wrap existing methods to add your own behavior before or after the original method runs. Validations, absolutely add those to enforce your business rules and ensure data quality. Now here's what you cannot do, and this is important. Don't try changing structural behaviors like the primary key. Don't try modifying the data type of an existing field. Don't remove inherited fields. These kinds of changes break relationships and would require overlaying, which is deprecated and you should avoid at all costs. Extensions are the supported model going forward. They're safe, they're upgradable, and you don't have to overlay anything. Use extensions for all your customizations. If you're finding yourself wanting to overlay something, that's actually a sign you're trying to do something that's not supported. When that happens, step back and figure out the extension-based approach instead, okay? When you need to add new fields to a table, you got two supported ways to do it. Let me walk you through both. First method is to add base fields first, then assign an EDT. You create a table extension, add your new string fields, then set the extended data type property to whatever EDT you need. Could be ecores, product name, invent, batch ID, whatever makes sense. The field automatically inherits all the metadata from that EDT. Second method is actually even simpler. You just drag EDTs directly onto the table, open our application explorer, find your EDT, and literally drag it onto the table extension. The system automatically creates a field with the correct type and all the correct properties already set. Both approaches work perfectly fine. Choose based on what you're comfortable with, right? If you like building things incrementally and seeing each step, go with the first method. If you prefer just seeing the final result immediately, the second method is faster. The key principle here, and I can't stress this enough, is to always use table extensions. Never overlay standard tables. Extensions are safe, they're upgradable, and they won't cause you problems down the line. Always assign the correct EDT to ensure your metadata stays consistent. Never add enum fields when you should be adding EDT typed fields. A product name is an EcoRes product name, EDT, not an enum. A batch ID is invent batch ID EDT. Use the correct data types for whatever domain you're working in. Okay. When you're adding fields to standard forms, there are strict rules you need to follow. First thing, use form extensions, never overlay. Overlaying blocks, upgrades, and it's just not supported anymore. Extensions are safe and upgradable. Second, you need to add the data before you can display it. Create a table extension and add the field to your table first. Then create a form extension and add the field to the form. Never try to display data that doesn't exist in the table yet. That just doesn't work. Third, follow the form patterns. Every form has to have an action pane for commands, a navigation list for filtering, a grid showing your records, a details header showing key information, and a details tab for detailed entry. When you add fields, they go in the appropriate section based on this pattern. Okay. Now, when you're exposing cross company data like product names, make sure you're using the correct data source. EcoRes product translation gives you the product name in whatever language the user is working in. InventDim provides your dimension information. Apply legal entity filters to make sure you're only seeing data for the correct company. These rules exist to ensure your forms stay consistent, upgradable, and compliant with Microsoft's architecture. Follow them and you won't run into problems. Let me walk you through 4 critical mistakes people make with table design. First mistake, missing indexes. Picture this, a query is scanning your entire table looking for matching rows. You've got a million rows in there and it's checking all million of them. Slow doesn't even begin to describe it, it's absolutely glacial. Always index your frequently queried columns. Add those indexes during table design, not after you start getting performance complaints. Second mistake is overlaying tables. You modify standard table directly and sure, it works fine right now. But then Microsoft releases an update and that update conflicts with your overlay. Now you can't upgrade. Extensions completely avoid this problem. Always use table extensions. Third mistake is using the wrong caching strategy. Maybe you use EntireTable for a 10 million row table and you exhaust all your memory, or you use NotInTTS for a parameter table and you're missing out on huge performance optimization. You need to understand what type of table you're dealing with and choose your caching strategy accordingly. Fourth mistake, no cross-company handling. Your custom field inadvertently shows data from other companies. Now users are seeing vendors they shouldn't be able to see. That's a data breach waiting to happen, right? Always apply legal entity filters on custom fields, especially for cross-company data like products. Test with multiple companies active to catch these leaks before they become problems. These mistakes cause performance issues, they block upgrades, they create memory problems, and they violate data integrity. Avoid them through disciplined table design from the start. All right, let's recap everything we covered in this topic. We learned that indexes accelerate your queries. Primary indexes ensure uniqueness. Clustered indexes define the physical order of data. And non-clustered indexes provide alternative lookup paths. Column order matters a ton. Database optimization depends on those leading columns. We learned about table inheritance using the extends and supports inheritance properties. Inheritance reduces data duplication across related table types. We learned about product subtypes. You've got product for standalone items, product master as a template, product variant for SKUs, and item for company-specific releases. We covered order quantity parameters, standard for typical quantities, minimum for your flow, maximum for your ceiling, and multiple for rounding. These control realistic purchasing behavior. We learned caching strategies, EntireTable for parameter tables, NotInTTS for transaction tables, found for stable master data, and found and empty for optional data. Getting the right strategy maximizes performance without the risk of stale data. We learned that table extensions are the safe customization model. Add fields, add indexes, add event handlers, but never overlay. Form extensions follow the same principle. Add your data in tables first, then expose it on forms following the proper form patterns. Now that you understand tables and storage, the next question is, how do records relate to each other? How do we prevent orphaned data when a parent record gets deleted? That's the next topic where we make sure data integrity is maintained. Welcome to this topic. So we've designed individual tables. We've optimized them with indexes and caching. Now we need to actually connect these tables together. In real business systems, data doesn't exist in isolation. A sales order relates to a customer. An order line relates to the order header. An employee bank account relates to the employee. These relationships are the connective tissue holding your entire data model together. But here's the thing, relationships create a responsibility. When you delete a parent record, what happens to the children? If you delete an employee and leave their bank accounts just sitting there orphaned, you've corrupted your database. If you delete a purchase order and leave line items hanging around, you've created phantom data that nobody can explain and everyone's confused about. relations, and delete actions are how we prevent these disasters from happening. We define the parent-child connections, and then we specify exactly what happens when deletion occurs. Cascade automatically deletes the children. Restricted prevents you from deleting the parent if children still exist. So in this topic, we're going to learn how to design safe, clean data relationships that actually protect your data integrity. Here's the fundamental principle you need to understand. Relationships always belong to the child table, never the parent. Let's walk through an example. Say you need to track vendor exclusions. You create a new table called vendor exclusion list to store which vendors are excluded from procurement. This new table references the parent table, vend table. The child table holds the foreign key, that's the vendor ID. So the relation that connects them gets defined on the child table. Okay. Now why not just modify the parent table? Because vend table is a standard Microsoft table. If you modify it, you break updates. When Microsoft releases an update, they are modifying vend table. Your modifications conflict with theirs. The system refuses to upgrade and you're stuck. Instead, you create a new child table. Vendor exclusion list references vend table, but it's completely separate. If Microsoft updates vend table tomorrow, your new table keeps working just fine. This is the extension philosophy in action. Create new tables instead of modifying existing ones. The child table holds the foreign key. The child table defines the relationship. The child table specifies the delete behavior. The parent table stays completely untouched, right? Okay, so a relation has four key properties, right? Let me walk you through these. Okay, first one is relationship type. And this basically describes the logical ownership. Now, association means the child is independent, So technically, you could have vendor exclusions without an associated vendor, though that would be pretty unusual. Composition, on the other hand, means the child depends on the parent. So every exclusion must have a vendor, okay? Use composition for true parent-child dependencies. Now, validate. This determines whether the system actually enforces that the parent exists. Set validate to yes when parent existence is mandatory, right? So if the vendor doesn't exist, the system just rejects the exclusion entry outright. Simple as that. Foreign key. Now this is your technical binding. The foreign key field on the child table holds the parent ID, and that's the actual link between them. But on delete, guys, this is the most critical property. It controls what happens when the parent gets deleted. Okay, you've got four options here. None means let SQL handle it, which might error out. Cascade means automatically delete all the children. Restricted means block the parent deletion if children exist. And Cascade plus restricted means delete children unless another relationship protects them. Setting on delete explicitly is mandatory, and I mean this. Never rely on implicit SQL behavior. Always, and I mean always, explicitly state your intention in the metadata. So the on delete property has four options, right? Let me break down when to use each one. First up, none. Now, none is the minimal configuration. The system just leaves deletion to SQL referential integrity. So SQL might allow the deletion, might block it, might raise an error. The behavior isn't explicit. This is risky because future developers won't understand what you intended. So avoid none unless you've got a really specific reason for using it. Okay, next is Cascade. Cascade automatically deletes all child records when the parent gets deleted. This is ideal when children are completely dependent on the parent. Classic example here, employee bank accounts. If the employee gets deleted, their bank accounts should be deleted too, right? I mean, why would you keep them? Deleting the employee cascades down and removes all associated accounts automatically. Now, restricted. This one prevents parent deletion if any child records exist. This is ideal when children must never become orphaned. Great example is sales order lines. You cannot delete a sales order header if line items exist. The system blocks the deletion and prompts you to remove the lines first. Okay. And then you've got cascade plus restricted, which is conditional. Deletion cascades, but only if no other relationship with the restricted rule is protecting the child. This is for complex scenarios where a child participates in multiple relationships. The child gets deleted unless another relationship says, absolutely not protect this record. So choose your own delete based on your business rules. Can children exist without the parent? Use restricted. Must children be removed whenever the parent is removed? Use cascade. Simple as that. All right, let's work through a practical scenario together. So you need to create a vendor exclusion list. This table stores which vendors are excluded from procurement. Step 1, create a new table called vendor exclusion list. Add fields for the exclusion reason and the date. Okay. Step 2, add a foreign key field called vendor ID that references the parent vend table. Step 3, create a foreign key relation on vendor exclusion list pointing back to vend table. Step 4, set relationship type to composition because the exclusion depends on the vendor existing, right? Step 5, set your on-delete property. Now you've got two options here. If you set it to Cascade, deleting a vendor automatically deletes all exclusion entries for that vendor. And that actually makes sense. I mean, if the vendor is gone, the exclusion becomes irrelevant. If you set it to restricted, deleting a vendor gets blocked if exclusion entries exist. So the user has to manually remove the exclusions first before they can delete the vendor. Now, which one is right? Well, your business logic decides this. If exclusions are just informational, Cascade is probably fine. But if exclusions are critical audit record that must be preserved even after the vendor gets deleted, use restricted and move the exclusion to an archive table before allowing the vendor deletion. So choose intentionally based on what your requirements actually are. Okay. So when children must never be orphaned, restricted is what you need. Classic example here is purchase order header and lines. The PO header is your parent, right? Line items are the children. Now, can you delete a PO header that has line items attached to it? Absolutely not. If you delete the header and leave the line sitting there, you've got phantom line items with no header. Reports break, accounting gets confused, your data is corrupted, right? So the solution is to set on delete equals restricted on the line to header relation. Now, if anyone tries to delete the PO header and lines exist, the system blocks the deletion and tells them, you must delete all line items before you can delete the header. And so the user removes the lines first, then deletes the header, clean and safe. Restricted is your guardian here. It enforces your business logic. It prevents accidental data corruption. Use restricted whenever children must never exist without the parent being there. Okay. Now, when children should be automatically removed along with the parent, use Cascade. Perfect example is employee bank accounts. When an employee leaves the company and their record gets deleted, all the bank accounts associated with that employee should be deleted too, right? I mean, why would you keep bank account records for an employee who no longer exists? They're useless and they just clutter up your database. So set on delete equals Cascade. Delete the employee, and the system automatically cascades that deletion to all related bank accounts. Your database stays clean, no orphaned records floating around, no manual cleanup required. And Cascade can actually chain too. If bank accounts cascade from employees and payment records cascade from bank accounts, then deleting an employee cascade through the entire chain. Delete the employee, bank accounts disappear, payment records disappear. One action, complete cleanup. Cascade is efficient and it keeps your database clean. Use it when children are completely dependent on the parent and simply shouldn't exist without them. Okay, Cascade plus restricted is for those complex scenarios where a child participates in multiple parent relationships. Let me paint a picture here. So imagine a purchase order line. It relates to the PO header with restricted. So you can't delete the line if the header is being deleted. You have to respect the header, right? But it also relates to an inventory master with Cascade. So if inventory gets deleted, the line should Cascade delete. Now, if you delete the PO header, the line should cascade away. But if the inventory gets deleted, the line should cascade. But if another relation has restricted on it, the line cannot be deleted. So cascade plus restricted says this: delete the child if all the other relations permit it. If any relation with restricted is protecting the child, the deletion gets blocked. This is sophisticated stuff and it handles edge cases. Now, most of the time, you're going to use plain cascade or plain restricted. Okay? Cascade plus restricted is really for specialists designing complex domains. Don't overthink this. Start with Cascade or restricted first. Use Cascade plus restricted only when your business logic truly requires that conditional cascading behavior. All right, here's your standardized checklist for configuring any parent-child relationship. First, identify your parent and child tables. Parent is the master, like vendor, employee, customer. Child is the dependent, like exclusion list, bank account, order line. Second, create or extend the child table. Add fields specific to that child domain. Okay. Third, add a foreign key field to the child table. This field holds the parent ID. Fourth, create a foreign key relation on the child table pointing to the parent. Fifth, set your relationship type. Association if the child is independent. Composition if the child depends on the parent. Use composition unless you've got a specific reason otherwise. Sixth, set validate yes to enforce that the parent exists, no to allow orphans, which you'll rarely use. Seventh, set on delete. Cascade for automatic cleanup, restricted to prevent deletion if children exist. Cascade plus restricted for conditional behavior, none only when passive behavior is acceptable. Eighth, test the deletion behavior with actual sample data. Create a parent record, create some child record, then delete the parent. Verify the system behaves exactly as you intended, right? Follow this checklist for every relationship you create. Consistency really matters here. Let me highlight 4 critical relationship design mistakes you need to avoid. Mistake 1. Modifying standard master tables just to add relationships. So you're thinking, I'll just add a field to when table to store my custom data. Now when table is modified, when Microsoft releases an update, you've got a conflict, you can't upgrade. Instead, create a separate child table. Relations stay on child tables, master tables remain untouched. Okay. Mistake 2. Relying on none for on delete. You're thinking SQL will handle it. Maybe it will, maybe it won't. The behavior is implicit and unclear to future developers. So explicitly set on delete to either cascade or restricted. State your intention clearly in the metadata. Mistake 3. Using restricted when you should use cascade or vice versa. You set restricted thinking you will prevent accidental deletion. But your business logic actually says children should be cleaned up automatically. The system blocks deletion and users get confused, right? Or you set cascade expecting automatic cleanup, but the business says keep the children as archived record. Users are shocked when deletion cascades and data disappears. So understand your business rules and choose the right behavior accordingly. Mistake 4. Ending up with orphaned child records because deletion behavior wasn't set at all. A parent gets deleted, children are left hanging, no parent ID anymore. Reports fail, data is corrupted. Cascading or restrict prevents this always, and I mean always set on delete explicitly. Now, in multi-company systems, relationships have to respect company boundaries. The vendor master is global, so one vendor can serve all companies. But exclusions are company specific. Each company maintains its own exclusion list. Okay, so if you delete a vendor globally, what happens to the exclusions in company A and company B? They should cascade independently. Company A's exclusions cascade and delete. Company B's exclusions cascade and delete. Each company's relationship manages its own data separately. Here's the technical implementation. The child table has a data area ID field that specifies the company. The relation respects those company boundaries. Cascade only deletes that specific company's exclusions. This prevents data leaks where deleting data in one company somehow affects another company's data. Cross-company relationships are sophisticated. They require explicit company filtering. So test thoroughly to ensure deletions only affect the correct company. Don't assume the system handles this automatically. Specify it explicitly in your relation configuration. All right, before deploying any relationship, you need to test the deletion behavior thoroughly. Test 1. Delete a parent record that has no children. The deletion should succeed regardless of your on-delete setting. No children means no cascade or restriction applies, right? Test 2. Delete a parent record with children present and on-delete set to restricted. The deletion should be blocked. The system should raise an error explaining that children exist and must be removed first. Verify that error message is actually clear and helpful. Test 3. Delete a parent record with children present and on delete set to cascade. The deletion should succeed. Children should auto delete. Go into the database and verify those children are actually gone. Okay. Test 4. Delete a child record directly. The deletion should succeed regardless of the parent. Deleting children doesn't affect parents at all. Verify the parent still exists and other children remain intact. Test with realistic data. Create multiple children, trigger the cascade, verify all of them got deleted. Test partial cascades. Not all cascades automatically trigger the same way. Run these tests on a sandbox environment before you even think about production. Testing prevents those nasty surprises where deletion doesn't behave the way you expected. All right, let's recap this topic. So we learned that relationships belong to the child table, never the parent. The child holds the foreign key. The child specifies the delete behavior, okay? We learned about 4 on delete options. None for passive behavior, which isn't recommended. Cascade to automatically delete children when the parent is deleted. Ideal for dependent data like employee bank accounts. Restricted to block parent deletion if children exist. Ideal for protecting data like sales order lines. And Cascade Plus restricted for conditional cascading in complex scenarios. We learned the relationship configuration checklist. Identify your parent and child. Add the foreign key to the child. Create a foreign key relation. Set relationship type, set validate, set on delete, and test the behavior. We walked through practical scenarios like vendor exclusions, order management hierarchies, and cross-company relationships. We learned anti-patterns to avoid. Don't modify master tables. Don't rely on none. Don't choose the wrong delete behavior. And don't end up with orphaned records. We learned to always test deletion behavior with realistic data before deployment. Now that you understand how to structure tables and relationships, the next step is actually writing code, right? How do you write X++ statements? What are loops? What are variables? That's the next topic. X++ syntax, loops and variables, where we dive into programming fundamentals. Welcome to the next topic. So we've spent the first few topics learning how systems work, how to organize code, and how to structure data. Now we're ready to actually write some code. X++ is the programming language of Dynamics 365. It's strongly typed, which means every variable has a specific type, like string, integer, date, boolean. This strictness actually protects you. The compiler catches type mismatches before they become runtime bugs that blow up in production. But it also means you have to be intentional about types. You can't just pass an integer to a function that's expecting a string. You've got to convert it first. Okay. So this is the topic on X++ syntax, loops, and variables. We're going to learn how to work with types, how to convert between them, how to write conditional logic, and how to execute code using runnable classes. These are the fundamentals you're going to use literally every single day. Okay, so X++ has a strict type system. Every variable must have a declared type. Let's review the common types you'll be working with. String or str stores text like names, addresses, descriptions. Integer or int stores whole numbers like quantities, counts, IDs. Real stores decimals like prices, percentages, measurements. Date stores calendar dates. Boolean stores true or false. Type. Now the compiler enforces these types strictly. If you declare a variable as str and then try to assign a number to it without converting it first, the compiler just rejects it. This is intentional. Type safety prevents entire classes of bugs from ever happening. In a weakly typed language, you might accidentally pass a number where a string is expected. The system tries to interpret it, gets confused, and produces wrong results. In X++, the compiler stops you immediately and says type mismatch, convert it first. This can be annoying sometimes, I'll admit, but it prevents absolute disasters down the road. So when you need to convert between types, X++ provides conversion functions. Into str converts an integer to a string. If you have got the number, into str turns it into the text string. Any to str converts almost anything to a string. It's the catch-all function, okay? If you're not entirely sure what type you're dealing with, any to str usually works. Num to str converts real numbers to strings. Now, strfmt is really powerful. It lets you format complex output. Instead of manually concatenating strings together, strfmt lets you use placeholders. So strfmt and you say value first, second. This produces value first and second. This is way cleaner than string concatenation, right? str to date converts text to a date. The sequence parameter really matters here. 123 means day, month, year. So 15/1/2024 is January 15, 2024. Use these functions whenever your types don't match. Always convert explicitly. Never assume implicit conversion is going to work. Here's a practical example of why this matters. The info method writes output to the info log. It requires a string argument. Okay, if you try to pass an integer directly, like info42, the compiler rejects it. Type mismatch. Expected str got int. So the solution is to convert first info int to str42, converts that integer to the string, and then passes it to info. The output shows up in the log. This pattern applies everywhere in X++. Any method that expects a string requires you to convert first. This is actually a best practice. Always convert explicitly. Never rely on implicit conversion happening magically. Explicit conversion makes your intention crystal clear to future developers who are reading your code. Okay, Boolean expressions evaluate to either true or false. You use them in conditionals all the time. The ternary operator is a really compact way to write if else in just one line. The format looks like this. Condition, value, if true value, if false. If the condition is true, the expression evaluates to value if true. If it's false, it evaluates to value if false. Right here is an example. str category equals age greater than 18 question mark adult colon minor. If age is 25, the condition is true, so category becomes adult. If age is 15, the condition is false, so category becomes minor. Now, critical rule here, both branches must produce the same type at the destination variable. If category is a string, both adult and minor have to be strings, okay? If one branch returned a number, you'd get a type mismatch error. You can't mix types in ternary branches. This strictness prevents bugs from creeping in. So type safety in comparisons is absolutely critical. When you compare two values, they must be the same type. If quantity is an integer and you compare it to 48, that's an integer comparison, valid. If status is a string and you compare it to active, that's a string comparison, valid, okay? But if you try to compare quantity, which is an integer, to 48, which is a string, Type mismatch. The compiler rejects it outright. Never mix types and comparisons. If you've got a number and a string, convert one to match the other first. This strictness prevents subtle bugs where 100 and 100 look the same to human eyes but behave completely differently. As a string, 100 is text. As a number, 100 is a quantity. They are fundamentally different things. X++ forces you to be explicit about which one you're actually using. All right, date handling in X++ uses specialized functions. Date to num converts a date to an integer representing the number of days from the system base date. Now, why does this matter? Because internally, dates are actually stored as numbers. Date arithmetic lets you add integers to dates to move them forward or backward in time. If you've got January 15, 2024 and you add 5, you get January 20, 2024. Dates support addition like that, okay? str2date converts text to a date. The sequence parameter tells the parser how to actually interpret the text. 123 means day month here, so 15/1/2024 is January 15. 321 means year month day, so 2020 for 115 is January 15th. Here's the key principle. Date conversions are reversible if you keep types consistent. Convert a date to a number, convert that number back to a date, and you get the original date back. This makes date handling predictable and safe. Use these functions correctly and your date logic just works reliably. So X++ offers you three conditional structures. If else is the most flexible, use it for complex conditions, ranges, or combinations of logic. If quantity is less than 10, do this. Else, if quantity is less than 50, do that. Else, do this other thing. If else can handle any condition you can express, right? Switch is cleaner when you're dealing with discrete values. Switch on status, case active, case inactive, case pending. Switch compares against fixed values. When you've got a limited set of options, switch is way more readable than nested if-else statements. And then you've got ternary operator, your one-liner. Instead of writing out an entire if-else block just to assign one of two values, use ternary str label equals active question mark yes colon no. All three structures are completely valid, okay? Choose based on the complexity of what you're doing. Simple decision between two values, go with ternary. Multiple fixed options, use switch. Complex logic with multiple conditions, if else is what you need. This makes your code readable for future developers who come after you. Okay, so let me share something really important about switch statements that trips up a lot of developers, right? After each case, you absolutely need to include a break statement. Now, why is that? Well, break is what tells the program to exit the switch block. If you forget to add break, something interesting happens. Execution just keeps going and falls through to the next case below it. Let me show you what I mean with an example. So let's say you're switching on a color variable. In the red case, you set the price to 10. Sounds good, right? But here's the problem. If you don't break out of that case, the execution doesn't stop there. It continues down to the blue case, and now your price gets overwritten to 15. Then it keeps going to the green case, and price gets overwritten again to 20. So even though you matched red, your final price ends up being 20 instead of 10. That's clearly a bug, okay? The fix is actually pretty straightforward. Just make it a habit to always include break after each case. So you'd write switch on color, case red, sets price to, then break, case blue sets price to, then break, case green sets price to, then break. Now each case executes independently and stops when it's done, right? Red sets the price to 10 and exits cleanly. Blue sets it to 15 and exits. Green sets it to 20 and exits. Perfect. Forgetting that break statement is honestly one of the most common mistakes I see. So please make it a habit to always include it. Okay, so X++ gives you three different loop structures to work with. And each one has its own purpose. Let's start with the for loop. This is your go-to when you know exactly how many times you want something to repeat. The syntax looks like this. For int I equals 0, semicolon, I less than 10, semicolon, I plus plus. This loop is going to run exactly 10 times with I counting from 0 all the way up to 9. Inside that loop, you can do whatever operation you need repeated 10 times, right? Now the while loop works a bit differently. It keeps going as long as some condition stays true. Think of it like this. When the queue isn't empty, keep processing the next item. The loop continues until that queue finally empties out, okay? Then we have the do while loop, which is interesting because it guarantees at least one execution before even checking the condition. This is really useful when you need to do something at least once before deciding whether to continue. All three loops are perfectly valid. You just need to pick the right one for your situation. If you know the exact number of iterations ahead of time, go with for. If you're working with a condition but don't know how many iterations that'll take, while is your friend. Need to guarantee at least one execution? That's what do while is for. These loops are honestly fundamental to pretty much every programming language out there. Okay, let me walk you through an example of how loops work in action. So let's say we write for I equals 1, semicolon, I less than or equal to 10, semicolon, I plus plus. Inside this loop, we're going to use info strfmt to output iteration followed by whatever I is at that moment, right? So this loop runs 10 times total. When I equals 1, you'll see iteration 1 in your output. Then when I becomes 2, you get iteration 2, and this pattern continues all the way until I reaches 10, where you will see iteration 10. At that point, the condition I less than or equal to 10 becomes false and the loop stops executing. Okay. This pattern right here is absolutely fundamental to programming. You're going to use loops constantly, whether you're iterating through collections, updating multiple database records, or just repeating the same operation over and over, And here's why loops are so powerful. They eliminate code duplication. Instead of literally writing the same logic 10 separate times, you write it once inside a loop and let the loop handle the repetition for you. That's what makes loops such an essential tool. Okay, so a runnable class is really handy because it lets you execute X++ code directly without needing to navigate through the entire application UI, right? It's perfect for things like testing small pieces of logic, updating data, or running isolated operations. Let me walk you through the process. First thing you'll do is create a runnable class. Just use the runnable class template that's built into Visual Studio. Second step is adding a main method which acts as your entry point. The signature has to be exactly this: public static void main args underscore args. Inside that main method, you write whatever code you need to run. Okay. Third, this is where you put your actual business logic, updating records, selecting data, performing calculations, whatever you need. Fourth step is building the project, because compilation makes sure everything is syntactically valid. Fifth, you need to set this runnable class as your startup object. Just right click on the class and select set as startup object. Then when you press F5, Visual Studio builds everything and actually runs your class inside the D365 runtime environment. Your code executes with full access to the system. This approach is incredibly useful for debugging specific scenarios or running one-time operations without having to click through the entire user interface. Okay, let me show you what a runnable class looks like in practice. We'll call this class myDataUpdate. The main method serves as our entry point, just like we talked about, right? Inside main, we are going to declare a variable called sales table. Then we use select for update to find a sales order that belongs to customer cust001. If we find that record, we update the cust account field to cust002 and save the changes. Finally, we log a message saying update complete. This simple example really demonstrates the pattern nicely. You create a runnable class specifically to make changes to the database or test some code in complete isolation from the rest of the application. There's no need to navigate through forms or menus. You just write the code and run it directly. When you press F5, this code executes right inside the D365 runtime with full database access and everything. It's perfect for one-time data corrections, migrations, or just testing out logic quickly. All right, so I want to highlight 4 syntax mistakes that are absolutely critical to avoid, okay? First mistake, forgetting about type conversion. So let's say you try to pass an integer directly to the info function, which expects a string. You'll get a compilation error immediately. You always need to convert it first, right? Second mistake, missing that break statement in a switch. This causes fall-through behavior where values get overwritten as execution continues to the next case and your final result ends up completely wrong. Always include break, okay? Third mistake has to do with ternary operators. Both branches must produce the same type as whatever you're assigning to. You can't have one branch returning text and the other returning a number. They have to match. Fourth mistake, trying to run a class without a main method. A runnable class absolutely must have a main method. Without it, the system has no idea where to start execution. Always include that main entry point. These are honestly the most common syntax mistakes I see beginners make. Once you're aware of them and avoid them, your code will work much more cleanly. All right, so let's recap everything we've covered in this topic. We learned that X++ is strongly typed, meaning every single variable has a specific type, whether that's string, integer, real, date, or boolean. The compiler enforces these types strictly and prevents you from mixing them inappropriately, okay? We explored type conversion functions that let you convert between different types, things like into str, any to str, and strfmnt for converting to strings, or str to date for passing strings as dates. We covered Boolean expressions that evaluate to either true or false, right? We looked at ternary operators, which give you a compact way to write if-else logic in line, but remember both branches must return the same type. We went through switch statements for comparing discrete values and emphasized how critical it is to always include break after each case. Otherwise, fall through will overwrite your values. We examined conditional structures using if-else for complex logic, switch for handling fixed values, and ternary operators for simple one-liners. We explored loops in detail, for loops when you need a fixed number of iterations, while loops for condition-based repetition, and do while when you need to execute first, then check the condition. And we learned about runnable classes, how to create one, add the main method, write your code, build the project, set it as the startup object, and run it. These fundamentals form the foundation of everyday X++ programming. Okay. Now that you understand syntax, loops, and variables, the next logical step is understanding how to work with objects. How do classes actually work? What are methods? How do you structure reusable components properly? That's exactly what we're going to cover in the next topic, object-oriented programming, classes and methods. All right, welcome to this next topic. In the previous topic, we covered the basics, variables, loops, and conditionals, right? Now we're taking a step up into object-oriented programming, or OOP for short. This is really how professional code gets organized in the real world. Instead of writing long procedures with global variables scattered all over the place, we organize our code into classes. Think of a class as a blueprint for an object. It defines what data that object holds and what methods or actions it can perform. Objects give you code that's reusable, testable, and maintainable. Okay. Here's an analogy that might help. Think of a class like a recipe. The recipe specifies the ingredients and the instructions for making something. Each time you follow that recipe, you create an instance, an individual cake, for example. That cake has the same structure as every other cake made from the same recipe, but it's its own separate entity, right? That's what we mean by instances. So in this topic, we're going to learn how to design classes properly, control who can access what, define methods, and use concepts like inheritance and interfaces to build sophisticated reusable code. Okay, so access modifiers are all about controlling who can call a method or access a member of your class. Let's break this down. Public methods can be called from anywhere that the class itself is visible. If you write a public method, any code in your system that has a reference to the class can call it, right? It's essentially your class's API, the public interface. Protected methods are more restricted. They can only be called from within the class itself and from any subclasses that inherit from this class, okay? Private methods are the most restricted. They can only be called from within the same class. They're internal helper functions. Now, why would you use different modifiers? Well, it comes down to control and safety. If you expose absolutely everything as public, then every piece of code in your entire system might end up depending on it. Later on, if you need to change that method's behavior, you risk breaking all the dependent code scattered throughout your application. By making methods private or protected, you're hiding implementation details. Only the public interface is guaranteed to remain stable, right? This principle has a name, it's called encapsulation. You hide how something works internally and only expose what's actually necessary. This makes your code safer and much easier to maintain over time. All right, let me walk through the access modifiers using a concrete example so you can see how this works in practice. Okay, so let's say you have a public method called search vendor. Any code anywhere in your system can call this. It's the main interface. Someone using your class calls search vendor to find a vendor in the system, right? Now you also have a protected method called validate amount. Only your class and any subclasses that inherit from it can call this. It's shared validation logic that's useful for inheritance scenarios, but other code doesn't call it directly. Then you have a private method called get vendor cache. Only your class itself calls this internally. It's a helper function you use to retrieve cached vendor data. Other code doesn't even know this method exists. There's also internal, but that's pretty rare in X++. It's mostly there for C# interoperability scenarios. The key principle here is expose only what's absolutely necessary. Make everything else private unless you have a specific, clear reason to expose it. This is sometimes called the principle of least privilege. You grant the minimum access needed for things to work. This approach protects your code from misuse and makes it much easier to make changes later without breaking things. Okay, so instance methods operate on the state of a specific object. If you have an object representing a sales order, an instance method on that order can access all the order's data, the customer, the line items, the total amount, and so on. Each object has its own state. A different order object would have completely different data. Instance methods work with that specific object's data. You know, Static methods, on the other hand, belong to the class itself rather than to any particular instance. You don't need to create an object to call a static method. You call it directly on the class name. Okay? Static methods are typically utility functions. Since no object instance exists, static methods can't access instance variables at all. They work purely with the parameters you pass in. Here's an example. Imagine a static method that calculates the average price of all items in a list. You pass the list as a parameter and the method does the calculation. It doesn't need an object instance to do that work, right? So when should you use each? Use instance methods when you need to work with an object state. It's specific data. Use static methods when you need utility behavior that doesn't depend on any specific object. This distinction makes your code clearer and prevents misuse. All right, let me give you a practical comparison. So let's say you have an order class with an instance method called total. To use it, you first need to create an order object. You write something like order odd equals new order. Then you call odd.total. Okay. This method can access all the specific data in that order object. Now contrast that with a math helper class that has a static method called average. To use this, you don't create any object. You just call mathhelper.average directly, right? You pass it a list of values and the method calculates and returns the average. No instance state is needed for that operation. The distinction becomes really clear when you're actually writing the code. If you need to work with object-specific state, write an instance method. If you need a utility function that's more general purpose, write a static method. This clarity helps other developers immediately understand your intent when they read your code. Okay, so when you pass a parameter to a method, there are two different semantics at play, passing by value or passing by reference. Value types, things like integers, strings, reals, and dates, are passed by value. What that means is a copy gets made. The method receives a copy of the value, not the original. So any changes the method makes to that parameter don't affect the original variable. The caller's value stays exactly as it was. Okay. Reference types, tables, classes, lists, maps are passed by reference. No copy is made in this case. The method receives a reference to the actual object. So changes to the object's properties are visible to the caller. The original object gets modified. Why this difference? Well, value types are small and simple. Copying them is cheap, not a big deal performance-wise. Reference types, though, are often complex and large. Copying them would be expensive. Passing a reference is much more efficient, right? Understanding this distinction is absolutely critical to writing correct code. If you expect a method's changes to affect the caller's variable, you need to either pass a reference type or return the modified value explicitly. If you don't expect changes to propagate back, you can safely pass value types knowing they won't be modified. All right, let's see reference semantics in action with some concrete examples. First example, you have a method called update vendor that receives a ventable parameter. Inside the method, it changes the name property. Now, ventable is a reference type, so this change is visible to the caller. Okay, after calling update vendor, the caller's ventable object has the new name. The change persisted, right? Second example, you have a method called add1 that receives an integer parameter. Inside the method, it increments that integer. But here's the thing, integer is a value type, so the change is not visible to the caller. After calling add1 with the value 5, the caller's integer is still 5, not 6. The method worked with a copy. This distinction prevents a lot of confusion. When you pass a table record to a method, you know that any changes made will be visible back in your calling code. When you pass an integer or string, you know the caller's variable won't change. This clarity makes your code predictable and easier to reason about. Okay, so an abstract class defines shared structure, but here's the key thing. You can't actually instantiate it directly. You can't create an instance of an abstract class itself. Instead, you create instances of concrete classes that extend the abstract class. Let me give you an example. So let's say vehicle is abstract. It defines a speed property and an abstract method called accelerate. Car and truck both extend vehicle. Both of them have to implement the accelerate method, but car might accelerate faster than truck based on their specific logic. Both share the speed property that's defined in vehicle. Both honor the accelerate contract. So why use abstract classes? Well, they enforce consistency. Every child class must implement the same methods. They also provide shared code. If vehicle had a method like get current speed, both car and truck inherit it automatically. They don't have to duplicate that code. Abstract classes are perfect for defining a family of related classes that share some common structure and behavior, but need to implement certain things differently. All right, so abstract classes and interfaces both define contracts, but they serve different purposes, and it's important to understand the distinction. Okay. Abstract classes can have state, meaning they can have fields that store data. They can have private and protected methods. They can have fully implemented methods that children inherit directly without having to override them, right? However, a child class can only inherit from one abstract class. Interfaces, on the other hand, have no state at all. All methods in an interface are purely public signatures with no implementation body. Interfaces are pure contracts, just method signatures, But here's the flexibility. A class can implement multiple interfaces. So when should you use each? Use abstract classes when you want to share actual implementation code, like a base vehicle class with common methods that both car and truck can use without rewriting. Okay. Use interfaces when you want to enforce a contract without sharing implementation, like a drawable interface that anything capable of being drawn must implement. You might have a car that's both a vehicle and drawable. It can extend one abstract class and implement multiple interfaces at the same time. Interfaces give you more flexibility because of this multiple inheritance capability. Okay, let me show you how interfaces work in practice. So let's say you define an interface called iPayable with a method signature getAmount. Invoice implements iPayable and provides its own implementation of getAmount based on invoice logic. Expense also implements iPayable with its own implementation of getAmount based on expense logic. Right? Now here's what's interesting. Invoice and expense are completely unrelated classes. They don't share an abstract parent at all, but both implement the same contract through iPayable. So code that works with iPayable can work with either an invoice or an expense without caring which specific type it is. This is really powerful, okay? Any class that can calculate an amount implements iPayable. The calling code doesn't need to know whether it's dealing with an invoice, an expense, or some other payable entity. It just calls getAmount and gets the result. This flexibility is exactly why interfaces are so valuable in object-oriented design. They define behavior that completely unrelated classes can share through a common contract. All right, let me show you a complete inheritance example that ties this all together. We have employee as an abstract class. It has name and salary fields and a getName method that's shared by all employees. Okay. It also has an abstract method called calculate bonus. Every employee type needs to calculate bonuses, but they do it differently, right? Manager extends employee. It adds a team size field specific to managers. Its implementation of calculate bonus calculates 15% of salary. Developer also extends employee. It adds a year's experience field specific to developers. Its calculate bonus calculates 10% of salary plus 100 for each year of experience. Both manager and developer inherit the name, salary, and getName method from employee. They get that for free. But both must implement calculate bonus in their own way. This is inheritance in action, okay? You have shared structure and behavior in the base class, but specialized behavior in each child class. Both managers and developers are employees with names and salaries, but they calculate bonuses differently based on their specific circumstances. The abstract class ensures both types implement calculate bonus, but each does it their own way. Okay, let me highlight 4 critical OOP mistakes that developers commonly make. First mistake, exposing everything as public. Sometimes developers make all methods public because they're not sure what external code might need to call, right? The problem is now every caller in your entire system might depend on every single method. When you inevitably need to change a method later, all that dependent code breaks. The rule is keep things private unless there's a specific reason to expose them. Second mistake, trying to use static methods to access instance state. You might think, I'll just use static to access this data. But static methods can't access instance variables at all. The compiler will reject this. If you need to access instance state, you must use instance methods. Third mistake, partial interface implementation. You implement an interface but accidentally forget to implement some of the methods. You'll get a compilation error. When you implement an interface, you absolutely must implement every single method it defines. The compiler enforces this strictly, right? Fourth mistake, overlaying standard Microsoft classes. You modify a standard class directly to add your functionality. When Microsoft releases an update, you get conflicts and can't upgrade smoothly. You should use extension classes instead. Okay. These mistakes are common, especially when you're learning, but they are definitely preventable once you understand OOP principles properly. All right, let me share 4 core OOP design principles that lead to good, maintainable code. First is encapsulation. Hide the implementation details inside your class. Expose only what's necessary through a clean public interface. Okay, this makes your code robust and easy to change internally without breaking external code. Second is inheritance. Share common structure and behavior through abstract classes. Specialized classes extend the base class and add their own specific behavior, right? This dramatically reduces code duplication. Third is polymorphism. Write code that works with interfaces and abstract classes rather than concrete types. This makes your code flexible and able to work with new types in the future without any modification. Fourth is extensibility. Use class extensions to add behavior to standard classes rather than modifying them directly. Never modify standard classes in place. Extensions are safe and remain compatible with upgrades. Okay, these principles work together to create code that's maintainable, robust, and scalable. Follow them consistently and your code will be cleaner and much easier to work with long term. Okay, so let me walk you through a practical process for designing OOP structures, right? So first step is you need to identify the required state. Now, what does that mean? Basically, does your class have fields that child classes are going to need to share? If yes, then you create an abstract class with those fields defined in it. But if the children need completely different state, they might not even need to share an abstract parent at all. Okay. Second step, identify the required behavior. So are there methods that all children should have? Right? Common behavior that belongs in the parent class. Specialized behavior that's going to belong in the individual child classes. Now, third step, decide between instance versus static. So most of your methods, they're going to be instance methods that work with object state. You only use static for utility functions that genuinely don't depend on any object state. All right. Fourth step, define access levels carefully. So what I recommend is make everything private by default as a starting point. Then you expose only what's necessary, protected for things subclasses need, public for your external API. This disciplined approach, it creates clean, maintainable class hierarchies that are, really easy to understand and work with. All right, guys, let's recap this topic and everything we've covered about object-oriented programming. Okay, so we learned about access modifiers, public for your external API, protected for behavior that subclasses need, and private for internal logic. The goal here is encapsulation by limiting exposure to what's truly necessary, right? Now we learned the distinction between instance methods that operate on object state and static methods that are general utilities. You choose based on whether the operation depends on instance-specific state. We covered parameter passing semantics, value types, they get passed by copy, reference types get passed by reference. Understanding this is really crucial for preventing bugs. We explored abstract classes, which define shared structure and behavior that children inherit and extend. We covered interfaces, which define contracts that completely unrelated classes can implement. Interfaces, they enable flexible polymorphic code. Okay. We discussed key design principles like encapsulation, inheritance, polymorphism, and extensibility. We emphasized that you should always use class extensions rather than overlaying standard classes directly. All right. And we walked through a design process. Identify required state, identify required behavior, choose instance versus static, and define appropriate access levels. Now that you understand how to structure code properly using classes and methods, the next question is how do you actually work with data safely? How do you handle errors gracefully when things go wrong? That's what we're covering in the next topic, data manipulation and exceptions, where we learn to query data, update it correctly, and handle problems professionally. Welcome to this topic, guys. So we've learned how to write code using objects and methods, right? Now we need to actually work with data, query it efficiently, update it correctly, and handle errors gracefully when things inevitably go wrong. This is really where theory meets reality. If you look at most bugs in production systems, they come from data manipulation mistakes. You query the wrong set of record, you update something without properly considering concurrency, an exception occurs, and you don't handle it appropriately. So this topic, it's all about safe professional data handling. Okay, we're going to learn how to query data efficiently, update it correctly without corrupting anything, and recover from errors gracefully. This is about data manipulation and exceptions. Master these patterns and you'll write code that's not just functional, but robust and genuinely production ready. So the select statement, this is how you retrieve data in X++, and it's absolutely fundamental, right? At its simplest, you select all fields from a table, like customer table. You can add a where clause to filter the results. For example, show only active customers. You can add an order by clause to sort the results alphabetically by name or any other field. Okay. Now, behind the scenes, the select statement translates directly into a database query. The database executes it and returns the matching records to your X++ code. Understanding select is truly fundamental to everything you do. Every single application feature queries data in some way. A report needs select statements. A form needs select statements. A batch job needs select statements. Master select, and you've unlocked the foundation of most X++ development work. Okay, so there are two different ways to order your query results, and it's good to understand both, right? You can use order by with a field name explicitly. For example, select vehicle order by vehicle ID sorts the results by vehicle ID in ascending order. This is clear and explicit. Anyone reading the code knows exactly what field you're sorting by, okay? Alternatively, you can use index ordering, which uses a predefined index. Select vehicle index, vehicle ID, IDX uses the vehicle index for sorting. This is efficient if the index already exists and happens to sort exactly the way you want. So when do you choose each? Use field ordering for clarity and explicitness. Use index ordering if the index perfectly matches your sorting requirement and you want to leverage its performance. All right. Now, one thing to note here. Never try to use an index name in an order by clause. That's a compile error. Order by only accepts actual field names. If you want to leverage an index for sorting, you use the index keyword separately. Okay. So where clauses, they filter your records down to what you need, right? For example, where account num equals 1, 2, 3, 4 returns only that specific customer. Now joins, they let you combine data from multiple tables, and inner join shows only customers that have sales orders. If no order exists, that customer doesn't appear. An outer join shows all customers and includes their sales orders when they exist or null if they don't. An exists join shows customers that have at least one sales order. Okay. And here's an important one, not exists join. This shows customers that have no sales orders at all. Now, why is not exist so important? Because you often need to ask business questions like what things don't have related records. Not exist solves this perfectly. Questions like show me customers with no sales orders, or show me inventory items that have never been purchased, or show me vendors with no open orders. Not exist is your tool for finding the absence of relationships, and that's incredibly useful for analysis and reporting. Okay, so let me show you a real use case for not exists, right? Say you want to find customers who have no sales orders. These could be potential untapped opportunities for your business. Okay, so you'd write select all from cust table not exist, join sales table, where sales table.cust account equals cust table.account num. Now what this query does is it starts with all customers in your system, then removes any that have a sales order. What remains are customers with zero orders. Okay. This is perfect for targeting marketing campaigns or investigating why certain customers haven't been buying from you. Not exist is incredibly useful, but often overlooked by developers. Master it and you can answer all sorts of interesting business questions. So for update is really important when you're about to modify data, right? It tells the system, I'm about to modify this record, so lock it so nobody else can change it while I'm working. The pattern is select for update, then modify the fields you need to change, then call the update method to save your changes. Okay. For update ensures you have exclusive access to that record. So if two users try to modify the same record at exactly the same time, one gets the lock and proceeds, while the other one waits until the lock is released. This is called pessimistic concurrency. You lock the record upfront to prevent conflicts. All right. For update is essential when you're making changes to data. Without it, you risk concurrent modification problems where two users change the same record and one user's changes get lost completely. Okay, so there are two different approaches to updating data, and understanding when to use each is important, right? Set-based updates, they use update underscore record set, which can change thousands of records in a single SQL statement. This is extremely fast and efficient. It's perfect for bulk operations like mark all invoices over 30 days old as due. Now, the trade-off is that no validation logic runs, no events fire. It's just raw data update at the database level. Okay. Row-based updates, they use the update method, which processes one record at a time. Each record runs through validation, events fire, business logic executes. It's slower but much safer because everything gets properly validated. So when do you use each? Use set-based for bulk updates, where you don't need validation logic to run. Use row-based for updates that absolutely must run through business logic and validation. And never use do update. That's considered an anti-pattern because it bypasses everything. Choose based on your needs, speed or safety. So transactions, this is how you ensure all or nothing semantics when modifying data, right? TTSBegin starts a transaction. Everything between that begin call and the commit call is part of the transaction as a unit. If any step fails, maybe an exception gets thrown, maybe a validation error occurs, the entire transaction rolls back. All changes get undone and the database returns to its state before the transaction started. Okay. This is absolutely critical for maintaining data integrity. Now imagine you're transferring money between accounts, your debit account A and credit account B. If the debit succeeds but the credit fails for some reason, you've literally created money out of thin air. That's obviously bad, right? Transactions prevent this scenario. Either both operations complete successfully or neither does. You should always wrap data modifications in transactions. TTS begin marks the start of your transaction boundary. TTS commit marks the end. If an exception occurs anywhere in between, you don't call commit and the transaction automatically rolls back. So try catch finally. This is how you handle errors gracefully instead of just letting your application crash. Okay. The try block contains the code you want to execute. Now, if an exception occurs during execution, maybe division by zero, maybe a record isn't found, maybe there's a permission denied error, control immediately jumps to the catch block, right? The catch block is where you handle the error. You might log it, you might fix the underlying issue, you might recover from it somehow. The finally block always runs regardless of whether the try block succeeded or the catch block handled an error. Finally is where you clean up resources or perform any necessary housekeeping. Okay. So the flow is completely deterministic. Try executes first, catch executes only if there's an error, and finally always executes at the end. This structure prevents your application from crashing when something goes wrong. Instead of crashing, you catch the error and handle it appropriately. Okay, so the retry statement, it restarts the try block from the very beginning, right? You use it when your catch block actually fixes the underlying problem. Here's an example. Say you get a network timeout error. Your catch block waits 100 milliseconds and then calls retry. The next attempt might succeed because the network has recovered. Okay, this is really powerful for dealing with transient errors, network glitches, temporary database locks, brief service unavailability. A retry combined with a short wait can solve these issues, but, and this is absolutely critical, only use retry when your catch block actually fixes the underlying problem. If your catch block does nothing and just calls retry, you're just going to repeat the failing code over and over, creating an infinite loop. Your application will hang, right? Never retry endlessly without reason. Always make sure your catch block is fixing something or include a retry counter to limit the number of attempts. So different types of exceptions, they need different handling strategies, and understanding this is key to robust error handling. Okay. If a database connection fails, you should catch it, wait a moment and retry. The connection might recover. If a record isn't found, you should catch it, log the issue and return null or some default value. Don't retry in this case because retrying won't magically make the record appear, right? If validation fails, catch it and notify the user. Don't retry because the same validation is just going to fail again. Now, for unexpected errors that you don't specifically anticipate, catch them, log thoroughly for debugging purposes, and throw the exception upward so the caller knows something went wrong. Okay. Understanding which errors are recoverable and which are permanent is really the key to good exception handling. Recoverable errors get retry logic, permanent errors get logging and propagation upward. Okay, so let me show you a complete exception handling pattern that's production ready, right? Here's how it looks. You start with try and inside you perform your update within a transaction. Now, if you catch an exception of type deadlock, you know this is temporary and recoverable. Deadlocks, they happen in multi-user systems. The retry statement will wait implicitly and try the operation again. Okay. Now, if you catch a generic exception, means something unexpected happened that you didn't specifically anticipate, you log it thoroughly and then throw it upward so the calling code knows something went wrong. Then in the finally block, you log that the operation completed, which is useful for auditing, right? This pattern is genuinely production ready. It handles the specific deadlock case intelligently while still catching other errors and propagating them appropriately. This is how professional code handles exceptions in real-world scenarios. So sysquery range util, this provides really useful helper functions for building filters dynamically, especially date filters. Okay. Current date returns today's date. Month range returns the first and last day of the current month. Date range lets you specify a custom date range, right? These functions are incredibly useful for reports and forms that need to filter by dates. Now, there's also wildcard filtering, which uses asterisks, similar to how SQL uses person signs. If you set range.value to asterisk wholesale asterisk, it finds all records that have wholesale anywhere in the name, beginning, middle, or end. These utility functions, they save you a ton of time and ensure consistent filtering logic across your entire system. Learn them well and filtering becomes straightforward. Okay, guys, so there are two concurrency models to understand, and they take different approaches to handling conflicts, right? Pessimistic concurrency locks records upfront when you select them for update. You get exclusive access immediately. If two users try to modify the same record, one gets the lock and proceeds, while the other waits until the lock is released. It's simple and safe. Okay. Now, the downside is lower throughput in high concurrency scenarios because locks block other users from proceeding. Optimistic concurrency takes a different approach. It doesn't lock at read time. Instead, it checks the rec version field when you try to update. If rec version matches what you originally read, the update succeeds. nobody else changed it. But if another user changed the record in the meantime, rec version will have changed and your update fails. You detect the conflict and can retry if appropriate, right? The advantage is higher throughput because there are no upfront locks blocking other users. The trade-off is more complexity because you must handle conflicts when they occur. So when do you choose each? Pessimistic for moderate concurrency systems where simplicity is valued, optimistic for high throughput multi-user systems where scalability matters. D365 defaults to optimistic concurrency for better scalability in large deployments. Okay, so let me highlight 4 critical data manipulation mistakes that cause disasters in production, all right? Mistake number 1, missing a where clause in your update statement. Your update affects every single row in the table instead of just the target rows. This is a disaster scenario. Always include a where clause unless you genuinely intend to update every record. Mistake 2, using do update directly. This bypasses all business logic, validation, and events. You're writing directly to the database with no safety checks. This leads to data corruption. Never use do update except in very specific kernel code scenarios, okay? Mistake 3, no transaction boundaries around your data modifications. Data changes should be atomic. If something fails halfway through, a rollback should restore consistency. Always wrap related modifications in TTSBegin and TTS commit, right? Mistake 4, catching out exceptions silently. You write a catch block with empty braces and no action. This hides errors completely. Your application appears to run fine, but data is getting corrupted and you have absolutely no clue why. Always handle exceptions specifically or at minimum rethrow them, okay? These mistakes, they cause production disasters that can be really expensive to fix. Avoid them by following proper patterns. All right, guys, let's recap this topic and all the ground we've covered on data manipulation and exceptions. Okay, so we learned that select statements are how you query data, where clauses filter record, order by sorts them, and joins combine multiple tables. Not exist is particularly useful for finding entities that don't have related records. We learned that for update locks records so you can modify them with exclusive access, preventing concurrent modification issues. We covered set-based updates using update underscore record set, which change many record in one SQL statement without running validation. Great for performance. We also covered row-based updates using the update method, which process one record at a time with full business logic and validation. Okay. We learned that transactions ensure all or nothing atomicity. Either everything succeeds together or everything rolls back. Try catch finally lets you handle exceptions gracefully instead of crashing. Retry restarts the try block for recoverable errors like temporary network issues. We explored 2 concurrency models. Pessimistic locks records upfront for simplicity, while optimistic detects conflicts at update time for better throughput. And we covered critical anti-patterns, missing where clauses, using do update directly, forgetting transaction boundaries, and catching exceptions silently. All of these cause production disasters, right? Master these patterns and you'll write data manipulation code that's safe, fast, and maintainable. Now that you can query and manipulate data safely, the next question naturally becomes, how do you extend standard D365 code without overlaying it? How do you add behavior to Microsoft standard classes without modifying them directly? That's exactly what we're covering in the next topic, class extensions and chain of command, where we learn how to extend safely without breaking anything. Welcome to this topic, guys. So we've learned how to write code, query data, and handle errors properly, right? Now we need to learn probably the most important pattern in D365 development, how to extend standard D365 code without breaking it. This is genuinely critical, okay? Microsoft ships standard classes, tables, and forms as part of the base product. You should never modify them directly, never. Instead, you create extension classes that augment the standard code without touching the originals. The platform is smart enough to stitch your extensions into the standard classes during compilation. Your code runs as if it were actually part of the original class. This pattern is called composition over inheritance, and it's the foundation of building safe, upgradable systems. All right. This is about class extensions and chain of command. Master these patterns, and you'll build code that's safe, maintainable, and survives Microsoft's upgrades without breaking. Okay, so an extension class, this is how you add functionality to a standard class without modifying it at all, right? Here's the process. You create a new class with the underscore extension suffix in its name. Mark it as final and public. Then you use the extension of attribute to declare which class you're extending. Okay, the compiler sees this attribute and stitches your extension into the base class during compilation. From that point forward, the base class has your new methods available. Callers use the base class normally and automatically get access to your new functionality. This is incredibly safe because you never touch the standard code at all. When Microsoft releases an update to that standard class, there's no conflict. Your extension just continues working alongside the updated base class, right? This is the real power of extensions. Safe, conflict-free customization. Okay, so let's look at this complete structure here. You've got the extension of attribute, right? So this basically tells the system which class you're extending. Now the final keyword that's required, you can't extend an extension, okay? Public keyword is also required because, these methods need to be accessible. Now inside this structure, you'll add your methods. So instance methods, they work with object state, while static methods are utilities that operate on the class itself. Both are completely valid and both become part of the base class. Now, this structure isn't optional, it's mandatory. If you skip any of these requirements, your code simply won't compile. Okay, so when you're adding instance methods, the method gets access to the objects, fields, and properties. So let's say you have a sales table order and you call order.process order, right? That method can now access order.cust_account, order.total, basically all the orders data. Now with static methods, it's different. The method doesn't need an object at all. Okay, it's just a utility on the class. So you'd call sales table, calculate tax, pass in your parameters and get your results back. Static methods are really useful for calculations and utilities that don't depend on object state. So here's the rule of thumb. Choose instance when you need the object's data. Choose static when you just need a utility function. Makes sense, right? Okay, let me show you a practical example here. So let's say you're extending the sales line table. You add a method called calculate line total. Now inside that method, you calculate quantity times unit price. Here this keyword refers to the table record, so you can access any field on that table. Now when you have a sales line record, you just call calculate line total and you get the result. This method becomes part of every sales line record. It's clean and reusable. So instead of duplicating that calculation logic everywhere throughout your code, you put it once in the extension and you're done. All right. So chain of command is all about wrapping an existing method to add behavior before or after it runs. Here's an example. You override the insert method, you add your validation logic before calling next insert. Now that next keyword, it invokes the original insert method. After that insert completes, you can add post logic like logging. This is really powerful because you're not modifying the original method, you're wrapping it. Okay. Now, multiple extensions can wrap the same method, each adding its own behavior. These wraps chain together. So one calls next, which calls the next wrapper, which eventually calls the original. This composition approach is both safe and elegant. Okay, let's talk about a practical chain of command pattern. So your pre-logic runs before the original method. This is perfect for validation, authorization, or setup tasks. Now, if validation fails, you throw an error and the original method never runs, right? Then you've got the core, which runs the original method via next. After that, your post logic runs. Once the original method completes, use this for logging, notifications, or secondary updates. Now, both pre and post are optional. You can have just pre logic, just post logic, or both. This flexibility is what makes chain of command so powerful for cross-cutting concerns. Okay, here's a critical rule. Your chain of command wrapper signature must match the base method exactly. Same parameters, same return type. So if the base method is void update with no parameters, your wrapper is void update with no parameters. Okay. If you try to add a parameter, it's not a wrapper anymore. It's a different method and the compiler will reject it. This strict matching ensures the wrapper intercepts every single call to the original method. Maintaining signature integrity isn't negotiable here. Now, static methods can also be wrapped with chain of command. The wrapper must all be static, obviously. The pattern is identical. Pre-logic, next invoke, post-logic, return. This is useful for wrapping static utilities. So for example, you might wrap calculate tax to add logging every time tax is calculated. The wrapper needs to be static, just like the base method. This ensures the method chain works correctly. Okay, so when you're extending tables, you actually use two extensions. First, a table extension to add fields. This creates the new field on the table itself. Then a class extension with chain of command to wrap methods and add logic. So when a sales line is inserted, your chain of command wrapper runs. It calls next insert, then populates your custom field. This pattern keeps field definitions separate from behavior, clean separation of concerns, right? Both extensions are required. One for fields, one for logic. All right, so you need to follow the extension pattern exactly. Create an extension class, mark it final, mark it public, use the extension of attribute. This is the correct and the only supported way to do this. Now never inherit from the base class using extends. Most standard classes are sealed anyway and won't compile if you try. Never skip the final keyword, never skip the extension of attribute. Following this pattern isn't optional, it's mandatory for D365 upgradability and supportability. Okay, let me walk you through 4 critical extension mistakes. So mistake number 1, modifying standard code directly. You change a Microsoft class. Now when Microsoft releases an update, you get a conflict and you can't upgrade, use extensions instead. Mistake number 2, calling next conditionally. So you wrap a method inside an if statement. If the condition is false, next doesn't run, which means the original method doesn't run. This leads to data inconsistency. Never wrap next in conditionals, either always call next unconditionally or don't call it at all. Okay. Mistake number 3, changing the chain of command signature. You try to add a parameter or change the return type. You get a signature mismatch and a compilation error. Signatures must be identical. Mistake number 4, creating a non-final extension. You skip the final keyword. This violates extensibility rules and causes issues down the line. Always mark your extensions final. Okay, here's a realistic scenario. You've got a sales order insert. You add pre-logic. If the amount exceeds 10,000, mark it as requiring approval, right? Then you call next insert to run the original logic. After the insert completes, you send it for approval. So this pattern intercepts every single sales order insert and adds your approval workflow. No modification of standard code whatsoever, just a clean extension that wraps the insert method. All right, so form extensions let you customize standard forms without modifying them. You create a form extension for sales order form, use the form designer to add new controls, add data sources if you need them, follow the standard form patterns, action pane, navigation list, grid, details header, details tab. Now, when you add a field to the form, it automatically binds to the data source if that field exists in the table or table extension. Okay. Form extensions are visual and designer friendly. Most form customization doesn't even require code. Okay, so professional customization uses all 3 extension types together. You extend the table to add fields, you extend the class to add logic and wrap methods, you extend the form to expose those new fields. This layered approach maintains clean separation, data layer extensions, business logic extensions, UI extensions. They all work together seamlessly. This is the standard D365 customization pattern. All right, so let's recap this topic. We learned that extension classes are marked final and public with the extension of attribute and underscore extension suffix. The compiler stitches these extensions into the base classes. We learn to add instance methods that work on object state and static methods that are utilities. We covered chain of command, which wraps existing methods. So pre-logic runs before next, post-logic runs after. The wrapper signature must match exactly. We learn to extend tables, classes, and forms together. So table extensions add fields, class extensions add logic, form extensions add UI. We covered the anti-patterns, modifying standard code, conditional next calls, signature changes, non-final extensions. All of these cause problems. Safe practice is simple. Always extend, never modify. Now that you understand how to extend code safely, the next question is, how do you trigger your code when certain events occur? How do you mark up your code with metadata? That's the next topic. Events and attributes, where we'll discover advanced customization patterns. All right, welcome to this topic. So we have learned to extend code with extensions and chain of command. Now we need to trigger that code at the right moment. Events are how you know something important just happened. A record was validated, a form was opened, a field was changed. By subscribing to these events, your code runs at exactly the right time. Now, attributes are how you mark up your code to control what can and can't be extended. Can other developers wrap this method with chain of command? Is this method deprecated and shouldn't be used? Attributes answer these questions. So this topic is all about events and attributes. Master these patterns and you'll build code that reacts intelligently to user actions and system events. Okay, so validate write is the primary validation method on tables. It runs whenever a record is being saved, whether it's an insert or an update. So a user enters data or a form and clicks save. Validate write runs. If validation passes, the record saves. If it fails, the save is blocked and the user sees an error. This is the correct place for business rules that must prevent persistence. Okay. Validate write runs regardless of how the data is entered. Forms, batch jobs, integrations, web services. Every save path goes through validate write. This is why it's so powerful for enforcing data integrity. All right, so there are three table methods related to validation. Validate write runs at save time for all entry points. This is where you put your business rules. Validate field runs during form entry for individual fields. So a user tabs out of a field, validate field runs to check that specific field. Now insert and update methods persist the data. Don't put validation here, therefore persistence, not validation. Okay. The pattern is clear. Validate write for record level business rules, validate field for field level UI feedback, insert and update for persistence. Okay, here's how you create table validation. You create a handler class marked subscribes to. Inside that, you create a static method that matches the validate write signature. The method receives the table record. You implement your validation logic. Now, if validation fails, you call check failed with an error message. This method gets called every time the table is validated. Users on forms, batch jobs, integrations, all of them go through this handler. This is the standard supportable way to add validation. All right, so there are two scopes of validation. Table level validation applies everywhere. Forms, integrations, batch jobs, all entry points executed. It's perfect for data integrity rules that must always be enforced. Now form level validation applies only to that specific form. Only users on that form see it. This is perfect for workflow specific rules or rules that depend on form context, So for example, a sales order must have a customer. That's a table level rule enforced everywhere. But a sales order on the executive dashboard requires credit approval. That's a form level rule only for that dashboard. Choose the right scope based on where the rule applies. Okay, so event handlers follow a clear pattern. You create a handler class marked subscribes to. Inside that, you create static methods that listen for specific events. Each method is decorated with an attribute specifying the event. The method signature matches the event signature. You implement your logic. Now, the system automatically calls your handler when the event occurs. This pattern is clean, declarative, and easy to follow. New developers can quickly understand this handler listens for that event. Okay, so there are two ways you can actually block a save, right? First one is check failed, which displays an error message to the user. So basically, the message explains why the save failed, so users can understand what went wrong and correct it. Now, the second way is return false, which blocks the save but without any visible message. So let me tell you when to use what. Use check failed for user facing validation, right? And use return false for internal checks that should just fail silently. Now, most of the time, most validation should use check failed because it helps users understand what's actually happening. Now, chain of command can also add validation to business process methods. Let me give you an example. So let's say we have confirm purchase order. Now, what you do is you wrap this method in a chain of command extension. Okay. Then you add pre logic to check vendor approval. So if the vendor is not approved, right, you just return early without calling next. And just like that, the purchase order confirmation is prevented. So basically, this integrates validation right into the process flow. The validation happens at exactly the right moment, which is before confirmation runs. This is uh, this is really powerful for process level validation, guys. Okay, so extensibility attributes, they control how your methods can be extended. Let me break this down. Hookable true allows event handlers to subscribe. Hookable false prevents event handler subscription. Right. Now, wrappable false prevents chain of command wrapping, and replaceable, it allows chain of command to replace the method without requiring next. So basically use these attributes to control your API surface. Mark critical methods as not wrappable to protect them. Mark observation points as hookable to allow subscribers. Now, here's the thing. These attributes make your intentions explicit to future developers, which is very important. So let me tell you when to use hookable true. Use it for methods you want developers to observe or extend. For example, let's say process order. Now, other developers might want to log when an order is processed. So mark it hookable and they can subscribe. Now use hookable false for security, sensitive or core methods. Like let's say validate security should never allow event handlers to bypass it. So you mark it non-hookable. This is very important because this protects security and stability. So basically mark your public APIs intentionally to guide extension points. Okay, so this absolute attribute, it marks deprecated methods. Now, when you refactor and you want developers to use new code, you mark the old method as obsolete. Now, here's the powerful part. If the second parameter is true, calling the old method produces a compilation error. So basically, developers are forced to update their code. This is very powerful for enforcing refactoring across large code bases, right? So instead of gradually having code fragments call both old and new methods, sysobsolete forces an immediate cutover, and this keeps the code base clean. Now, event handlers and chain of command, they serve different purposes. Let me explain. Event handlers are for observation and lightweight logic. Okay. So you subscribe to an event, check something, maybe block an action. It's lightweight and non-invasive. Now, chain of command, that's for wrapping or replacing methods. So we are talking heavy modification of logic, process changes, and behavioral overrides. Now, here's the thing. Event handlers have higher stability because they're non-invasive, right? Chain of command requires careful design because you're replacing core logic. So basically choose the right tool for the job. Let me give you a realistic validation rule here. So let's say vendors have a risk rating low, medium, high. Now the rule is prevent saving high risk vendors without approval. So what do? You create a validation handler. Subscribe to Ventable validate right. Check the risk rating. If it's high, you call check failed. Now anytime anyone tries to save a high risk vendor, the save is blocked with a clear message. Batch, jobs, forms, integrations, all blocked. So basically, this enforces data integrity universally. This is uh, this is professional grade validation, guys. Okay, let me cover 4 critical mistakes here. Mistake number 1, putting validation in insert or update. Now these persist data, they don't validate it. Use validate right instead, right? Mistake number 2, putting UI only validation at table level. This affects integrations and batch jobs that don't have the form context. So use form level validation for that. Mistake number 3, missing the hookable attribute. Now your intentions are unclear to future developers, so mark it explicitly. And mistake number 4, sys obsolete with false. That's soft deprecation that developers will just ignore. Use true to force refactoring. So basically, these mistakes reduce code quality and extensibility. Now, professional event handling follows specific patterns. So first thing, organize your handlers by domain. Vendor handlers together, customer handlers together, right? This makes code easy to find. Use descriptive names like vendor.onValidating right is clear. Avoid generic names like on event. Now, mark handler classes final to prevent accidental extension. They are subscription endpoints, not extension points. Okay. Use the right scope, table level for rules that apply everywhere, form level for UI specific workflows. So basically, discipline in event handling makes the system reliable. All right, so let's recap this topic. We learned that validate right is the primary table validation trigger. It runs for all save operations, right? Validate field validates individual fields during form entry. Now insert and update, they persist the data they don't validate. We learned that event handlers subscribe to events without modifying code. So you create a handler class, implement static methods, decorate them with event attributes. We learned the hookable attribute controls whether methods can be subscribed to. So mark public APIs as hookable, mark security methods as non-hookable. We learned chain of command wraps business process methods for conditional logic. Pre-logic validates before next, okay? We learned sys obsolete marks deprecated code. The second parameter true forces a compilation error, preventing use. And we learned event handling best practices, organized by domain, use descriptive names, mark handlers final, use appropriate scope. Now that you understand events and how to control extensibility, the next question is how do you extend enums and add fields to tables safely? That's the next topic, table and enum extensions, where we'll customize data structures. Welcome to the next topic. So we've learned to extend code with classes and events. Now we need to extend the data structures themselves, enums and tables. Now enums define fixed lists of values like order, status, or risk rating. Tables define the structure of your data. Both need to be extended safely without modifying Microsoft standard definitions. Now, this is where many developers make critical mistakes. They edit standard enums directly, breaking upgrades. They use integer values instead of enum literals, causing fragile code. So this topic is table and enum extensions. Master these patterns and you'll extend data structures the right way, safe, upgradable, and maintainable. Okay, so enum extensions let you add values to standard enums without modifying them. Let me give you an example. So let's say order status enum has open, confirmed, shipped. Now you need to add on hold and cancelled. What you do is you create an enum extension and add your new values. The system merges them at compile time. So now order status has all 5 values, 3 original, 2 from your extension. The base enum remains completely untouched. Microsoft can update it and your extension continues working. Now there's a critical requirement though. The base enum must have isExtensible set to true. This property controls whether extensions are allowed, right? Most standard Microsoft enums are extensible. If not, you must request Microsoft to make it extensible. Now isExtensible is the gateway property. So you open the base enum in Application Explorer and check the isExtensible property. If it's true, you can create enum extensions. If it's false, extensions are blocked. Now, why would an enum be non-extensible? Usually it's security, sensitive enums, or core system enums, where Microsoft needs tight control. So if you encounter a non-extensible enum, you need to extend, submit an extensibility request to Microsoft. They'll evaluate it and may make it extensible in a future release. So basically always check this property first before planning an enum extension. Okay, let me walk you through the complete enum extension process. First, verify the base enum is extensible true. Second, create an enum extension. You right-click the base enum in Application Explorer and select Create Extension. Third, add new elements, name them clearly, on hold, cancelled. Fourth, build the project. Compilation merges the extension into the base enum. Fifth, use the new values in code, reference them as order status on hold. So this 5-step process is clean, safe, and upgradable. Follow it every time you need to add enum values. Now here's the critical rule. Never use integer values for enum comparisons. Why? Well, enums are assigned integers internally, but that assignment isn't guaranteed to be stable. So if someone adds a value to the middle of the enum, the integers shift. Now your code checking if status equals 3 now references the wrong status. Your code breaks. So instead, always use enum literals. Order status on hold. The compiler validates the literal exists, right? If the enum changes, the compiler catches mismatches and the code is self-documenting. Anyone reading it knows exactly which status is being checked. This is non-negotiable, guys. Enum literals everywhere. Now, range checks are another anti-pattern. So code like if status greater than or equal to 3 and less than or equal to 5. It assumes the enum values are consecutive integers. This is fragile. If someone adds a value in the middle, the range changes meaning. If the enum is reordered, the range becomes meaningless. So instead, explicitly list the statuses you care about in a switch statement. Case order status on hold, case order status cancelled, case order status pending. Now this is verbose but crystal clear, right? The compiler validates every case. Future developers understand exactly which statuses are being handled. So never use ranges, always be explicit. Now, when you add enum values, you often need to add logic that handles them. Let me give you an example. So let's say the process status method handles open, confirmed, shipped. Now you add on hold and cancelled. How do you add handling for these new values without modifying the base method? Well, you create a post event handler. The handler runs after the base method. Okay. Inside, you switch on the status and handle only your new values. The base method already handled the original values. Your handler adds logic for the extensions. So this keeps the base method untouched while extending behavior. Clean separation. Okay, so table extensions add fields to standard tables. Let me give you an example. So sales line has quantity, unit price, total. Now you need custom field and approval status. What you do is you create a table extension and add your fields using the correct EDTs. Build and synchronize the database. Now the fields are part of sales line. Forms can display them via form extensions. The base table remains untouched, right? This is the standard pattern for adding data to Microsoft tables. So never modify the base table, always create a table extension. All right, let me walk you through the complete table extension process. First, create a table extension object. Right-click the base table and select Create Extension. Second, add new fields. Choose the correct EDT for each field. So custom field might be a string, approval status might be an enum, right? Third, add fields to field groups if you want them displayed on forms. Field group make it easy for forms to show related fields together. Fourth, build the project. Compilation validates the extension. Fifth, synchronize the database. This updates the SQL schema to include your new fields. Six, extend forms to display the new fields. So table extensions and form extensions work together. Okay. This 6-step process is safe and complete. Now, table extensions allow you to change some properties but not others. So what's allowed? System tracking fields like created by and modified by, form ref, and preview part ref for UI references, title field 1 and title field 2 for display, tags for metadata. These are safe to change in extensions, right? Now, what's not allowed? Primary index, clustered index, table group. These are structural and affect database schema and relationships. Changing them would break the table. Delete actions and relations are also protected. So you need to understand what you can change and respect the boundaries. Okay. Trying to change protected properties results in compilation errors. Okay, so let me walk you through a complete scenario here, right? We're going to add an approval workflow to sales orders. So first thing we need to do, we're going to extend the order status enum to include a new pending approval status. Now then we'll extend the sales table itself, to add a couple of fields. We need approval date and approved by. Now here's where it gets interesting. Okay. We'll create an event handler on the same method. And what this does basically is check if the order amount goes over 10,000. If it does, we automatically set the status to pending approval, right? After that, we create another event handler on process status. So when the status hits pending approval, it triggers our approval workflow. You see how this all comes together? We're combining enum extension, table extension, and event handlers, all three of them working in harmony to implement our business requirement. And the best part, we're not modifying any standard code. Everything's done through extensions, which means it's safe and completely upgradable. Let me tell you about 4 critical mistakes people make with extensions. So mistake number 1, using integer values for enum comparisons. This is really fragile because it breaks the moment the enum changes. Always use enum literals instead, right? Mistake number 2, doing numeric range checks. The problem here is you're assuming the values are consecutive, but that breaks when enums get reordered or extended. You should always list out explicit cases. Now, mistake number 3, and this one is a big deal, overlaying the base enum to add values. When you do this, you're blocking Microsoft updates and breaking your upgrades. Always use enum extensions instead, okay? And mistake number 4, duplicating the base table to add fields. This creates incompatible types and breaks relationships all over the place. The right way, table extensions. These anti-patterns, they're surprisingly common and they cause real production problems. So please avoid them. Once you've implemented your extensions, you really need to test them comprehensively. Let me walk you through what that looks like, okay? So test number 1, make sure the original enum values still work. Your base logic for open, confirmed, shipped, all of that should still function perfectly. Your extension shouldn't break any existing behavior, right? Test number 2, now check your new enum values. Make sure an event handler actually executes for on hold and cancelled. Test number 3, let's verify those new table fields, save some records with your new fields populated, then query them back and verify the data actually persists and retrieves correctly. And test number 4, open up the forms and make sure your new fields appear in the right places with the correct labels. Thorough testing like this prevents those nasty surprises in production. Remember, extensions should be additive. They shouldn't break anything that's already working. Let me share 5 best practices for working with extensions. Okay, so practice number 1, always check that is extensible property before you plan any enum extensions. Don't just assume an enum can be extended. Verify it first. Practice number 2, use enum literals everywhere. Never use integer values, never use ranges. Always reference them as order status value, right? Practice number 3, keep your event handlers minimal They should only handle your extension values. Don't duplicate the base logic. Practice number 4, document all your extensions. List out the new enum values, the new table fields, the handlers you added. Future maintainers need to understand what you've extended and why. And practice number 5, always synchronize the database after making table extension changes. Those new fields don't actually exist in SQL until you sync. Following these practices ensures your extensions are high quality and maintainable over time. All right, let's recap what we covered in this topic. Okay, so we learned that enum extensions let us add values to standard enums, but the base enum has to have is extensible set to true. You create the enum extension, add your values, and reference them as enum name : value. Right. We also learned to always use enum literals for comparisons. Never integers, never numeric ranges. Both of those are fragile and break when enums change. Then we covered how event handlers extend logic for new enum values. Post handlers run after the base methods and handle your extension values, while the base logic stays completely unchanged. We learned about table extensions and how they add fields to standard tables. You create the table extension, add fields with the correct EDTs, build it, and synchronize the database. We also learned that you can change limited table properties like created by form ref and title fields, but structural properties, those can't change. And finally, we emphasized comprehensive testing, making sure base behavior is unchanged, your extension values work, and forms display correctly. Now that you understand how to extend data structures safely, the next question naturally is, how do you build consistent user interfaces? What are form patterns and why do they actually matter? That's what we're diving into next, where we'll learn to build professional, consistent UIs. Welcome to this topic. So we've learned how to extend code and data. And now we need to build the user interface that actually displays and modifies that data, right? Forms are how your users interact with the system. A well-designed form follows patterns that are consistent across D365, which means users understand the layout immediately. The navigation feels intuitive. Data entry is smooth. Now, form patterns are these standardized structures that enforce consistency. Microsoft provides patterns like simple list, list page, details master, workspace. Each one has a specific purpose and structure. And here's the thing, choosing the right pattern is absolutely critical. Okay, pick the wrong pattern and the form just feels out of place or functions poorly. So that's what this topic is about, form patterns. Master these patterns and you will build interfaces that are professional, consistent, and genuinely user-friendly. So what exactly are form patterns? They're standardized combinations of UI components. You've got the action pane, which holds your commands and buttons. There's a navigation list that filters or organizes records. The grid displays your list of records, and the details area shows fields for editing. Right? Now, different patterns combine these elements in different ways. For instance, a simple list might have just a grid with no details area. A details master might have a grid, navigation, and a really rich details section. Each pattern serves a specific purpose. Okay, the pattern determines the layout, which components are required, and how they behave. Choosing the right pattern ensures the form fits your business requirement and follows D365 standards. There are two supported ways to apply patterns. So method number 1 is through the designer. You right-click the design node and select apply pattern. A list pops up with all the available patterns. You choose one and the designer automatically applies it. Components get added, structure gets set, all automatic, right? Method number 2 is through metadata. You open the design node properties and set the pattern property to your chosen pattern. This assigns it at the metadata level. Uh, both methods work, both are safe and supported, neither introduces any risk. Use whichever feels more natural to your workflow. I'll say though most developers use the designer method because it's visual and you see the results immediately. Let me walk you through the 5 primary form patterns. Okay, so simple list is minimal, it's just a grid, perfect for basic reference data like units of measure. List page handles large data sets with advanced filtering, great for master data like customers. Now, details master is the rich one. You get the entity plus related records in tabbed details, ideal for complex data like sales orders. Simple list and details is kind of the middle ground, a grid with a details panel for moderate complexity. And workspace is for dashboards and monitoring with KPIs and tiles. Right? Each pattern is optimized for its specific purpose. When you choose the right pattern, the form just feels natural and performs well. Here's a decision tree you can use for pattern selection. Start by understanding the requirement. Are you dealing with a complex master entity that has many related details? That's details master. Is it a large data set that users need to filter extensively? List page. Do you need a grid plus a details panel for editing? Simple list and details. Is it just a simple reference grid? Simple list. Or maybe it's a dashboard with KPIs and metrics. That's workspace, right? Walk through these questions and the right pattern becomes pretty obvious. Each question narrows down your choices. This systematic approach ensures you're choosing the pattern that actually matches the requirement. Simple list is the most minimal pattern. It has an action pane for your buttons and a grid for displaying records. That's literally it. No details panel, no complex navigation. Okay. Users see a list and they can add, edit, or delete record. It's perfect to reference data like units of measure or currencies, data with just a small number of fields. It's quick to implement and easy to navigate. If you don't need a details panel or any complex structure, simple list is your go-to choice. Details Master is the most sophisticated pattern. It combines an action pane, a navigation list for filtering, a grid for records, and a really rich details area with fast tabs. Now, these are vertical tabs showing related information. It's perfect for complex master entities like sales orders. And the header grid shows your orders. You click an order, and the details area shows line items, shipping address, delivery history, all in separate tabs. Fast tabs are these collapsible sections that reduce visual clutter while keeping information accessible. Right? Details Master is powerful, but you need a complex entity structure to actually justify its complexity. Simple list and details is that middle ground pattern. Okay, it has an action pane, an optional navigation list, a grid, and a details panel with tabs. It's not as minimal as simple list, but not as rich as details master either. Perfect for scenarios like a vendor exclusion list. The grid shows your excluded vendors. You click one, and the details panel shows the reason, effective date, and approver information. Users can add, edit, or delete exclusions without dealing with overwhelming complexity, right? This pattern is ideal for custom tables and extensions where you need both the grid and detailed editing, but you don't need the full richness of Details Master. Here's a comprehensive comparison. Okay, so simple list is the simplest, just a grid, minimal complexity, no filtering for basic reference data. List page is for large datasets with advanced filtering but no details panel. Simple list and details has the grid plus details panel, moderate complexity, basic filtering for custom tracking. Details master is the most complex with navigation, grid, rich details, advanced filtering for master entities, right? Think of this as a spectrum from left, that's simple, to right, that's complex. Find where your requirement sits on that spectrum and match it to the pattern. This comparison makes the selection pretty straightforward. Different patterns use different tab styles, okay? So horizontal tabs are those traditional tabs across the top. They're older, but still supported. Fast tabs are vertical tabs along the left side, and they're collapsible like accordions. They're modern and used in Details Master and Simple List and Details. Fast tabs reduce visual clutter because you can collapse the tabs you don't need right now. Inline tabs are a minimal visual representation. Each tab style fits different design goals, right? Fast tabs are generally preferred for modern forms because they're space efficient and really intuitive. Extending forms safely uses 3 layers working together. Okay. So first layer is the table extension where you add new fields using the correct EDTs. For example, EcoRes product name for product name. Second layer is the form extension where you add UI controls to display those fields. You add a new group in the details panel, then add text controls for the new fields. Third layer is event handlers that populate the fields. You use an onInsert handler to look up and populate the product name when a record gets created, right? All 3 layers work together. None of them modify standard code. They're all extensions. Safe and upgradable, this layered approach keeps your code clean and maintainable. Let me give you a real world example. Okay. So let's say your inventory status form needs product name and batch ID. First, you extend the table, add an EcoRes product name EDT field for product name and an invent batch ID EDT field for batch. Second, extend the form by adding a new group in the details panel for inventory details. Third, add text controls that bind to these new fields. Fourth, create an event handler that subscribes to on inserted. Fifth, the handler receives the new record. Sixth, It looks up product information via the release product master and populates the product name field, right? Seventh, it gets the batch information and populates the batch field. Now users see the form with product name and batch automatically populated, no manual entry needed. This is what professional form extension looks like. Integration architecture has two distinct paths. Okay. So the batch path works like this. You pull XML files from SFTP, run a batch job periodically, maybe nightly, read those files and insert the raw data into a staging table. Then you use the data management framework to map staging fields to target table fields, transform the data as needed, and write the transformed data to your target tables and sales order headers. Right. This handles bulk periodic imports. Now the real-time path is different. External systems call OData endpoints, data arrives immediately. The system validates the schema against EDTs and field definitions, processes the data and updates inventory immediately. It logs changes for audit visibility. Batch is for high volume periodic updates. Real time is for immediate updates. Both are valid and they are often used together. Let me tell you about 4 critical form design mistakes. Okay. So mistake number 1, choosing the wrong pattern. Like using simple lists for complex data, the form just feels inadequate and the user experience suffers. Always choose the pattern that matches the complexity. Mistake number 2, modifying standard forms directly. You edit a Microsoft form, then when Microsoft releases an update, you've got a conflict. You can't upgrade. Use form extensions instead, right? Mistake number 3, inconsistent tab styles. You mix fast tabs with horizontal tabs and users get confused. Different forms start looking different, which breaks pattern consistency. Stick to one style. Mistake number 4, extended fields that aren't populated. You add fields to the form, but you don't implement handlers to populate them. Now users have to manually enter data that should be looked up automatically. Always implement handlers to auto-populate. Here are 5 best practices for form design. Okay. So practice number 1, choose the correct pattern. Really understand the requirement and match it to a pattern. Don't try to force a simple list to do complex work. Practice number 2, use extensions only. Never modify standard forms. Extensions keep your code safe and upgradable. Practice number 3, populate your extended fields. When you add fields, implement handlers to populate them automatically. Don't make users manually enter data that could be looked up. Practice number 4, follow fast tab conventions. If your pattern uses fast tabs, use them consistently. Don't mix tab styles. And practice number 5, document your pattern choice. In comments or design documentation, explain why you chose this pattern. Future maintainers will understand the design decision. Discipline in form design makes the system professional and maintainable. Okay, so let's quickly recap what we covered in the previous topic. We learned that form patterns, they basically enforce consistency across D365, right? So you've got simple list, which is for minimal grids. Then there's list page for large data sets. Details master for those complex entities. Simple list and details, that's when you need a grid plus a details panel. And workspace, that's for your dashboards. Now, the key thing here is you need to choose patterns based on the complexity and functionality you actually need. Make sense? And so we learn to apply these patterns either through the designer or through metadata properties. Both ways work fine. Okay. Now, details master and simple list and details, they use these vertical fast tabs, which are basically just collapsible sections, right? We also covered safe form extension. So you extend the table, then you extend the form, and then you add event handlers. All 3 layers, they work together. We talked about integration architecture too. You've got batch imports via SFTP plus data management, and then real-time updates through OData. Both paths serve different needs, And then best practices, choose the right pattern, use extensions only, populate those extended fields, follow the conventions, and document your decisions. Now that you understand form patterns, the next question is, okay, how do you actually extend and customize forms? Like how do you add controls? How do you modify layouts? That's what the next topic is all about, form extensions and controls. That's where we dig into the details of form customization. Welcome to the next topic. So we've learned about form patterns and how to choose the right structure. Now we need to customize forms to match our specific requirements. Things like adding fields, adding sections, displaying related information. And here's the thing, we do all of this without touching the standard code. This is where form extensions really shine. So basically you create an extension on the base form, you add your controls and you bind them to your data. The base form, it remains completely untouched. So Microsoft can update it and your extension just continues working. Pretty cool, right? That's what this topic is all about. Form extensions and controls. Master these patterns and you'll be able to customize forms professionally and safely. Okay, let me walk you through the complete form extension workflow. So first thing, you locate the base form in Application Explorer and you right click it. Second, you select Create Extension. The system creates a new extension object for you automatically. Third, it's automatically named following the conventions. So it'll be something like baseform name dot model name dot extension. Fourth, you open the design and you add your controls, text boxes, groups, buttons, whatever you need, right? Fifth, you bind those controls to data sources from your table extensions. So you set the data field property, and that's what connects the control to the table field. Sixth, you build and compile. Now your extension is active. So every time someone opens that form, your extension gets merged in. The user sees the base form plus your customizations. Safe and upgradable. Naming conventions, guys, this is absolutely critical here. So you use base form name dot model name dot extension. Let's say you have sales table dot HR dot extension for a sales table extension in the HR model, or custable dot finance dot extension for a customer form in the finance model. This pattern, it's consistent across forms, tables, and classes. It's immediately recognizable as an extension. You know, now what not to do? Don't use sales table dot extension without the model name. That's ambiguous and non-standard. Don't use random naming like sales table X, and don't use underscores instead of dots. Naming matters because future developers, they need to recognize extensions at a glance. Consistent naming is professional. Okay, so adding new fields requires two extensions working together. First, the table extension. This is where you add the new fields using correct EDTs, like EcoRaise product name for product name, invent batch ID for batch ID. Second, the form extension. You add a new group to the form design, maybe in the details section. Then you add text controls for each new field, and you set the data field property to point to your table extension field. Data field, that's what binds the control to the data, right? Now, when you open the form, your new fields appear and they are bound to the table data. Users can view them, edit them. This two-step process, it keeps your data and UI synchronized. So you need to choose the right control for each data type. Control for strings, integer control for whole numbers, real control for decimals, date control for dates, enum control for drop-down lists, button control for actions. Each control has properties. Label for the display name, help text for the tooltip, extended data type to enforce the EDT validation. Setting these properties correctly, it ensures the control works as intended and provides a good user experience. A label should be descriptive. Help text should briefly explain what the field's for, and extended data type should match your table field's EDT. Here's a critical rule, okay? Create extensions only from the base form. So you right-click the base form in the AOT and select Create Extension. This is the supported safe method. Never add the base form directly to your project. That's not an extension. Never try to modify the base form that overlays it and breaks upgrades. And never create a new form with a matching name. That's a duplicate, not an extension, right? The system knows when you're creating an extension and it validates the structure. If you try to bypass this and modify the base directly, the build fails or you get overlaying. Both are bad news. Always use create extension from the base form. Factor boxes. Okay, so these are read-only displays that show context-specific information for the currently selected record. They're perfect for list pages. So let's say a user selects a customer and the fact box shows customer totals, balance, last order date, all that contextual info. Fact box uses a form part control that displays a secondary form. That form queries the related data and displays it. When the user selects a different customer, the fact box refreshes automatically. Fact boxes, they're ideal for operational awareness without having to open additional forms. It reduces clicks and improves user productivity. There are four filtering mechanisms. Filter pane is a structured multi-field filter. Users click the fields they want to filter and enter criteria, and the system builds a query. Advanced filter slash sort is more powerful. Users can build complex queries with joins and ranges. Both are formal structured filtering. Okay. Then there's column filter, which is simpler. You just click a column header and filter that one column. And quick filter is a search bar in the grid. Users type text and it searches. So for formal filtering, filter pane and advanced filter slash sort are your two primary mechanisms. Both support complex filtering logic. Column filter and quick filter, They're more like convenience filters, Display methods can really hurt performance if they execute expensive queries. Let me give you some optimization techniques. First, use sysclient cache data method attribute with the true parameter. This caches the method result per record. So if multiple controls call the same method, they get the cached result, no repeated query. It's very effective, right? Second, set visible to false for display methods you don't actually need to show. Hidden controls don't execute their display methods, which eliminates wasted queries. Now, don't use enabled equals false. That doesn't prevent method execution. It just makes the control read only. And don't use skip equals true. That only affects tabbing order, no performance benefit. Cache and hide. Those are your tools for display method optimization. Form extension classes, they subscribe to form events and add behavior. So form data source.init runs when the data source initializes. Use it to set up defaults or calculations. Form data source.write runs when a record is saved. Use it to perform validations or updates. Form control.modified runs when a user changes a field. Use it to update related fields or enable and disable buttons. Form extension classes work alongside form extensions. The form extensions add UI controls, and the form extension classes add behavior. Together, they provide complete customization. This keeps your code separated from the UI structure. Here's a real world scenario. Let's extend the customer form with credit limit and last order date, okay? So first, the table extension adds credit limit as a real type and last order date as a date type. Second, form extension adds a new group in details. Maybe call it financial information or something. Third, add text controls for the new fields. Fourth, create a form extension class with an on-written handler. Fifth, the handler validates that credit limit is positive when they save. Sixth, the handler queries the sales tables to find the customer's last order and populates last order date. The result, the form shows credit limit and last order date. The data gets auto-populated on load, it's validated on save. Users see a rich form with calculated data, all done safely via extensions. Let me tell you about 4 critical mistakes. Okay. Mistake number 1 is modifying base forms directly. You think you're just adding a field, but then weeks later, Microsoft releases an update with a conflicting change. Now you can't upgrade and it breaks everything. Use extensions. Mistake number 2, adding the base form to your project instead of creating an extension. This creates an overlay situation. When Microsoft updates the form, your copy doesn't get the updates. You're stuck with old code. Use create extension from the base form. Mistake number 3, adding controls but not binding them. You add a text box but forget to set data field. No data appears and users just see an empty box. Always bind controls to data. Mistake number 4, display methods that execute expensive queries. The method runs for every row. So a grid with 100 rows runs that query 100 times. The form crawls. Cache the method or hide the control. These mistakes, they cause real production problems. Here are 5 best practices. Practice number 1, always use create extension from the base form. Never try workarounds. This is the supported method, okay? Practice number 2, follow naming conventions consistently. Base form dot model name dot extension. It should be recognizable at a glance. Practice number 3, bind all controls to data sources. Don't add orphaned controls with no data. Set data field and properties correctly. Practice number 4, optimize display methods. Cache expensive methods or hide unnecessary ones. Performance matters. And practice number 5, document your extensions. In code comments or design docs, list the controls you added and why. Future maintainers, they need to understand your changes. Discipline makes form extensions professional and maintainable. Professional form customization, it uses 3 layers. So the base form is Microsoft's standard. Form extension adds the UI. New controls, groups, layouts. Form extension class adds the behavior, event handlers that run when certain things happen. All 3 layers work together that are kept separate. It's clean separation of concerns. Base form stays untouched. UI customization goes in the form extension. Behavior customization goes in the class extension. Each layer has a specific responsibility. This architecture ensures safety, maintainability, and clarity. Future developers will understand the separation. Okay, so let's recap this topic. We learned to extend forms safely. Always create the extension from the base form. Never modify the base directly. Follow naming conventions. Base form.model.extension. Add controls via the form designer. and bind each control to data via the data field property. Extend tables and link form controls to table extension fields. Both have to work together, right? Use fact boxes to display related information for selected records. Fact boxes are powerful for operational awareness. Implement the 4 filtering mechanisms: filter pane, advanced filter slash sort, column filter, quick filter. The first two are formal. Optimize display methods with the caching attribute or by hiding unnecessary controls. Use form extension classes for behavior. Event handlers run at appropriate lifecycle moments. It's a 3-layer architecture. Base form extension for UI, class extension for behavior. All separate, all safe, all professional. Now that you understand form customization in depth, the next question is, okay, how do you organize navigation? How do you build dashboards and workspaces? That's the next topic. Menus, workspaces, and tiles. That's where we learn navigation architecture. Welcome to the next topic. So we've built forms and extended them. Now we need to figure out, okay, how do users actually navigate to them? How do users actually access your custom forms? Through menus, right? How do they see important information at a glance? Through workspaces and tiles. Navigation is absolutely critical to user experience. Well-organized menus and dashboards, they make systems easy to use. Confusing navigation just frustrates users, you know? So that's what this topic is about: menus, workspaces, and tiles. We learn about 3 menu item types: display for forms, action for processes, output for reports. We learn to build operational dashboards using tiles and workspace elements. We learn how users can personalize their experience. Master these patterns and you'll create professional navigation that guides users intuitively through your system. There are 3 menu item types. Okay, display opens interactive forms. You click a menu item and a form opens. Users see data, can edit, can navigate. Action runs a runnable class like a batch job or processing routine. You click the menu item, the class runs, processing happens. Output runs an SSRS report. You click the menu item, the report displays, and users can print or export. Each type has a specific purpose, right? Display is for UI interaction, action is for processing, output is for reports. Choosing the right type is critical. Wrong type and the menu item just won't work. Here's a simple decision process. What do users need to do? Open a form and interact with data. Display menu item, run background processing or a batch job. Action menu item, run a report. Output menu item. This decision tree, it's clear and deterministic. No ambiguity. Each question points to exactly one answer. Use this every time you create a menu item. Display menu items open forms. So you create a display menu item called customer maintenance. You set object type to form and you set object to cust table. Now when users click this menu item, the cust table form opens. They see the list of customers and they can add new customers, edit existing ones, delete them. Display works for list pages, detail forms, dialogues, any form that requires user interaction. This is actually the most common menu item type. All right. So action menu items, right? These are what you use when you need to run batch jobs. So let's say you're creating one and you call it calculate late fees job. You set the object type to class. Okay. And then you set the object to calculate late fees runnable. That's the class where you implemented your runnable logic. Now here's what happens. So when users click this menu item, that class kicks in and runs. The batch processing executes, late fees get calculated, and the job either completes right away or runs in the background, right? Now, action menu items, they're perfect for things like automation, those nightly batch jobs we all love, integration syncs, basically anything that doesn't need someone sitting there interacting with it. This is actually the second most common menu item type you'll work with. Now let's talk about output menu items. These are specifically for running reports. Okay. So imagine you're creating an output menu item called sales analysis report. You'd set the object type to report and the object would be sales analysis, which is your SSRS report. When users click this menu item, the report fires up and displays in the report viewer. From there, users can apply whatever parameters they need, print it, export to PDF or Excel, all the usual report stuff. Here's something important, right? Output is the correct type for report execution. Don't try to run a report through a display menu item. It just won't work. Remember this. Display is for forms. Output is for reports. Keep those separate. Okay. So you want to add a report button to a form? Let me walk you through this. Okay. First thing you do is create an output menu item for that report. Second, you're going to add a menu item button control to the form. And notice I said menu item button, not just a regular command button, right? There's a reason for that. Third, you'll set the button's menu name property so it points to your output menu item. Fourth, the button shows up on the form, users click it, and boom, report runs. This pattern is really clean and maintainable because the menu item lives in the AOT, where you can actually find it and reuse it later. Command buttons can't reference reports directly, and that's by design. Always use menu item button when you're dealing with reports. Workspaces contain 4 different types of elements, and each one serves a specific purpose. Okay, first you've got tiles. These show you a count or a KPI. Something like, let's say, pending confirmation orders 24. Users click on it and it filters to show exactly those orders. Then there are links, which are simple navigation kind of menu style, right? Users click and it opens a form. Third, you have lists, which show an embedded grid right there inline in the workspace. Users click a row and it opens that records form. And finally, there's the Power BI visual, which embeds analytical charts and dashboards. Users can interact with those charts to drill down into the data. You know, each element really does serve different purposes, so choose based on what information you're trying to surface. Let me show you how to display a KPI in a workspace. Okay. First, you create a KPI measure in the AOT. Let's call it pending order count, and it calculates the number of pending orders. Second, you create a tile in the workspace. Third, you bind the KPI to that tile by having the tile's properties reference the KPI. Fourth, the tile now displays the KPI value, right? Fifth, when users click the tile, the system applies the filter and shows them the underlying list. This is really the standard pattern for operational dashboards. The KPI measures are your data source, and the tiles are how you display them. Tiles can show you record counts, which is super useful, right? So let's say you create a tile for pending confirmation orders. Your query would be status equals pending and confirmation equals false. The tile calculates everything and shows 24 pending. When users click that tile, the system applies this filter and displays those 24 pending orders in a list. Okay? Tiles are perfect for operational awareness because at a glance, managers can see exactly how many orders need attention. One click, and they're drilling into the details. This is what professional dashboard design looks like. Users actually have the ability to personalize their own workspaces, which is pretty powerful, right? Here's how it works. A user opens a form and applies a filter. Maybe they want to show just orders from 2024. Then they go to the options menu and select add to workspace. A dialog pops up asking which workspace they want and what presentation style. Link gives them that menu style view. List shows an embedded grid. Tile shows a count. User picks what they want, and that filtered view gets added to their workspace. The cool thing about personalization is it's pure user action, no development required. Users are customizing their own experience. This really empowers users to tailor dashboards to their specific needs. A personalization toolbar gives users a lot of control over their interface. Okay. You've got the selector, which identifies an element. Users click it to select a field or control they want to customize. Then there's the move tool, which lets them rearrange elements. Users can reorder grid columns to match their preferences, which is really useful when you want to focus on the important columns, right? The hide tool does exactly what you'd expect. It hides elements so users can hide fields they don't need. And then there's personalization settings, which manages the overall personalization options. Users have full control over their layout. This is professional UX design at work. You're empowering users to customize things the way they want. Let me give you a real workspace example. Okay, picture a sales operations workspace. The first tile shows 24 pending confirmation orders. Click to drill down. The second tile shows 8 overdue shipments. Click to drill down, right? The third tile shows your revenue KPI for this month. The fourth tile is actually a link to create new orders. And the fifth element is a Power BI chart showing monthly trends. When you put all this together, this workspace gives sales managers everything they need in one place. You get operational awareness at a glance, and you're just one click away from drilling into the details. This is professional dashboard design, combining all these element types into one cohesive user experience. Let me tell you about 4 critical mistakes that I see all the time. Okay. The first mistake, using a display menu item for a report, it won't work. Display opens forms, not reports. You need to use an output menu item, right? The second mistake, using an action menu item to open a form, again, won't work. Action runs classes, not forms. You need a display menu item. The third mistake, trying to link a report directly to a command button, not supported. Command buttons don't have report properties, so you need to use a menu item button that references an output menu item. The fourth mistake, modifying standard menus directly. You change a Microsoft menu, and then when Microsoft updates it, you've got a conflict, you can't upgrade. Okay, use menu extensions instead. These mistakes will break your navigation and prevent upgrades. Now let's cover 5 best practices. Right. The first practice, use display menu items for opening forms. This is the standard approach. The second practice, use action menu items for batch processing and automation. This is how processing actually works on the system. Okay. The third practice, use output menu items for running reports. Never mix report execution with forms. Keep them separate. The fourth practice, extend standard menus using menu extensions. Never modify Microsoft menus directly. Extensions keep your code safe and upgradable. The fifth practice, use tiles to make your workspaces operational. Tiles show important information and allow users to drill down. When you're disciplined about navigation design, it makes your systems professional and intuitive. All right, let's recap this topic, okay? We learned about 3 menu item types. Display opens forms, and it's the most common one you'll use. Action runs batch classes for processing. Output runs SSRS reports, right? Choosing the right type is critical because the wrong type will just break the menu item. We also learned about workspace elements. Tiles show KPIs and counts. Links provide that menu style navigation. Lists show embedded grids. Power BI visuals show analytics. We learned how to populate workspaces with meaningful information, and tiles are really the best option because they're actionable. Users can click to drill down. We covered personalization, where users apply filters, click options, and add to workspace. No development required. Users are tailoring their own experience. And we went through best practices: display for forms, action for processing, output for reports, extend menus instead of modifying them, and personalize with tiles. Now that you understand navigation and dashboards, here's the next question. How do you move bulk data? How do you import thousands of records efficiently? That's what we're covering in the next topic, data entities and DMF, where we learn about the data management framework. Welcome to this topic, okay? We've built forms, we've extended them, and we've created navigation. Now we need to handle bulk data operations, right? Think about it. How do you import thousands of vendor records? How do you export sales data to external systems? How do you integrate with other applications like Power Apps or Salesforce? Data entities are the answer here. They are an abstraction layer that exposes table data for integration, and the data management framework is what processes them. This is our next topic, data entities and DMF. Master these patterns, and you'll be building professional data integrations that move data safely and efficiently. Data entities are an abstraction layer. So let me explain what's going on underneath. Okay. You've got SQL tables down there, complex relationships, system fields, internal logic. Data entities abstract all that complexity away. What external systems see is a clean, simplified interface, right? The vendor's entity exposes vendor master data without exposing any of those internal details. A field might even be computed. It's a combination of multiple table columns, but external systems just see it as a single field. This abstraction is really powerful because you can change the underlying tables without breaking your integrations. The entity interface stays stable. There are 4 data entity field types you need to know about, okay? First, mapped fields. These come directly from table columns, things like a vendor account, vendor name. They're stored in the database and they're the most common type, right? Second, computed fields. These are SQL expressions that the database calculates. For example, a full address concatenated from street, city, and state. It's efficient because SQL Server does the calculation. Third, virtual fields. These are X++ code that gets evaluated at runtime, like total invoices, which is the sum of all vendor invoices, not stored in the database, calculated when you access it, slower than computed, but more flexible. Fourth, unmapped fields. These are custom fields you populate using X++ methods. Use these when you need custom logic that doesn't fit the other categories. Choose the type based on whether the data is stored, where the calculation happens, and what your performance needs are. Here's a key difference you need to understand. Okay. Computed fields use SQL. which means SQL Server executes the expression. It's very fast and it's perfect for concatenations, aggregations, simple calculations, right? Virtual fields use X++, so the AOS evaluates the code at runtime. This is more flexible because you can write any logic you want, but it's slower because you're not getting that database level optimization. For bulk operations, prefer computed fields. For complex logic, use virtual fields. Understanding this distinction is really critical for performance. Let me show you how to create computed output for integration. Okay. First, you extend the data entity. Second, you add an unmapped string field called full address. Third, you create an X++ method that concatenates street, city, state, and postal code. Fourth, you set the field's data method property to reference this method. Fifth, regenerate mappings if you're using this entity in DMF. Now, external systems can import or export full address without knowing anything about the underlying table structure. You know, this pattern encapsulates all that complexity and makes integration really clean. Data management framework orchestrates bulk data operations. Okay, here's how it works. You create import projects and define which entity you're importing. You map source fields to target fields. DMF stages the data in temporary tables, validates each record, transforms data as needed, and then writes to the target tables, right? If errors occur, DMF logs them and lets you retry. You can schedule jobs to run nightly or on demand. DMF is really the enterprise way to move data. It's reliable, traceable, and production ready. Let me walk you through the complete import workflow, okay? First, you create an import project in the DMF workspace. Give it a name like vendor import. Second, select your target entity, vendor V2 entity for a vendor import, right? Third, add your source data, which is usually an Excel file with vendor records. Fourth, generate the field mapping. DMF automatically maps columns to entity fields for you. Fifth, um, review and adjust if you need to. Maybe you want to rename a column or add a transformation. Sixth, click import. DMF stages the data and writes it to the target. Seventh, monitor the progress. DMF shows you import status, any errors, and how many records have been processed. This workflow is systematic and reliable. Composite entities handle parent-child relationships, and sales orders are a perfect example. Okay, the parent is the order header and the child is the line items. Both entities participate in the import. DMF stages both tables. Header record get a row ID and line records get a parent row ID that points to the header row ID, right? When the import runs, DMF ensures the lines are linked to their headers. After the import, the system creates the formal relationships. This is really powerful for complex data structures because a single import job handles both headers and lines. Okay, so entity extensions, right? They let you customize how imports behave. Um, Here's how it works. You create an extension on the target entity and then you add your logic there. So let's say you want to add validation. Okay. If the vendor country isn't in your approved list, you mark it as invalid. Or maybe you need transformation, convert an external date format to the finance and operations format. Or you could add calculation, like setting default payment terms if they are not provided. All of this happens during the import. And the best part, you don't have to modify the standard entity at all. Extensions keep all your import logic in one place. And this is really important. They preserve upgrade safety, right? So when Microsoft releases updates, you're good to go. Now, change tracking, this enables incremental updates, which is super efficient. So instead of exporting all your vendor records every single night, you only export the ones that actually changed. Makes sense, right? So here's how it works. Database change tracking logs, inserts, updates, and deletes. When you query the entity with change tracking enabled, it returns only the records that changed since the last extraction. This is really efficient for large data sets because, external systems get incremental updates instead of full refreshes. You're saving bandwidth, you're saving processing time. Now, you configure change tracking on the entity based on your needs. You can do primary table only, entire entity, or even a custom query. Choose what works for your scenario. All right, let's talk about Dataverse. So Dataverse is Microsoft's shared data platform. Okay. Finance and operations uses Dataverse for synchronization with Power Apps, customer engagement apps, and other cloud applications. Now, when you enable dual write, data syncs in real time between finance and operations and Dataverse, and then other applications can access the same data. This creates um, basically a unified data model across your entire organization. So customers in Dataverse come from CRM, orders in Dataverse come from finance and operations. Single source of truth, this is enterprise data integration done right. Okay, so the data management framework export supports multiple formats. Let me walk you through them. Excel, right? This is great for user analysis and low volume exports. CSV works really well for comma separated integration with legacy systems. XML is for structured integration with web services. And then there's the package format, which includes a manifest file that defines the contents. So choose the format that matches your target system. Okay. And the batch data API handles file-based asynchronous integrations, which is really useful for those automated nightly jobs that you're running. All right. So after you extend tables, you need to synchronize the database. You got three options here. Let me quickly go through them. Option one, you go to the Dynamics 365 menu and select Synchronize Database. This does a full system sync. It's the safest, but it's slower. Option two, you set the project property called Synchronize Database on build to true. This gives you automatic sync during each build, which is really good for development. Option three, you right-click the project and select Synchronize. This is a project-only sync, and it's faster for large solutions. So choose based on your needs. Now, database synchronization, what does it actually do? It creates the SQL columns for your new fields. Without the sync, the fields exist in metadata, but not in the actual database. Okay. So you got to sync. Let me tell you about four critical mistakes that people make. Mistake number one, overlaying data entities instead of extending them. So you modify a standard entity, Microsoft updates it, and boom, you've got a conflict. You can't upgrade. Use extensions instead. Okay, mistake number two, using virtual fields in bulk import operations. Virtual fields run X++ code per row. So with 10,000 rows, that's 10,000 code executions. Performance just kills your import. Use computed fields for bulk operations instead. Mistake number three, not generating field mapping. So you import data, but the columns don't map and data goes to the wrong fields. Generate mapping automatically. Let the system do it for you. Mistake number four, not synchronizing the database after extending tables. You add a field in metadata, but it doesn't exist in SQL, so data can't persist. Always sync, guys. Now let's cover 5 best practices. Okay. Practice number one, always use data entities for integrations. They're the supported layer. This is what Microsoft recommends. Practice number two, extend entities via extensions. Never modify standard entities directly, right? Practice number three, use computed fields for bulk import performance. Reserve virtual fields for complex logic. Practice number four, generate field mappings automatically in the framework. Let the system do the alignment for you. It's much safer. Practice number five, always synchronize the database after schema extensions. Metadata and SQL must be in sync. Okay. When you are disciplined about data integration, it ensures you have reliable performance systems. All right, let's recap this topic. So we learned that data entities are an abstraction layer for integration. External systems see a clean interface without knowing the table complexity underneath. We learned about 4 field types, right? Map fields from table columns, computed fields via SQL, virtual fields via X++, and unmapped fields via custom code. We learned about the framework, the data management framework, which orchestrates bulk import and export. You create projects, you map fields, you validate data, and you transform as needed. We learned that composite entities handle parent-child relationships, like sales orders with line items. We learned that entity extensions add validation and transformation without modifying standard entities. We also learned about change tracking, which enables incremental extraction, so you're only getting the change records. We learned that Dataverse is the shared platform synchronizing data across finance and operations, Power Apps, and customer engagement. And we learned that database synchronization is mandatory. After schema extensions, metadata and SQL must match. Okay. Now that you understand bulk data operations, here's the next question. How do you build real-time integrations? How do you expose data and logic to external systems programmatically? That's the next topic, services and APIs, where we learn to build integration endpoints. Welcome to the next topic. So we've learned about bulk data operations with the framework. Now we need real-time integration, right? External systems need immediate answers to questions like, what's the inventory level? Can we fulfill this order? Is this customer approved? These require instant communication through APIs. So OData is the standard REST interface that exposes data. Custom services handle business logic, calculations, validations, complex workflows. Both are real-time and both require secure authentication. This is the topic on services and APIs. Master these patterns and you'll be building real-time integrations that connect Dynamics 365 to your entire ecosystem. Okay, there are three primary integration technologies you need to know. First is OData version 4, which is REST-based access to data entities. You can query vendors, customers, orders, real-time data without custom development. Second is custom services, which are X++ classes exposed as web services. These run business logic like calculate tax, check inventory, validate approvals, also real-time. Third is the Excel add-in, which lets users edit data in Excel and sync it back to Dynamics 365. It's convenient for ad hoc work, but not really for automation. So choose based on your need: data access, business logic, or user convenience. All right. So OData is REST-based data access. You make HTTP requests to the OData endpoint. So you do get/data/vendors to list vendors, get/data/vendor with a key to get one specific vendor, post to create, patch to update, delete to remove. You can filter with where conditions. You can sort, you can page, you can select specific fields. OData returns JSON by default. And there's a metadata endpoint at /data/$ metadata that describes all exposed entities and their fields. So OData is self-documenting. Any system that understands REST and JSON can integrate with it. This is why OData is so powerful, right? Okay, custom services expose business logic through web endpoints. Here's how you build one. You create an X++ class decorated with data contract. You add public methods for each operation. You decorate those methods with sysEntryPoint attribute to make them callable. Then you register the service. Now external systems can call the service, pass parameters, the method runs your business logic and returns results. So for example, let's say you have a check inventory method. You pass item ID and quantity. The method queries inventory, calculates available to promise, and returns true or false. This is really powerful for complex business rules that you just can't express in OData queries. Here's a key distinction, okay? OData is for data access. Query vendors get their records, update a field. Straightforward CRUD operations, right? Custom services are for business logic. Calculate tax or an order total, validate credit limits, reserve inventory, check approval rules. These require calculations and external lookups. OData can't express this kind of logic. So use OData for data, use custom services for complex logic. And here's the thing, most solutions actually use both. It's not one or the other. Let me show you how to consume OData from C#.NET. First, you install the OData version 4 code generator. Second, you configure it with the metadata document URI pointing to your environment. Third, you run the generator, it reads the metadata and creates C# classes representing each data entity. Fourth, you use these classes in your code. So these strongly typed proxy classes make integration safe and IntelliSense friendly. Instead of dealing with string paths, you have compiled classes. Errors get caught at compile time. This is much better than manual API calls, okay? All right, so external applications need authentication to access your system. Here's how it works. First, you register the app in Microsoft Entra ID. That's what Azure AD is called now. This creates an app registration with a client ID and secret. Second, you map that app to a user account in finance and operations through the system administration workspace. You assign security roles to that user. Now the app can authenticate using the client ID and secret. It gets an OAuth token and it calls APIs with that token. The token grants permissions based on the user's roles. So Entra ID handles authentication, finance and operations handles authorization. And by the way, Lifecycle Services is not involved in API access. It's only Entra ID and finance and operations. Okay. So when do you actually need custom services instead of OData? When you need calculated results, right? OData can't calculate, it just retrieves data. When you need complex validation, OData can't validate, it just reads and writes. When you need business logic, OData can't execute logic. When you need to call external systems, OData can't integrate with external APIs. Custom services are perfect for these scenarios. But here's the thing, don't use custom services for simple data access. OData is simpler and faster. Use the right tool for the job, okay? All right, synchronous integration is real time. The caller makes a request and waits for a response. It's perfect for inventory checks, approval workflows, any scenario where you need immediate feedback. The downside is if the network is slow or the server is busy, the caller waits. Asynchronous is batch oriented. The caller submits a job and continues working. Results come later. It's perfect for bulk data sync, nightly imports, any scenario where latency is acceptable. The upside is it's resilient and doesn't block the caller. So choose based on your requirement, right? Need a real-time decision? Go synchronous. Batch processing? Go asynchronous. Let me give you a real-world synchronous example. So you've got a mobile app that lets a store associate scan a barcode and enter a quantity. Now, before allowing the order, the app needs to check inventory. It calls a custom service with the item ID and quantity. The service queries inventory in real time and returns the available to promise. If it's available, the order proceeds. If not, it shows out of stock. This is synchronous, right? The associate waits for the answer. Latency is acceptable, usually under a second. Now, if the server is slow, the associate waits. That's the trade off, but it ensures accuracy. Now, here's a real world asynchronous example. A point of sale system collects sales all day. In the evening, a batch job runs and calls the framework API to import sales to finance and operations. By morning, finance and operations has the updated sales data. This is asynchronous, right? The point of sale doesn't wait, it just queues the data. Overnight processing handles the input. Latency is hours, but that's acceptable for daily reconciliation. There's no real time requirement here. This is efficient for high volume periodic synchronization. Okay? Okay, when you're monitoring framework jobs programmatically, you poll the status using the execution summary status enum. There are 7 valid values. Let me walk you through them. Not run means the job is queued but hasn't started yet. Executing means it's currently running. Succeeded means it completed with no errors. Partially succeeded means it completed but some records failed. Failed means the job failed with errors. Cancel means a user stopped it. Unknown means it's in an indeterminate state. These are the only valid statuses, okay? And by the way, starting is not valid. That's a common mistake people make. Always use these defined values. So you'll poll the status repeatedly until you get succeeded, failed, partially succeeded, or cancelled, right? Okay, so let me walk you through a real world example with custom services, right? So let's say you have a vendor portal and vendors need to check their order status. Now you wouldn't want to give them direct database access, would you? I mean, that's where custom services come in. So here's how it works. The service method, it takes in a vendor ID and an order ID. First thing it does is validate whether this vendor is actually authorized to see that particular order. Once that checks out, it queries the order status and returns it back to them. Okay. So the vendors, they call this service through REST. They authenticate using OAuth. And here's the beauty of it. The service enforces security automatically, so vendors can only see their own orders, right? This is what professional API design looks like. Controlled access, business logic that's actually enforced, and security that's built right in. All right, so let's talk about 4 critical mistakes I see all the time. Okay. Mistake number 1 is accessing tables directly for external systems. This is unsupported and honestly, it's dangerous. You got to go through OData or services. No shortcuts here. Mistake 2 is using custom services for simple data retrieval. That's overkill. OData is simpler and faster for that, right? Save your custom services for actual business logic and use OData when you just need data. Now, mistake 3 is using synchronous calls for bulk imports. Think about it. If you're importing 10,000 records synchronously, the caller's just sitting there blocked for minutes. Terrible user experience. Use asynchronous DMF instead. Okay. And mistake 4, using invalid status codes like starting that don't even exist in the enum, that's just going to cause failures. Always stick with the defined enum values. Let me share 5 best practices that'll really make a difference. Okay. So practice 1, use OData for data access queries. It's standard, it's documented, and you don't need any custom development. Practice 2, reserve custom services for business logic. Things like calculations, validations, complex workflows, that's where they shine. Practice 3, secure all your APIs with Entra ID and finance and operation security. Never, and I mean never, expose unprotected endpoints, right? Practice 4, use synchronous patterns for real-time scenarios where you need an immediate response. And practice 5, use asynchronous for batch operations and bulk imports. The key here is choosing the right pattern for what you're trying to accomplish. Your integration quality really depends on following these disciplines. So let's recap what we covered in this topic. We learned that OData version 4 is your standard REST API for data access. You can query any exposed entity, filter it, sort it, page through it. It's widely supported, okay? We also learned about custom services and how they expose your X++ business logic as web endpoints. Think calculating taxes, validating credits, checking inventory, real-time business logic, right? Now for application registration, you need Entra ID for authentication and finance and operations security mapping for authorization. NCS doesn't play a role here. We also covered generating typed C# proxy classes from OData metadata, which gives you strongly typed, IntelliSense-friendly integration. And we talked about synchronous versus asynchronous. Synchronous for real-time decisions, asynchronous for batch operations. Remember, DMF execution statuses follow defined enum values. Now that you understand real-time integration through services, the next question is, how do you react to events asynchronously? And how can you leverage Power Platform for low-code integration? That's what we're covering in the next topic, Async and Power Platform, where we'll dive into event-driven integration patterns. Navigation, the form just... So we've already learned about real-time integration through OData and services, but now we need to tackle asynchronous patterns, right? Here's the thing. Not everything can be real-time. You've got long-running batch jobs, scheduled exports, event notifications going out to external systems. Asynchronous patterns handle all of these gracefully. We're also expanding our scope beyond just Dynamics 365, Power Platform, and I'm talking about Power Apps, Power Automate, Dataverse. These are now central to how Microsoft's ecosystem integrations work. Okay? So that's what this topic is all about. Async and Power Platform. Master these patterns, and you'll be building event-driven, resilient integrations that can scale across the entire Microsoft ecosystem. Let's talk about the three sys operation execution modes. So synchronous runs immediately in the user session. The form actually blocks until it completes. This is good for short tasks like validation or a quick calculation. Sure, the user waits, but it's okay because it's fast. Now, asynchronous runs in the background batch framework. You can schedule it to run nightly or on demand. This is perfect for things like nightly imports, exports, reconciliation. The user doesn't have to wait around. Then there's reliable asynchronous, which is the same as async, but with enhanced reliability built in. If the batch job fails, it automatically retries. This is perfect for mission critical work like financial posting. So you just need to choose the mode that matches your requirement. Here's the decision logic for choosing between these modes. Okay. If your task has to complete in seconds and the user is actively waiting, go with synchronous. That's for things like validation, calculations, quick lookups, right? If your task might take minutes or hours and failure just isn't acceptable, use reliable asynchronous. Financial posting, critical reconciliation, automatic retries, ensure it actually completes. Now, if the task can take some time, but failure is acceptable and you're handling it elsewhere, regular asynchronous works fine, like nightly imports where you just check the log in the morning. Following this logic ensures you're picking the right mode every time. There are two ways to run async operations from forms. Okay, so form run.run async is better for the user interface. When a user clicks a button, the work runs in the background, and when it completes, a callback fires and updates the form. No page refresh needed. It's a seamless user experience, right? Global.run async is simpler but less elegant. The work runs in the background, but there's no callback. So you need to manually refresh the page to see the results. You know, use formRun.run async when you want that professional user experience. Use global.run async when a callback isn't really needed. Let me explain three batch processing patterns. Okay. So individual task means creating one batch task per work item. It's simple, but if you have a large import, you're creating thousands of tasks. That's a lot of overhead, right? Static bundling is where you pre-assign fixed groups. Group A handles items 1 through 100. Group B handles 101 through 200. This works fine if processing time is uniform, but here's the problem. If Group A's items are complex and take twice as long, you end up with an imbalanced load. You know, Top picking is where tasks dynamically pull work from a queue. Your staging table has items waiting, and each batch task just grabs the next unprocessed items and processes them. When it's done, it grabs more. This gives you perfect load balancing. If one task finishes early, it immediately starts on more work. Okay. This is the professional pattern for scalable batch processing. Here's how the top picking workflow actually works. Okay. You create a staging table with work items and a status column. The controller spawns multiple identical batch tasks. Let's say 5. Task 1 selects the next top 100 unprocessed items, marks them as processing, processes them, then marks them as completed, right? Task 2 does the same thing. If task 1 finishes first, it just loops back and picks the next 100 items. All the tasks run in parallel, so the load is perfectly distributed, you know. And if processing time varies by item, the tasks actually self-balance. This pattern is professional, it's scalable, and it handles large volumes really efficiently. Business events architecture has 3 main parts. Okay. The business event class defines the event and raises it. For example, sales order confirmed event. It receives data like the order record, builds a contract with the order ID and customer, then sends the event. Right? Data contract holds the payload. Order ID, customer, status, these are strongly typed fields. Then you have the event handler class, which subscribes to events. When sales order confirmed event fires, the handlers receive it and execute their logic. Maybe one sends an email, another posts to an external system, another updates analytics. Multiple handlers can subscribe to the same event and they all fire independently. This is really powerful event-driven architecture. Let me give you a real-world example. Okay, so a sales order gets confirmed and an event fires. The business event class builds a contract with the order ID, customer name, and total amount. Then the event is sent out, right? Multiple handlers receive it. Handler 1 sends a confirmation email to the customer. Handler 2 posts to the warehouse system to start picking. Handler 3 logs the event for analytics. All of this happens asynchronously and independently, you know. So if the warehouse system happens to be down, the email still sends. If the warehouse is busy, the email doesn't have to wait. That's elegant decoupling right there. This is what professional event-driven architecture looks like. You've got 5 integration tools and each one has a specific purpose. Okay. So OData is for real-time data access, good for quick reads and writes. Limited throughput though, so it's not for bulk operations, right? DMF is for bulk imports. You want to import 10,000 vendor records nightly? That's DMF. High throughput, asynchronous. Recurring integration is basically scheduled DMF. Export data every night at midnight. Scheduled batch processing, business events are for real-time event notifications. Order confirmed, event fires, and external systems react immediately. And dual write is for Dataverse synchronization. It keeps finance and operations and Dataverse in sync for offline power apps. So you just choose based on what you need. There are 2 Dataverse patterns to understand. Okay, so dual write synchronizes data by directionally between finance and operations and Dataverse. Products in finance and operations become products in Dataverse. Power apps download those products to a local Dataverse cache and the app works offline. Perfect for offline scenarios. Virtual entities query finance and operations without actually storing anything in Dataverse. So a Power app opens up, queries a vendor balance through a virtual entity and gets real-time data from finance and operations. There's no local storage, which means it can't work offline. Choose dual write when you need offline capabilities. Choose virtual entities when you want real-time data without storage. Power Apps barcode scanning uses the barcode scanner control, which you'll find in the media category. Okay. Other media controls include camera, audio, and video. You add the barcode scanner to your app, and when the user points their device camera at a barcode, the control recognizes it and extracts the value. Your app can then process it, maybe look up the item in finance and operations using OData and display the details. This is perfect for mobile scenarios like receiving, warehouse picking, field service. It's professional mobile integration. Let me walk you through 4 critical mistakes. Okay. So mistake 1 is polling instead of using events. The external system repeatedly asks, is the order ready? That wastes bandwidth and has latency, right? Use events instead. When the order is ready, an event fires and the system is notified immediately. Mistake 2, using OData for bulk imports. If you try to import 10,000 records via OData, the system throttles you and requests start timing out. Use DMF, Mistake 3, using synchronous for long tasks. You run a 5-minute batch job synchronously, the form blocks, and the user just sees a frozen screen. Use asynchronous, okay? And mistake 4, virtual entities for offline scenarios. A Power App uses a virtual entity to query finance and operations, works great online, but not offline because the data isn't cached locally. For offline, you need dual write. Every Dataverse and finance and operations table has system fields that are managed by the system automatically. So created on tracks when the record was created, modified on tracks when it was last edited. Now here's the thing. You can rename the display name to something more user-friendly like entry date or last updated. Right. The schema name stays the same internally. This reuse is really efficient. Don't go creating a new field for what system fields already provide. Just reuse what exists and rename the display name for business context. That's professional design. Mission critical batch jobs need reliability. So take financial posting. It's critical. General ledger entries have to be posted daily. They just can't fail, right? So use reliable asynchronous mode. If the job fails, sys operation automatically retries based on your configuration. It logs every attempt. Eventually, it either succeeds or notifies you if it's unrecoverable. This gives you real peace of mind. Your daily financial posting isn't going to be delayed by transient failures. The job retries and completes. That's production grade reliability. Let's recap what we covered in this topic. Okay, we learned about sys operation execution mode, synchronous for short tasks, asynchronous for background work, and reliable asynchronous for mission critical operations with guaranteed completion. We learned about formRun.runAsync for asynchronous execution with callback and UI update, and global.runAsync for simple background work. We covered the top picking pattern for efficient parallel batch processing, staging table, dynamic work acquisition, perfect load distribution. We learned business events architecture. Event classes raise events, contract classes hold payloads, and event handlers respond. It's decoupled asynchronous integration. We went through the integration tools: OData for real-time, DMF for bulk, recurring integration for schedule, business events for event-driven. Okay. We covered Dataverse integration, dual write for synchronized offline capable data, and virtual entities for real-time queries. We learned about Power Apps barcode scanning using media category controls, right? And we learned to reuse system fields with friendly display names. Now that you understand asynchronous integration and event-driven patterns, the next question is, how do you present business data for analysis? How do you build reports? That's the next topic on SSRS reports, where we will learn to build professional business analytics. Welcome to this topic. We've built integrations, we've automated processes. Now we need to report on that data. Okay. How do you present business metrics? How do you let managers actually see trends, right? SSRS SQL Server Reporting Services is the answer. SSRS reports are designed visually, but they're backed by X++ code. Data providers fetch and process the data. Controllers orchestrate the execution. This is what this topic is all about. SSRS reports. Master these patterns and you'll be building professional business reports that drive real decision making. Okay, so let's talk about SSRS report architecture. Basically, there are four main components that work together here, right? So first you have the data contract, and this is where you hold your parameters. I mean, think about it. These are basically the things the user wants to report on, like customer information, date ranges, maybe product categories, things like that. Now, the second component is the report data provider. This guy actually queries the database using those parameters we just talked about. So it retrieves the data, it processes everything, and then it fills up temporary tables. Now, the third piece is the report controller. And this is like the orchestrator. Okay. It selects the right report design, it passes those parameters over to the provider, and then it launches the whole execution process. And finally, you've got your report design. This is basically your visual layout, right? So all your fields, your tables, charts, everything formatted nicely. So all four of these components, they work together to produce that final report you see. Make sense? Now let's talk about the data contract class. So basically, this class holds your report parameters, okay? And it's decorated with something called data contract attribute. Now, your public fields, these represent the actual parameters, and each field needs to have a data member attribute. This is really important because this is what actually makes that field appear on the report dialog. Now, if you need to control the parameter order, you can use this operation display order attribute. Let me explain that second parameter in data member attribute real quick. So if it's true, that means the parameter is mandatory. If it's false, it's optional, right? Now here's something interesting. External systems can actually see these parameters when they're calling the report. So basically, this is the contract, like the agreement between the report and whoever's calling it. Does that make sense? All right, so the report data provider, this is where you actually fetch the data, okay? Now it's decorated with SRS report parameter attribute, and this links it to that data contract we talked about earlier. Now the dataset method, this is marked with SRS report dataset attribute, and this specifies the temp table that's going to hold your data. Now here's something really critical, guys. Process report is your main work method and it returns void. I mean, this is super important to remember. So inside this method, what you're doing is you're querying the database using those parameters from the contract, and then you fill the temp table. The report engine then reads that temp table and displays everything. So basically, this is where all your business logic actually lives. This is the heart of it. Let's talk about the report controller now. So this guy orchestrates the whole execution process, right? It extends SRS report run controller. Now you can override something called pre-prompt modify contract, and this lets you set default parameter values. So basically, users see reasonable defaults when they open that dialog, which is nice. You can also override set report name to select which report design to use. So if you've got multiple designs, this is where you decide which one actually gets used. Okay. Think of the controller as like the conductor of an orchestra. Okay. It sets everything up and then launches the report. So when you call the report from a menu item, the controller is what actually runs first. Okay, so for report deployment, there are two valid paths you can take. In Solution Explorer, you right-click your project and select Deploy. This deploys all the report objects in that project, so it's pretty fast for development. Or in Application Explorer, you right-click a specific report and deploy just that one report. Both approaches are totally valid. Now, here's what doesn't work, and this is important. Build project that builds your X++ code, but it doesn't deploy SSRS designs. Okay? Build models compiles metadata but also doesn't deploy designs. Package deployment moves compiled artifacts but not the designs themselves. So you've got to remember, always use Solution Explorer or Application Explorer when you're dealing with SSRS reports. That's the way to do it. Framework attributes are absolutely critical here, guys. So let me break these down. Data contract attribute. This marks a class as a parameter container. Data member attribute on your fields. This makes them actually appear on the dialog. SRS report parameter attribute on the provider. This links it to the contract. SRS report dataset attribute on the dataset method. This specifies the temp table you're using. And sys operation display order attribute controls the parameter order on that dialog. Now, if you miss any required attribute, the framework just won't recognize the class, right? So you've got to apply all the required attributes. This is non-negotiable. The report data provider has some really strict requirements you need to follow. Okay. So first, it must extend SRS report data provider base. That's non-negotiable. Now the process report method, it must return void. A common mistake people make is they return Boolean or int, and that actually breaks the framework. So don't do that. You've got to have a dataset method that's marked with SRS report dataset attribute. And this specifies the temp table. The framework is really strict about these requirements. If you miss any one of them, your report won't execute. So just follow them exactly as they're specified. All right, let me walk you through the complete process for creating a parameterized report. So first you create your contract class with the parameters. Second, you decorate those fields with data member attribute. Third, you create your RDP class and you link it to the contract. Fourth, you implement the process report method, and remember it has to have that void return type. Fifth, you add a dataset method with the attribute. Sixth, you write the logic to query the database and fill that temp table. Seventh, you create the visual design in SSRS. So that's your fields, tables, charts, all that stuff. Eighth, you deploy from Solution Explorer. And ninth, you test by actually running the report from a menu item. So this 9-step process, it's systematic and complete, right? Just follow it step by step. Now, when a standard report is locked, you can't modify it directly, okay? So what do? You use extensions instead. So first you extend the provider class using chain of command. In your extension, you populate the new field values. Second, you clone the report design and add the new field to that design. Save it as your custom report. Third, you extend the controller and override set report name to use your cloned design instead of the standard one. Now every execution uses your design with your new field, and the standard report stays completely untouched. So it's upgrade safe, which is exactly what we want. Let me go over 4 critical mistakes that people make. Mistake number 1, process report returns Boolean or int. That's a wrong signature. Okay. The framework expects void, and if you don't use void, your report just won't execute. Mistake number two, duplicating the provider class to add fields. This actually breaks upgradability. I mean, your copy doesn't get updates when Microsoft changes the standard version, so you should use extensions instead. Mistake number three, deploying via build project. That builds the code that doesn't deploy SSRS designs. You need to use Solution Explorer or Application Explorer. And mistake number four, modifying tables directly in the RDP. The framework expects temp table population, right? So if you modify tables directly, you're breaking the contract. Always use temp tables. These are common mistakes, so just make sure you avoid them. Let me give you a real world example here. So let's say you have a customer sales report, okay? The data contract has three parameters from date to date and customer ID. So the user selects these on the dialog. Now the provider queries sales table. It filters by these parameters and it sums up the sales. It fills a temp table and the design shows the customer name, total sales, and maybe a trend chart. So let's say a manager opens the report, enters a date range, and boom, they can see which customers generated the most revenue. That's professional business reporting right there. That's exactly what you want to deliver. Let me share 5 best practices with you guys. Practice number 1, extend, don't duplicate. So use chain of command to customize providers because it preserves upgradability. Okay. Practice number 2, use temp tables. The framework requires it. So don't query tables directly. Practice number 3, apply all required attributes. Each attribute serves a purpose, and if you miss one, it breaks the framework. Practice number 4, test before deploying. Run it in development, verify the report renders correctly, check that the parameters work, all that stuff. And practice number 5, document your parameters. Help users understand what each parameter does, right? Professional documentation really improves adoption and it makes everyone's life easier. Report security is enforced at the menu item level, okay? So the menu item has a role requirement, maybe something like sales manager. The user has to have the sales manager role to even see the menu item. So basically, only sales managers can access the report. This is the standard pattern. Now, don't try to implement security logic inside process report because the framework won't honor it. Let the menu item handle security. That's the professional standard way to do it. Keep it simple. All right, so let's recap this topic real quick. We learned about SSRS report architecture, right? So data contract holds parameters, report provider queries the database and fills the temp table, controller orchestrates everything, and report design provides that visual layout. We learned about the required framework attributes, data contract attribute, data member attribute, SRS report parameter attribute, SRS report dataset attribute. All of these are required, okay? We learned about report deployment, so use Solution Explorer or Application Explorer because build project doesn't deploy designs. We covered data provider requirements, so it must extend the base class, process report returns void, and the dataset method is marked with the attribute. We learned how to create parameterized reports with that 9-step systematic process. We learned about extending locked reports, so you use chain of command on the provider, clone the design, extend the controller. That's upgrade safe customization. We covered best practices like extend, don't duplicate, use temp tables, apply attributes, test, and document, and we learned that report security is at the menu item level. Now that you understand SSRS reports, the next question is, how do you build embedded reports in forms? How do you leverage advanced analytics? That's the next topic on ER analytics, where we learn about embedded reporting and business intelligence. Okay, welcome to the next topic. We've already learned about SSRS reports for detailed business analysis. Now we need to tackle real-time KPIs and configurable reporting, right? How do you show live metrics that update as data changes? How do you let business users configure reports without needing a developer every time? That's what this topic is all about. ER and analytics. Electronic reporting handles configurable import and export. Aggregate models power your KPIs. Power BI enables self-service analytics. Together they transform raw data into business intelligence. Master these patterns and you'll build professional analytics that drive real-time decision making. So KPI architecture, it starts with your fact data. Okay, think sales tables, RAF journals, order records, numeric values just waiting to be aggregated. Aggregate models transform this data for you. They create measurements like sum of sales, count of orders. They create dimensions like region, customer, time, right? The entity store receives all this aggregated data. Then tiles query the entity store and display your live metrics. Total sales this month, $5.2 million. Count of orders, 1,847. Region, West is leading with 2.1 million. All of this is real time, live, updating as new data enters the system. Okay, so aggregate measurements, they define your numeric facts. You have got some for things like total sales amount, count for number of orders, AVG for average order value, min for minimum delivery time, max for highest unit price, right? Each measurement specifies what operation to perform, which field to operate on, and any filters you want to apply. Measurement type tells the framework what calculation to do. The is aggregated flag indicates this is a pre-calculated value. Source field points to the underlying table column. These measurements answer questions like, what is our total revenue? How many customers do we have? What's our average order size? So aggregate dimensions, they provide your grouping context. Region lets you slice sales by geography. Customer group lets you slice by customer segment. Hour lets you slice by time of day. Date lets you slice by day or month. Product category lets you slice by product line. Okay. Dimensions answer questions like, what are sales by region? How many orders by customer group? What's revenue by product? Your dimensions must map to stable fields in your tables. Changes to dimension values shouldn't break your analytics, right? Good dimensions enable meaningful analysis. Okay, let me give you a real KPI example. Total RAFs per hour. Your fact data is the RAF journal table with timestamps. The measurement is count of RAF lines. A dimension is the hour extracted from that timestamp. You bind them together in a model, deploy it to entity store, and create a tile in the workspace showing this KPI. Now, managers can see RAF throughput visualized by hour. At a glance, they know the processing volume. Trend analysis shows them peak hours, right? This is professional analytics in action. So here's another KPI example. Sales by region. Your fact data is the sales table with amount and region. Measurement is sum of sales amount. Dimension is region. Okay. You combine them in a model and create a tile that displays total sales by region. West region is leading with $2.1 million. East follows with 1.8 million. South trails at 1.2 million. Managers can instantly see regional performance, identify high performers and underperformers, and make resource allocation decisions. This is what drives real business value. Okay, so let's talk about 4 critical KPI modeling mistakes you need to avoid. Mistake 1, using data entities for KPIs. Data entities are for import and export, not analytics. Use aggregate models instead. Mistake 2, using TempDB tables. These are session temporary and disappear when the user logs off, so they are not suitable for persistent analytics. Use fact tables. Mistake 3, using numeric fields as dimensions. Dimensions are categories like region or customer. Don't try to group sales by amount. That doesn't make sense. Amount should be a measurement, not a dimension. Mistake 4, creating manual aggregated views. The framework generates aggregate views automatically from your model. Don't write custom SQL. Let the framework handle it for you. Okay. So creating a KPI tile, it involves 3 steps. First, create your aggregate model. Define what measurement to display and what dimension to group by, then deploy it to entity store. The framework builds the analytics database for you, right? Second, create a tile in the workspace. Point it to your measurement and specify any filters if needed. Maybe you just want to show West region sales. Third, pin the tile to a workspace. Now it displays on the dashboard showing real-time data. As sales come in, the tile updates immediately. Your managers always see current metrics. Okay, so electronic reporting handles configurable import and export, right? Now the format basically defines your file structure. So you might have, let's say, XML format for one vendor, CSV for another vendor, and maybe JSON for a third one. Now format mapping, what does it do? It transforms that file structure to the D365 data model. So for example, you extract the vendor ID from an XML element, and then you map it to the vendor account field. Now, format validation, this enforces your business rules. So if the vendor ID is missing, you reject the import. So these 3 components, they work together. The external file comes in, ER processes it, and then D365 receives clean validated data. So ER format validation, it enforces data quality. Okay. Now you define the rules. Something like if vendor identification is missing, then error, right? When the import runs, validation checks every single record. Now, if a record violates the rule, the import stops and that record gets rejected. So your data quality is protected. Now you can choose warning, which logs the issue but continues, or you can choose error, which stops everything. So when should you use error? Well, use error for critical business rules, like vendor ID is required, so that's definitely an error. But maybe something like missing street address, that might be just a warning. So basically, validation keeps bad data out of your system. Okay, so here's the ER use pattern, right? Multiple formats, but one shared model mapping. So let's say three vendors send you bank statements. Vendor A sends XML, vendor B sends CSV, vendor C sends JSON. Different file formats, right? But here's the thing, it's the same business process. You're importing statements, validating them, posting to bank reconciliation. So what do? You create three formats, and this is important, all of them map to one shared model mapping. So your business logic stays centralized. Now, if you need to change validation rules, you change it once in the model mapping and all three formats immediately benefit from that change. So maintenance becomes simple. Now, what's the anti-pattern here? Creating separate model mappings for each vendor. That's a maintenance nightmare, guys. You need to make changes in three different places. Okay, so you've got three BI components to work with here. First, tiles. These are live KPIs pinned to workspaces. Just single metrics that are quick to scan, right? Now, dashboards. These are role-based homepages. So your sales manager, they see sales KPIs. Your warehouse manager, they see inventory KPIs. Each dashboard is tailored to what that role needs. And then self-service BI. This lets users create their own analytics using Power BI without any developer involvement. So a user might create a custom report, let's say, analyzing sales by customer by month without even needing you. So how do you choose components? Well, it's based on user need. Do they need a quick metric, a role dashboard, or custom analysis? So business document management, it configures your business documents. Now here's how it works. You create an electronic reporting format for an invoice and you set the tag property to invoice. So when a user prints, print management finds the format tagged as invoice and uses that format to generate the document. So company logo goes here, customer details go there, line items get formatted nicely, and it's completely configurable without any code. So you want to change the template, no deployment needed. You just update the ER format. This is really powerful for customization, without needing developer involvement every single time. Okay, so let me tell you about four critical mistakes to avoid, right? Mistake number one, multiple model mappings for the same business process. So let's say vendor statements in three formats, each with their own mapping. That's a maintenance nightmare. Instead, use one mapping shared by all three formats. Mistake number two, no format validation. So you're importing any data without checking it? Bad data pollutes your system. Always validate, okay? Mistake number three, temp DB tables in aggregate models, session, temporary data. It can't support persistent analytics. Use fact tables instead. And mistake number four, manually coding ER formats. Use the ER designer. It's visual and powerful. Don't try to code XML structures manually. All right. So 5 best practices for you here. Practice number 1, understand measurements and dimensions. Measurements are numbers to display. Dimensions are categories to group by, right? Practice number 2, reuse model mappings. So different external formats, but same business logic. One mapping, multiple formats. Practice number 3, validate all imports using ER validation. You're protecting your data quality here. Practice number 4, deploy aggregate models to entity store. That's where your KPIs get their data from. And practice number 5, use tags for print management. So you bind ER formats to document types. These professional practices, they ensure quality analytics. Okay, so let's recap this topic, right? We learned KPI architecture. Aggregate measurements define numeric facts. Aggregate dimensions provide grouping context. So measurements and dimensions, they combine in models. Models deploy to entity store, and then tiles query entity store to display live metrics. Now we learned electronic reporting. Format defines file structure. Format mapping transforms file to data, and format validation enforces business rules and stops invalid imports. We learned the reuse pattern, multiple formats, but one shared model mapping for centralized business logic. We learned BI components. Tiles are glanceable KPIs, dashboards are role-based homepages, and self-service BI enables user-authored analytics. We learned business document management configures templates, so ER formats with tags, they bind to print management. And we learned best practices. Understand measurements versus dimensions, reuse model mappings, validate all imports, deploy to entity store, and use tags for BDM. Now that you understand analytics and reporting, the next question is, how do you control who accesses what? How do you secure the system? That's the next topic, security architecture, where we learn about roles, permissions, and data access control. Okay, so welcome to this topic, right? We've built applications and reported on data. Now we need to control who sees what. So who can delete vendors? Who can only view them? Can a clerk see all customers or just their own? Security is critical to compliance and data protection. So this is security architecture. Now D365 uses layered security. Roles get assigned to users. Duties group privileges together. Privileges grant access to specific operations, and permissions control table and field access. And then extensible data security, it adds row level filtering on top of all that. So master these patterns and you'll build secure systems that protect data while still enabling users to do their jobs. Okay, so security follows a hierarchy here, right? Users are assigned roles, and this is the least granular element you can assign to users. So roles like accounts payable manager or clerk. Now duties, they group related responsibilities together. So an invoice processing duty, it might include invoice approval, posting, and deletion. Privileges are specific tasks. So you've got process invoice privilege, view invoice privilege, delete invoice privilege. And then permissions, these are your table and field operations. Read permission on when table, update permission on AP invoice. So this hierarchy, it ensures organization and maintainability. Now, when you change a single privilege, all users with that privilege are affected automatically. So four security components work together here. Okay. Role is the user facing assignment duty groups related privileges. Privilege grants access to specific operations like forms or reports, and permission controls table and field CRUD operations. So each level has its purpose, right? Role is about user assignment, duty is about grouping related things, privilege is about operations, and permission is about data. Now, understanding this separation, this is critical to designing security that's maintainable. All right, so three security frameworks work together here. First, role-based security. It controls who can use which forms and operations. So your accounts payable clerk, they can open the invoice processing form. Your finance manager can run financial reports. Now, extensible data security, it filters data at runtime. So maybe an accounts payable clerk, they only see invoices for their vendor group, not all vendors, just their group. And then table permissions framework, it controls CRUD on tables and fields. So your accounts payable clerk can read invoices, but they can't delete them. So all three layers together, they create comprehensive security. Okay, so extensible data security, it applies row level filtering. So you create a query defining the filter, something like show only customers in my group. Then you create a security policy linking that query to the customer table. You define the context. So you apply this policy to the accounts payable role, and then you add constraint tables for related data like orders, invoices, deliveries. Now, all accounts payable users, they only see their customer group across all forms and reports. It's transparent filtering at runtime. So XDS is really powerful for multi-tenant scenarios or department-specific data access. Okay, so building an XDS policy step by step here. First, you create the query with your filter logic. So customer table where customer group equals the user's customer group. Second, you create the security policy and link it to customer table. Third, you define the context. So you apply it to accounts payable clerk role. Fourth, you add constrained tables, sales orders, invoices, and other related tables. They're constrained by the same filter. And fifth, you deploy it. The policy is now active, right? So users see only their customer group everywhere. Okay, so securing forms requires differentiated access. Let's say the cash disk form, managers need full access, including delete, but clerks need view only. So first, you use security diagnostics to verify manager access is already configured correctly. Second, you create a new privilege with view access to the form. Third, you create a duty extension containing this privilege. And fourth, you assign the duty extension to the clerk role. So now managers, they retain their delete access, but clerks can only view. This is professional security design following the least privilege principle. All right, so four critical security mistakes to avoid here. Mistake number one, modifying standard rules. So you change a Microsoft role, then when Microsoft releases an update, you've got a conflict and you can't upgrade. Use role extensions instead. Mistake number two, using XDS for UI access. XDS is for row level data filtering. Use role-based security for UI. Using the wrong layer, it breaks the model. Mistake number three, adding menu items directly to roles. This bypasses the privilege and duty structure, so breaking the hierarchy causes maintenance issues. Use privileges and duties instead. And mistake number four, granting table access directly to users. This violates the model. Access flows through privileges, direct grants. They break the architecture. So securing reports, it follows the same pattern as forms. You create a privilege containing the report's output menu item. Then you create a duty extension containing the privilege. And you assign the duty to the appropriate role, maybe accounts payable manager. So now only users with that role can run the report. Non-managers trying to run it, they get access denied. This keeps your report secure and organized, right? All objects stay in the required model. Okay, so batch job security requires the full stack here. You implement a data contract for parameters. You implement a service with your business logic. You implement a controller to launch the batch. Then you create an action menu item pointing to the controller. You create a privilege for the menu item. You create a duty containing the privilege, and you assign the duty to a role. So now users with that role, they can execute the batch job. Batch jobs are secured the same way as other operations, through the privilege and duty hierarchy. All right, so real world example with two recurring batch jobs here. Job number one, end of month invoice updates. It reads open invoices, retrieves minimum amounts from an external ERP system, and applies updates scheduled for the last day of the month. And it's secured with accounts payable manager privilege. Job number two, update purchase lines based on modified discounts scheduled weekly, secured with purchasing manager privilege. So both jobs, they use the same security architecture, privilege, duty, role. Different users execute different jobs based on their roles. This is professional, recurring automation with proper security. Okay, so saved views. This is a usability feature. Users apply filters to forms like vendor, due date, amount. Then they save that filter as a named view. So next time they just click that view and the filter applies instantly. So your vendor invoices past due form, it might have saved views like my overdue invoices, high value overdue, due tomorrow. Each view filters based on the user's needs, right? And this is standard D365 functionality, no custom code required. It dramatically improves user productivity because users stop recreating filters manually every single time. Okay, so let's talk about security diagnostics. This is basically your go-to troubleshooting tool, right? So, ever wonder whether a user actually has access to a particular form? Well, you just run diagnostics. It's very simple. You specify the user, you specify the form, and the tool goes through and checks all the privileges throughout the entire hierarchy. Okay, and then it tells you exactly what their access level is. So, can the user read? Can they update, create, delete? Or maybe, they're limited to just read only access. The tool shows you precisely what that user can do. And this is absolutely invaluable when you're troubleshooting those issues where someone's asking, why can't this user see this form? Right? So security diagnostics answers that question for you. Now, let me walk you through 5 security best practices, okay? So first practice, always extend the standard roles, duties, and privileges. Never modify them directly. Now, why is that? Well, because modifications will break your upgrades. But extensions, they're completely safe. You can upgrade without any issues. Second practice, use the hierarchy properly, right? So roles get assigned to users, duties group your privileges together, privileges grant operations, and permissions control your CRUD operations. You really need to understand this flow because it's fundamental to how security works. Third practice, follow the least privilege principle. So basically grant only the access that's actually necessary. I mean, a clerk doesn't need delete access, right? So restrict them to view only. Give them what they need, nothing more. Fourth practice, layer your security. Use role-based security for the UI, use XTS for row, level filtering, and use table permissions for field, level control. All three working together, okay? And fifth practice, test access regularly using security diagnostics to verify your configuration is actually correct. Make sure what you configured is actually working as intended. So let's recap what we covered in this topic. We learned about the security hierarchy, how roles are assigned to users, duties group privileges together, privileges grant operations, and permissions control table and field CRUD operations. That's your 5-level organization, right? We explored 3 frameworks: role based security controls the UI and operations, XDS filters data at runtime by row, and table permissions controls CRUD operations. When you use all 3 together, you create comprehensive security. Now we learned how to extend standard roles, duties, and privileges. And remember, never modify them directly because uh, extensions preserve your upgradability. That's very important. We walked through XDS implementation, creating the query, creating the policy, defining the context, and adding constraint tables for row level filtering that gets applied transparently. We saw how to secure forms through privileges and duties, where managers retain full access, but clerks are restricted to view only. That's differentiated access following the hierarchy. We learned to secure reports and batch jobs using the same privilege, duty, and role pattern. It's a consistent architecture throughout, okay? And we covered best practices: extend, don't modify, use the hierarchy properly, follow least privilege, layer your security, and test with diagnostics. Now that you understand the security architecture, the next question naturally becomes, how do you ensure quality? How do you test things and handle approvals? That's what we're moving into next with testing and workflow, where we learn about quality assurance and approval processes. Welcome to the next topic. Okay, so we've secured the system. Now we need quality assurance, right? How do you test everything? How do you document your processes? How do you route approvals? And how do you find performance problems? This is what we're covering now with testing and workflow. So Task Recorder captures business processes for both documentation and testing. The SysTest framework provides unit testing capabilities. Workflow routes documents through your approval logic, and performance tools help you diagnose issues. Master these patterns, and you'll build professional systems with proper testing, clear workflows, and optimized performance. And this is actually the final topic of the comprehensive D365 curriculum. Okay, so Task Recorder has 3 modes, and each one serves a different purpose. First is recording mode. This captures the business process. The user performs the steps, and the system records everything. Okay, data entry values, form navigation, button clicks. It all gets recorded and produces a file. Now, guide mode plays back the recording interactively, so the user sees highlighted controls and follows along step by step. The system actually enforces the flow. Users can only interact with the current step unless they unlock it. This is great for training purposes, right? And then playback mode. This replays all the steps automatically. The system navigates forms and fills in fields using the recorded values. This is perfect for regression testing or automated demos. So 3 modes, 3 different purposes. Okay, so the task recorder workflow is pretty straightforward. You open task recorder and you start recording. Then you perform the business process. Maybe you create a vendor, you enter the details, and you save it. When you're done, you stop the recording and the system saves all the steps. Now, here's where it gets interesting. You have options, right? You can export to Word to create documentation. You can export to XML to create a test automation file for RSAT, or you can create a shared task guide for training. So one recording actually produces multiple deliverables, documentation, testing files, and training materials. It's very efficient. You do the work once and get multiple outputs. So let's look at task recorder's capabilities. You can capture any business process through the UI. You can create interactive guides that teach users step by step. You can replay recordings automatically for demonstrations or initial testing. You can export to Word for process documentation and share it with non-technical users. And you can export as XML for our SAT. That's the automated regression testing tool. Okay. So one tool, many uses. It's really powerful for documentation, training, and automation. You get a lot of value from this one feature. Okay, so the SysTest framework provides unit testing capabilities. Test classes contain test methods that are marked with an attribute. That's how the framework discovers and runs them, right? Each test runs in a transaction that automatically rolls back after completion. And this gives you clean isolation with no side effects between tests. So one test doesn't affect another test. The framework maps your code coverage and categorizes tests with metadata, things like owners, priorities, and properties. The results show you which tests passed and which ones failed. It's a professional unit testing framework. It works similar to frameworks you might have used in other languages. So there are 4 transaction isolation modes. Auto rollback is the modern and clean approach. All database changes, inserts, updates, deletes, they're rolled back after the test completes. You get perfect isolation. Okay, the test runs, then it rolls back, and the next test starts fresh. Now, legacy rollback only rolls back inserts. This is useful for backward compatibility with older code. Legacy rollback with update tracking also tracks updates, but it's rarely used. And none means no rollback at all. Changes persist. This is good for integration tests where you actually need real committed data, right? So choose based on your needs. Most of the time you'll use auto rollback because it's clean and modern. Okay, so there are 7 SysTest attributes you should know about. First one marks a method as a test for discovery. This one's required, okay? If you don't mark it, the framework won't find your test. The second one disables a test without removing it. This is useful for work in progress. Maybe you're still working on a feature. Third one assigns ownership. For example, Jane owns this test, right? So you know who to contact if there's an issue. Fourth one sets priority so you can run high priority tests first. Fifth one adds custom metadata. Sixth one links the test to what it's actually testing. And seventh one enforces gated check-in. The test must pass before code check-in. It's a quality gate. So each attribute serves a specific purpose and you combine them to create well-structured tests. Okay, let me show you a real unit test example. So we have a class called vendor service test with a method called test create vendor. It's marked with an attribute for discovery. Another attribute links it to the vendor service class. And there's one that gates the check-in. It must pass, right? We are using auto rollback mode for clean isolation. The test creates a vendor. Then it asserts that the vendor exists in the database and it asserts that the account number matches what's expected. If the assertions pass, the test passes. If any assertion fails, the test fails. This is professional unit testing that ensures your code quality. Okay. You write tests like this for all your critical business logic. Okay, so workflow architecture has 5 components. The document class holds the document data, things like vendor information, orders, expense reports. The workflow type defines the workflow structure and elements. Workflow elements include approval processes, decisions, and manual tasks. The approval provider routes approvals to specific users or group based on your criteria, and event handlers execute when workflow events occur, like when a document submitted, an approval is completed, or a workflow is rejected, right? Together, these components create a complete approval process. Documents flow through the hierarchy with proper routing and notifications. It's a complete system. So let's look at conditional approval routing. Say you have a purchase order workflow that checks the amount, okay? If the amount exceeds 10,000, it routes to the VP for approval. Otherwise, it routes to the manager. The conditional decision element evaluates this condition automatically. No user intervention needed. The document flows to the right approver based on your business rule, right? This ensures proper authorization levels and efficient approval. You don't need someone to manually decide where to route it. The system does it for you based on the logic you define. Okay, so there are 5 workflow elements you can use. Approval process routes to users for approval or rejection. Manual decision lets the user pick which branch to take. Conditional decision auto evaluates business logic. Automated task executes system logic. And manual task assigns work to a user. You choose elements based on your workflow needs, right? Need approval? Use an approval process. System calculates the next step. Use a conditional decision. User picks an option. Use a manual decision. So you mix and match these elements to build the workflow you need. Okay, so workflow association types control the scope. Company association means the workflow applies to one legal entity. This is useful when different companies have different rules, right? Global association means the workflow applies to all legal entities, useful for shared corporate rules. Other is for special cases, but it's rarely used. So choose your association based on your requirement. Single company rules, go with company. Corporate wide rules, use global. It's pretty straightforward, Just think about whether the rule applies to one company or all companies. Okay, so creating custom workflows requires a strict sequence. You really need to follow this, right? First, develop your components, the document class, event handlers, and approval provider. Second, create the workflow type in the AOT and bind your classes. Third, configure workflow steps in the designer. add approval processes, decisions, and tasks. Fourth, enable it on the source table and in the client. Fifth, deploy and test. Now, if you skip a step, the designer can't find the compiled classes and you'll get errors. Okay. So follow this sequence exactly. This is critical. I mean, you can't just jump around. Each step depends on the previous one being completed. Okay, so there are 5 performance monitoring tools you should know. LCS environment monitoring gives you a system-wide health view, CPU, memory, SQL performance, batch job history. Fiddler analyzes client to server HTTP traffic. Things like form load time, request latency, and payload sizes. Trace Parser shows you single process details like call stack, SQL statements, and durations. SQL Insights shows database level blocking, locks, and transaction weights. And activity monitoring shows user activity, session counts, user actions, and timeline, right? Together, these tools cover full stack diagnostics. You have visibility from the client all the way down to the database. Okay, so performance troubleshooting uses a decision tree approach. System-wide health issue, use LCS monitoring. Form loads slowly, use Fiddler. Code runs slow, use Trace Parser. Database blocking, use SQL Insights. Need a user timeline, use activity monitoring. Okay, so ask the right question and you'll get the right tool. This systematic approach speeds up your diagnosis. Instead of just randomly trying tools, you think about the symptom and pick the appropriate tool for that symptom. Okay, let me give you 5 best practices. First practice, use task recorder. It documents processes, enables testing and training. Second practice, write unit tests with SysTest. You get transaction isolation and code coverage tracking, right? Third practice, design workflows carefully with conditional logic and proper approval routing. Fourth practice, use the correct performance tools and diagnose problems systematically. And the fifth practice, test performance regularly so you catch issues before production. Okay. Discipline ensures quality. If you follow these practices consistently, you'll deliver high quality systems. Okay, so let's do a final recap of this topic. We learned that Task Recorder documents business processes and supports both interactive training through guide mode and automated testing through playback mode. The SysTest framework enables unit testing with transaction isolation and structured attributes. We reviewed workflow architecture, including approvals, conditional routing, and component associations, right? We also covered the main performance diagnostic tools, LCS monitoring, Fiddler, Trace Parser, SQL Insights, and activity monitoring, each one targeting a different layer of the system. Okay. Together, these tools provide full stack visibility. So you can diagnose issues anywhere in the stack from the client down to the database. Welcome to the closing summary, guys. So we've traveled a pretty comprehensive path through Dynamics 365 finance and operations development, right? From foundational cloud architecture all the way to advanced extensibility patterns, from basic X++ syntax to complex integrations, from role-based security to performance diagnostics. So this final topic, it brings everything together and helps you understand how all these pieces form a complete professional development framework. It's all connected. So we've traversed 8 complete modules together. Okay. Module 1 on ALM and DevOps taught you how the platform is deployed, versioned, and built. Module 2 on data modeling taught you to design efficient data structures. Module 3 on programming covered X++ and object-oriented principles. Module 4 on extensions taught you safe modification without breaking upgrades. Module 5 on forms and UI showed you how to build user interfaces that follow standards. Module 6 on integration taught you to connect external systems in both real-time and batch. Module 7 on reporting taught you to deliver insights through reports and analytics. And Module 8 on security and operations taught you to protect data and ensure quality. So together, there's a complete development curriculum, right? Everything you need to know. The platform foundation rests on 4 pillars, okay? So you've got cloud architecture, and that's how the system scales and deploys. Then you've got code organization through models and packages, version control that ensures team collaboration, and the build pipeline that automates compilation and deployment. Now, these pillars, they're not separate concerns, they're interconnected. So your code organization affects your branching strategy. Your branching strategy affects your build pipeline. Your build pipeline affects deployment. Understanding how all of these work together is really foundational. I mean, it's the basis of everything. Data and code form the core of any solution, right? So on the data design side, proper EDTs enforce type safety, tables organize your data logically, relations connect entities efficiently, indexes optimize query performance. Now on the code quality side, object-oriented principles create maintainable code, set-based operations handle data efficiently, exception handling prevents surprises, and naming conventions make your code readable. So when both your data and your code are excellent, the entire system performs well and scales reliably. Everything just works better. Modern extensibility philosophy is really central to professional development. Okay. So never modify Microsoft standard code, always extend it instead. Class extensions through chain of command add behavior, table extensions add fields, event handlers react to events. This separation ensures that when Microsoft releases updates, your code isn't affected, right? You can upgrade without fear. Now, this philosophy isn't unique to Dynamics. It's a modern software engineering best practice. Separation of concerns, clean dependencies, upgrade safety. That's what it's all about. User experience has three layers to think about. So first you've got forms, and these present data for entry and viewing. Follow the patterns like simple list, details master, list page. Users recognize these familiar structures, right? Then you've got navigation, and this guides users to what they need. So menu items, tiles, links, all organized logically. And finally, you've got dashboards, and these provide that executive overview. Role-based dashboards show relevant KPIs. So when all three layers are designed well, users have a professional, intuitive experience. They spend less time searching for features and more time actually doing their job, and that's exactly what we want. Okay, so let's talk about integration architecture. You've got four patterns here that work together really well, right? So first up is OData. Now think of this as your go-to for real-time data access. You need to query something right now. OData's got you covered with moderate throughput. Then there is DMF, which is basically your heavy lifter for bulk operations. We're talking high throughput when you need to import or export large volumes of data. Now, when you've got complex business logic that needs real-time calculations, that's where custom services come in. And finally, business events, they handle your asynchronous notifications. Perfect for event-driven architecture. The beauty here is that together, these four patterns cover literally every integration scenario you'll encounter. Real-time needs, batch processing, complex logic, event handling. Just pick the right pattern for what you're trying to accomplish, okay? So analytics in D365, it works across three distinct layers, and each one serves a different purpose, right? You've got SSRS reports at the foundation. These give you detailed business analysis where users can really drill down and investigate what's happening. Then there's electronic reporting with aggregate models, which powers your live KPIs and those configurable documents. What's great here is that users can customize templates themselves without needing a developer to help them every time. And at the top layer, you've got Power BI for self-service analytics. This is where your users can create their own reports and dashboards. When you put all three together, you get complete visibility into your business. Decision makers get their real-time KPIs, analysts get detailed reports for deep dives, and power users get self-service capabilities. It's all about making your data tell the story. Okay, so security architecture in D365, it uses three frameworks that complement each other really well. Role-based security is your first line. It controls who can use which features, right? And so your accounts payable clerk can't delete vendors, but your finance manager can post to the general ledger. Then you've got extensible data security, which filters data at runtime. Maybe that clerk only sees vendors in the specific group, not everyone. And table permissions, they control CRUD operations on fields. Some fields are read only, others you can update. What you're creating here is defense in depth, multiple layers protecting your system. Even if someone breaks through one layer, the others are still there protecting you. So quality and operations, they're all about ensuring production excellence, okay? Your testing strategy needs to cover multiple angles. Unit tests for your code, integration tests for features, and task recorder for both documentation and automation. Workflow automation is crucial too. It routes documents through the proper approval chains with conditional logic, making sure the right people see the right documents. Now for performance monitoring, you're using multiple tools here. LCS gives you system health, Fiddler helps with network issues, SQL Insights tackles database problems. And here's the key, continuous improvement. You create feedback loops where issues found in production actually inform your next development cycle. Optimization isn't a one-time thing, it happens iteratively. Okay, so here's the bigger picture I want you to see. These aren't just D365 patterns we're talking about, right? These are modern software engineering principles that have been adapted for enterprise applications. Separation of concerns keeps your code clean and maintainable. Metadata driven design makes your systems flexible without having to code everything. Extension over modification preserves stability. Defense in depth security protects your critical data. Performance optimization ensures scalability. Quality assurance prevents issues from hitting production. And user empowerment through self service analytics and personalization. Whether you're working with D365, SAP, Oracle, or any other enterprise system, these principles apply universally. This is professional software development. So, throughout this curriculum, we've highlighted common pitfalls that developers run into. Modifying standard code instead of extending it, that breaks your upgrades. Ignoring patterns creates an inconsistent user experience. Poor performance causes user frustration. Weak security creates breach risks. Not testing allows bugs to slip into production. But now you know how to avoid all of these. Extend instead of modifying. Follow the patterns. Optimize proactively. Layer your security. Test continuously, right? This knowledge prevents costly mistakes that you might have otherwise made. Okay, let me give you 6 key takeaways that summarize professional development. First, extend safely using proper extension mechanisms. Never modify standard code, right? Second, follow patterns, whether it's for forms, navigation, or security. Patterns create consistency and predictability. Third, think integration. Understand when to use OData, when to use DMF, when you need custom services, when events make sense. Fourth, secure thoroughly by layering multiple security frameworks. Fifth, test rigorously with unit tests, integration tests, performance tests. And sixth, optimize proactively by monitoring your systems and improving continuously. These 6 principles, when you apply them consistently, create professional solutions. So this is the closing summary. Guys, you've completed a comprehensive journey through Dynamics 365 finance and operations development. Okay, we covered architecture, code, extensions, forms, navigation, integration, reporting, analytics, security, and operations. Right? You now have knowledge of the complete development stack, from cloud architecture to performance diagnostics, from basic X++ to complex integrations, from role-based security to business event handling. So you have the knowledge framework, the patterns, the best practices, and the decision-making criteria to build production quality solutions for the MB-500 certification. Okay. So yeah, best of luck with your certification, and thanks so much for watching. I'll see you around.